everybody, good morning. Everybody, good morning. Yes, Yuvraj, Anu, Shahid. Yes, Lakshmi, I'm good. What about you guys? How are you guys? இன்னைக்கு ரெடியாடா 90 plus score guaranteed session da. Readyada everybody? Tell me, everybody ready-யா? Give me a fire quickly. Ready na give me and the energy எனக்கு வந்து புரியணும்டா. So இப்போ வந்து I will tell you. Okay, இந்த class ஓட construction எப்படிங்கறத I will be telling you. So first of all, we know that hardly வந்து 15 days தான் இருக்கு. So இந்த 15 daysல I am telling you guys, trust me, I'm telling you, இது வந்து என் promise தான். இப்போ வந்து இன்னைக்கு நீங்க வந்து you are spending this 9 hours in the sessionல I will be going for quick revisions. And the revisions எல்லாமே you can just go through it. அதுக்கப்புறம் question practice மட்டும் போதோடா. Okay, இந்த chapterல இருந்து question practice மட்டும் போதும். I am telling you 90 plus is possible for you in this 15 days. This is a promise. Okay, this is a promise from my end. So இன்னைக்கு you are going to watch my session. இன்னைக்கு complete-ஆ you are dedicating yourself for this session. இது வந்து ஒரு warm up. Okay, இந்த 15 daysல first day வந்து we will be covering the whole 12th grade syllabus. அதில் வந்து make sure பண்ண முடியும். Some chapters வந்து few chaptersல இருந்து few questions வந்து we can make sure da. அதனால தான் I'm telling you guys. So இன்னைக்கு வந்து just listen the whole class. அதுக்கப்புறம் நாளையில இருந்து you can just go for question practice. So இன்னைக்கு I will tell you first வந்து which chapter you feel more difficult in class 12. Tell me da. Which chapter you're feeling like, ma'am, in the chapter one, oh my god, ma'am, it's a hectic chapter. So on the madri edachu chapter irundha, please tell me da. Hema, it's all good. Abor, we are actually doing as a separate session, don't worry. PDF வந்து available இருக்கும், of course. Yes, I can see wave optics, ray optics, current electricity, modern physics. இது வந்து எல்லா chaptersமே இருக்குடா. So அதுக்கு முன்னாடி மறக்காம like பண்ணிக்கோடா and also share with your friends, okay? So we need 200 plus watching, okay வா? So அதுக்காக இப்பவே வந்து you can just share with your friends. ஏனா இந்த ஒரே ஒரு session போதும்டா. இந்த 15 daysக்கு வந்து you can just இந்த 15 daysல question practice பண்றதுக்கு இந்த ஒரே ஒரு session attend பண்ணா போதும். Okay? Targets like edu illada, நம்ம target வந்து இன்னைக்கு 90 plus mark. Okay, we are going for 90 plus marks. இதுதான் வந்து நம்ம target இன்னைக்கு. Likes எதுக்கும் target இல்ல, nothing else is there. Just we are focusing 90 plus marks. Okay, so இப்போ வந்து I'm telling you again and again, இன்னைக்கு இந்த ஒரே ஒரு session போதும். ஒரே ஒரு session will definitely change your entire physics preparation. I'm telling you, next 14 days, just focus on the question practice. 90 plus is for sure. Are you ready for this challenge? Are you guys ready for this challenge? Yes, Aisha, that is what I'm saying. 90 plus is possible. Okay, அதுக்காக இந்த session பார்த்துக்கோ. நாளையில இருந்து question practice. Okay, இன்னைக்கு கூட question practice இருக்கும். ஆனா we know பத்தாது இல்ல. We need to do maximum number of questions. So அதுக்காக தான் I'm telling you, everyone should go for question practice from tomorrow onwards. We will do the question practice in the channel also, so you can join that sessions. Okay, so now yes, zero la irundhalum paravalada, inneki session vandu point by point da. Okay, point by point na, it is actually something like, what should I say, இப்போ வந்து ஒவ்வொரு சாப்டர்லுமே இருந்து இம்பார்ட்டண்டா ஸ்டேட்மெண்ட் பேஸ்டு கொஸ்டின்ஸ் we can expect, numericals we can expect. அதுக்கு தேவையான பாயிண்ட் பை பாயிண்ட்ஸ் தான் இன்னைக்கு I have kept it here. Okay, so இதுல வந்து புரியற அளவுக்கு like we are not going to that descriptive, point by point இருக்கும். And the points just you need to note it down. அதுக்கப்புறம் you can just go for question practice. Okay, எல்லாமே இருக்கும். So I was just thinking like in the 3 chapters, okay, magnetism and matter இருக்கு, electromagnetic induction and alternating current. In the 3 chapters வந்து I will be going for a quick revision videos in the in a separate session. ஏனா இன்னைக்கு வந்து high weightageல இருக்கிற chapters முடிஞ்சதுக்கு அப்புறம் இந்த 3 chapters வந்து we will be do it as a separate one. Okay, So yes, Damodara, good morning. Scratch lerunde start. Yes. Okay. So ipo vande first we will be going with the chapter that is nothing but I think most of you feel like this chapter is the what to say very difficult chapter. Okay. So let us just start with ray optics. So in the ray optics chapter la first of all we will be discussing about the reflection of light. What we are discussing? The reflection of light. Okay. So yes. So reflection of light na we know that adula vand laws of reflection irukke illa. What is laws of reflection? Quickly tell me da. Quickly tell me what is laws of reflection. So ipo vand idudha vand nama surface. So in the surface la I will go for a perpendicular. So definitely what will happen da? What will happen? So this will be making an angle I, right? In the idudha vand in the white line da in the incident ray. So incident ray will make an angle I with the normal and that is what our incident angle. Purinjidada? So adukapram definitely what will happen? There will reflection. I mean in the yellow line da in the reflected ray. So now I'll be marking in the reflected ray will make an angle with the normal. Adudha vand R. Now tell me what is laws of reflection? Very good Oliva. It is nothing but angle I will be equal to angle R, which means incident angle and reflected angle banda it is going to be equal. Purinjidada? Everybody understood what I said? Incident angle and reflected angle banda it is going to be equal. Now the thing is like I know that in the frame ila incident ray irukke, reflected ray irukke, normal irukke. So idellame vanda same plane la da irukum. So idudha vanda laws of reflection. 2 points da irukke. First one vanda incident angle and the reflected angle vanda it is going to be equal. Second point enada in the incident ray, in the reflected ray and the normal will be in the same plane. Understood everybody? So now another question which will be coming from here is what is the deviation? Okay, what is the deviation? Deviation என்னடா? So let us say இப்போ வந்து we are traveling. Okay, so இப்போ வந்து straight ஒரு road இருக்கு. Actually வந்து we need to continue in the straight road. ஆனா suddenly I'm just taking a deviation. புரிஞ்சுதாடா? Straight road க்கு instead I'm taking a deviation. So basically what is that? In the straight, instead of the straight line, you are just changing your direction. Correct? So அந்த மாதிரி பார்த்தேனா actually வந்து இந்த white line இல்லையாடா இதுதான் வந்து நம்ம incident ray. So actually வந்து it is supposed to go like this. Correct? It is supposed to go like this. ஆனா actual ray இந்த reflected ray எப்படி இருக்கு? இந்த yellow line தான். So இதுதான் வந்து the deviation happened. புரிஞ்சுதாடா everybody? What is deviation? What is deviation? It is nothing but inga oru incident ray irukke and the incident ray actually வந்து இந்த blue line da follow பண்ணனும். Correct? It is actually supposed to follow a blue line. ஆனா we know that there will be a reflection. அதனால இங்க ஒரு deviation இருக்கும் delta. Okay? Okay, fine. So now we got it. The deviation is nothing but okay. So now the thing is like deviation we got it. Now I want the expression for deviation. What is going to be the expression for deviation da? Deviation na how I can write it? Deviation na eppadi I can write it da? Please let me know. Deviation na. So total இது வந்து ஒரு straight line இல்லடா. இது வந்து ஒரு straight line da. அப்படினா இந்த total angle என்ன? Total angle என்ன ஆக போறே? What is going to be the total angle? Can I say அது வந்து it is going to be pi? Can I say it is going to be pi? So pi minus deviation na actually வந்து we know this is I, this is R and this is what deviation, which means pi which is equal to I plus R plus delta. Can I write it like this? Yes or no? Very good guys, very good. So pi is equal to I plus R plus delta. Now we also know that in the I and R one the same da. Correct? Appadina I am writing 2I plus delta. In the total angle one the I plus R plus delta da. Appadina, definitely I am rewriting this equation. Pi is equal to 2i plus delta. Now tell me what is delta? What is delta? It is nothing but pi minus 2i. What is I? What is I? It is nothing but the incident angle. புரிஞ்சுதாடா? It is nothing but the incident angle. Incident angle na ennada? Incident angle na enna? The angle between incident ray and the normal. Don't be get confused. Yeah, sometimes question la they will be giving this angle. Okay, they will be giving this angle. Okay, இது வந்தா it is not the incident angle. Incident angle na எப்பவுமே incident ray and the normal. Okay, அதுக்குள்ள இருக்கிற angle தான் இந்த incident angle. புரிஞ்சுதாடா everybody? Everybody understood na? Give me a quick fire. Everybody give me a quick fire da. Yes, perfect, perfect, perfect. Yes. Yes, very good Arun, very good, very good, very good. So இதுதான் வந்து பேசிக்கா இருக்கு. Okay, so இதுல வந்து laws of reflection we have discussed, and அதுக்கப்புறம் we have discussed about the deviation, and now we got the base idea. Next வந்து I'm just focusing on the plane mirror. Okay, and adukku munnadi we have normal incidence and grazing incidence. Okay, what is this normal incidence? What is this normal incidence? Tell me, what is normal incidence? Normal incidence na any surface arkattum. Okay, whether it is a plane or any curved surface, whatever it may be, normal incidence na actually vande in the surface ku perpendicular it will fall. Okay, so it will be perpendicular to the surface. Even if it is a curved surface also, it will be like this. Okay, it will be perpendicular to the surface. Now, can you just tell me, in the case, what is going to be the incident angle? What is going to be the incident angle in this case? Normal incidence. What I said, this is the surface perpendicular, it will come. Appadina, my question is, what is going to be the incident angle in this case? What is the incident angle? Can you just give me the answer? Very good, Sudarshan, right? Very good. It is coming as 0. Appadina, tell me what is reflected angle? Reflected angle kuda, it is coming as same according to the laws of reflection. So we will be get it as angle I will be equal to 0, and definitely angle R also coming as 0. Purinjidada. So this is what the normal incidence, whether it is, okay, whether it is what to say, இது வந்து ஒரு curved surface இல்லனா ஒரு plane surface இருந்தாலும், this is what actually happening. Okay, this is what actually happening. Whether it is curved or plane, normal incidence will be coming as, the incident angle will be coming as 0, as well as the reflected angle also coming as 0. Purinjidada? So now tell me, in this case, what is the deviation produced? In this case, what is the deviation? Can you give me the answer? What is the deviation in this case? Quick tell me da. What is the deviation in this case? Thank you, Lakshmi. Thank you so much. What is the deviation? Very good, Sudarshan. It will be coming as 180. Yeah. Why we are saying? Because we know that in the incident ray it is supposed to go like this. Correct? It is supposed to go like this. Now what exactly happening? What exactly happening? Idu reflected in the same way. Appadina, this is going to be the deviation. Okay, this is going to be the deviation, and which will be coming as 180 degree. Okay, so now very good. So now I'm going for the grazing incidence. Idellame vandu konjam fancy names da. Okay, so grazing incidence. Grazing incidence na actually வந்து let us say இப்போ வந்து ஒரு curved surface இருக்கு இல்லனா ஒரு plane surface இருக்கு so அதுல வந்து we know இந்த பாயிண்ட்ல இதுதான் வந்து இதோட normal கரெக்ட்டா இதுதான் வந்து normal now the light is actually falling tangential to it, which means இப்படி தான் it will come. Okay, incident ray is actually coming like this. Now tell me what is the incident angle here? What is the incident angle? What is the incident angle? In the case, இப்போ வந்து the light ray is actually coming tangential to the surface. அப்படினா incident angle, very good Jai, it is coming as 90 degree. Now quick tell me what is the reflected ray? What is the reflected angle? What is the reflected angle? Ma'am, laws of reflection theriyada? That is nothing but 90 degree, ma'am. Correct? That is also coming as 90 degree. Now tell me da, in the case la, okay, in the grazing incidence la, deviation na enna? Deviation na enna? Grazing incidence la, deviation na enna? What is the value of deviation? Very good, Sudarshan. I can get the answer. It will be coming as 0. The deviation will be coming as 0. Very good. Super, guys. You are on the track, okay? No worries. In the ray optics is not going to torture you people now onwards. Very good. Perfect. So, delta in the deviation it will be coming as 0. Yena, again, we know the reflected ray will also go like this. Appadina, deviation, angle of deviation, what is it is indicating? It is nothing but the incident ray supposed to go on a track. What is the deviation? In the case, it is a straight line. Adinala, no deviation. So, it will be coming as 0. Understood, everybody? Got it? So, now the basic part is done. Now, let us just quickly go for the plane mirror. Okay. Plane mirror na enna? Actually, we will be, okay, Games Murthy, right? Sorry, Ganesh Murthy. Yeah, Ganesh Murthy. Actually, what is this deviation? இப்போ ஒரு incident ray இருக்கும்லடா, இந்த incident ray without a deviation, if it is going na, it should be in a straight line, correcta? ஆனா the rest of the case la, in the reflected angle I mean there will be a reflected angle. ஆனா இந்த case la, இதுக்கு deviation கிடையாது. It is moving as a straight line, correcta? அதனால தான் it is happening like this. Okay va? So now again I just wanted to let you know, guys. இப்போ if you understood na, give me a heart. Okay, always better than you are just saying understood and all. If you're giving me hearts na, it will make me so happy. Okay, so just idu mind la vechiko and marakama like kuda paniko. Also share with your friends. Yena inneki complete we are going to discuss a lot of high weightage chapters da. So idilirunda, if you are dedicatedly sitting for this session na, next 14 days la, you can just focus on the question practice and whatever I have written over here, adu note panikoda. Exam time la kuda just focus on this will help you. Okay, break start pannalada. How I could give break? No way. Ray optics mudinjadukku appra I will give break. Okay, how much weightage in the chapter ku actually good weightage irukkuda. So usually 3 questions kuda we can expect from this ray optics, and the 3 questions konjam difficult ah irukum. Okay, what இப்போ if you are just translating to Malayalam na, that is not going to be a proper sentence. Google will also cheat you da. Okay, master the blaster. Yes. Yeah, definitely da, Oliva, we will do for the 11th also. Don't worry. Okay, so now the thing is like let me tell you da, whenever I mean in the session la, in the chat la, I'm not going to be much interactive. Okay, so just I will be more concentrated on the content. Yeah, few students in the kapparam later also they will come and they will join. Adinala tha. Okay, so now listen. Plane mirror da we are just going to discuss. Plane mirror na Jay, you can expect 90 plus. Just follow this channel. 90 plus, I'm promising you. Okay? Waiting for logic gates. I'm also waiting for logic gates. Okay? So just listen. Come back. Okay? So plane mirror na usually in the makeup ellam podumbodhu we will look at the mirror, right? And boys they will just fix their hair like this. So adha in the plane mirror. Okay, and the plane mirror la you can just go for some of the important terms like focal length. Focal length na adu infinity ah irukum. Okay, focal length for a plane mirror infinity ah irukum. Next focal length infinity na, radius of curvature kuda it will be coming as infinity. புரிஞ்சதாடா? ஏனா அது plane da. So in the point note பண்ணிக்கோ, and many years la இது statement they have asked. Okay, so in the focal length infinity da, and the radius of curvature kuda infinity for the plane mirror. Another thing is like let us say I'm talking about the image distance and the object distance. இது வந்து ma'am additional you don't need to tell and all. ஏனா daily வந்து we are seeing, right? Okay, so tell me da, what about the object distance and image distance order relation? Tell me quickly, image distance and this object distance, what is the connection between them? So for a plane mirror இது வந்து எப்பவுமே ஈக்குவலா இருக்கும். இந்த மிரர்ல இருந்து ஆப்ஜெக்ட்ல இருக்கிற டிஸ்டன்ஸ் and இந்த மிரர்ல இருந்து இமேஜ்ல இருக்கிற டிஸ்டன்ஸ் வந்து எப்பவுமே சேமா இருக்கும். Now another question, what about the size of the object? இப்போ வந்து if I'm just showing this to the mirror, okay, if I'm showing this to the mirror na, what will be the size of this object and size of the image order relation? What is going to be that relation? It is again coming as same. So plane mirror na, few things instantly it should come on your mind. What are the things? What are the things? In the focal length வந்து infinity ma'am, radius of curvature வந்து infinity ma'am, image distance and object distance வந்து same ma'am, image size and object size வந்து same ma'am. அதை விட you should also know, நீங்க பார்க்கிறது வந்து ஒரு virtual image தான், and அந்த image வந்து actually erect இருக்கு, which means it is not inverted. Okay, so அந்த plane mirrorல பார்க்குற imageோட property என்னன்னா, you can say that அதோட magnification னா என்னடா? Okay, இப்போ வந்து இந்த object இவ்வளோ size இருக்கு, let's say 5. Okay, so இப்போ வந்து இந்த image வந்து 10 இருந்து I can say 2 times magnified இருக்கு. Okay, ஆனா வந்து plane mirrorல we know that இப்போ இது வந்து 5 cm இதோட lengthனா அது வந்து same size தான் show பண்ண போறேன். அப்படினா tell me da, what is going to be the magnification? What is the magnification? Very good Jay, very good. The magnification வந்து it will be coming as 1. Very good. Magnification for the plane mirror வந்து it will be coming as 1. So next வந்து another thing, you also know it. Okay, daily பார்க்குறேன் ma'am. So இப்போ வந்து right hand if you are raising na, இந்த mirrorல பார்க்கும்போது left hand மாதிரி தெரியும். So அதுதான் வந்து we will be call it as lateral inversion. So அந்த point கூட you can just note it down. Plane mirrorல the lateral inversion will happen. And also another important point which we should study is, let us say இப்போ வந்து I'm standing in front of the mirror. Okay, just listen carefully. இது வந்து directa they have asked. Okay, அதனால தான் சொல்றேன், please note it down da, மறக்காம note பண்ணிக்கோ. So what I said, when I'm talking about the what is இப்போ வந்து எனக்கு வந்து complete full body இல்லனா இந்த வந்து I wanted to see myself completely in the mirror. Okay, so இப்போ வந்து இந்த ஒரு பென் இருக்கு, இந்த பென்னோட completely I wanted to see in the mirror na, what must be the mirror ஓட size? Okay, so mirror ஓட size என்ன இருக்கணும், அதுதான் வந்து I'm going to discuss. அது எப்பவுமே வந்து இந்த object ஓட half இருக்கணும். புரிஞ்சுதாடா? So that is what I have written over here. The size of the plane mirror required to see the full image. Okay, full image பார்க்கணும்னா மிரருக்கு வந்து அந்த objectோட sizeோட half length இருக்கணும். புரிஞ்சுதாடா? So size of the mirror வந்து it is nothing but h/2. புரிஞ்சுதாடா? Yes or no? Please let me know quickly. So plane mirrorல இதுதான் வந்து another important fact that you should know. Next வந்து rotation தான். Okay, next வந்து rotation தான். For example, just focus over here. இவ்ளோ வரைக்கும் புரிஞ்சுதாடா? இவ்ளோ வரைக்கும் any confusion இருந்துருச்சுனா please let me know. Okay, the heart indicates you got it. Okay, thank you so much guys, thank you so much. Okay, so இப்போ வந்து what I'm going to discuss is, புரிஞ்சுக்கோ, let us say initially வந்து நம்ம mirror வந்து இப்படி தான் இருந்துச்சு. ஓகேவா? no confusions. இது வந்து இதோட நார்மல் தான். ஓகே, பரவாயில்ல, சர்ஃபேஸ்க்கு பெர்பெண்டிகுலர்னா அதுதான் வந்து மேம் இந்த நார்மல் எனக்கு கரெக்ட்டா தெரியும். Now this is the incident ray which is actually making an angle alpha with the surface. புரிஞ்சுதாடா? Now tell me in the reflected ray இல்லையாடா, and the reflected ray will make an angle, definitely it will make an angle with the surface, right? And the value என்னடா? Please let me know what I said. இப்போ வந்து இந்த incident ray surface it is made an angle alpha with the surface. அப்படினா tell me the reflected ray and the surface will also make an angle. அந்த value. Question Jai, focus on the question. What I asked, the angle between reflected ray and the surface. Reflected ray and the surface. In the angle that I'm asking. Tell me, hey, don't get confused. What is this angle? Very good, Jay. It is coming as alpha. Yes, Sapita, right? Yes, this will also come as alpha. Correct? Why so? Why so? Yeah, we know that idu vandu alpha na, this is coming as 90 minus alpha. Yeah, this is perpendicular to each other. Correct? அப்படினா I can say that in the reflected ray கூட, okay, reflected ray கூட, it will be coming as 90. Reflected angle will be 90 minus alpha. இதுதான் வந்து I have told you in the question paper la, they will be giving, instead of this incident angle and all, they will be giving you the angle with the surface. So அந்த momentல you will be get confused, right? அதுதான் வந்து அவங்களுக்கும் வேணும். புரிஞ்சுதாடா? So that is what I'm saying. So just understand, இப்போ இந்த questionல surface the incident ray is making an angle alpha. அப்படினா இந்த reflected ray will also make an angle alpha with the surface. புரிஞ்சுதாடா? Everybody got it? Yes or no? ஆமாடா, secret தான். Okay, so இப்போ வந்து NTA secrets எல்லாமே வந்து இந்த sessionல we are going to reveal. Okay, so புரிஞ்சுதாடா? Alpha வந்து we got it. Now what I'm doing now, so இதுதா வந்து initial surface. Okay, initially we kept it like this. Now I'm rotating for an angle. Okay, now I am rotating for an angle theta. Okay, theta angle rotate பண்ணியிருக்கேன். புரிஞ்சுதாடா? So theta angle வந்து rotate ஆருக்கு. அப்படினா how much? Okay, according to this surface. Okay, in the previous old position of the mirror compare பண்ணும்போது how much it is rotated? How much it is rotated? Can you give me the answer? Can you give me the answer? இப்போ வந்து initially இப்படி தான் இருந்துச்சு. ஆனா now I have rotated this much. அப்படினா my question is, in the reflected ray எவ்வளோ rotate பண்ணிட்டு இருக்கேன்? Okay, it will be rotated for 2 theta, which means theta angle rotate பண்ணிருக்குனா I can say that reflected ray will rotate 2 theta. புரிஞ்சுதாடா? Everybody, very good, it will be coming as 2 theta. So they will be giving a question, a mirror is rotated for an angle 45 degree. அப்படினா how much the reflected ray is rotated? So quickly tell me the answer. What is going to be the answer? What is going to be the answer? It is, ma'am, definitely இப்போ வந்து 45 degree na, reflected ray will be rotated for 90 degree for sure. ஏனா theta rotate ஆருக்குனா reflected ray will be rotate 2 times of it. அப்படினா 90 தான் answer வரும். புரிஞ்சுதா? Very good. So now another point, இப்போ வந்து ஒரு plane mirror is rotated na, அந்த rotating, அந்த rotation happen for the reflected ray according to the old position of the mirror will be 2 times theta. So here we will be getting, in the case la 45 into 2, that will be coming as 90 degree. Got it, everybody? Marikama like panikoda, share maximum with your friends, and also focus on the session completely. Okay, ஏனா இந்த ஒரே session போதும்டா. The rest of the days just focus on the question. Okay, question practice மட்டும் போதும். அதனால தான் I'm telling you. Okay, perfect. Yes. Very good. Thank you so much, guys. So, இப்போ வந்து we understood about the another point. It will be rotated for 2 theta angle. Next வந்து, இப்போ வந்து you guys know it. Let us say if we are keeping 2 plane mirrors at a particular angle na, definitely it will produce multiple images. இப்போ வந்து எனக்கு தெரியணும் எவ்வளோ images will be formed in. புரிஞ்சுதா? So what we are now looking for, இப்போ வந்து 2 mirrors இருக்கு. 2 mirrors are 2 plane mirrors kept at an angle theta. Okay, kept at an angle theta. So definitely I wanted to know how many number of images is produced. So அதுக்காக 2 equations இருக்குடா, 2 scenarios இருக்கு. Okay, so let us say இப்போ வந்து if I am doing 360 divided by theta, what is theta? What is theta? Tell me what is theta. Quickly tell me what is theta. Theta na in the 2 plane mirrors kulla angle. புரிஞ்சுதா? So இப்போ வந்து இந்த 2 plane mirrors I kept it like this na, அதுக்குள்ள ஒரு angle இருக்கும். அதுதான் வந்து theta. So இப்போ வந்து 360 minus theta. If I'm doing 360 minus theta na, definitely either I will be getting an even number or odd number. Correct? Yes, very good, Jay, very good. So what I said, 360 by theta வந்து either it will be a odd number or it will be a what? It will be a even number or an odd number. Understood? Now the thing is coming here. Okay, இப்போ வந்து if I'm keeping Okay, இப்போ வந்து இதுதான் வந்து two plane mirrors. This is the angle bisector. Okay, angle bisector na அந்த angle half we will be cutting, right? So இப்போ வந்து இந்த object if I am keeping in the bisector, note பண்ணிக்கோடா, many students வந்து mistake பண்ற ஒரு topic தான், அதனால தான் I am telling you. So two plane mirrors இருக்கு, kept at an angle theta. இப்போ வந்து if I am placing an object in the angle of bisector, so you will be getting 360 by theta. Either it is odd or even, the number of images, okay, number of images will be 360 by theta minus 1. Understood the statement? Yes or no? Give me a heart if you understood what I said. இப்போ வந்து இந்த angle bisectorல தான் இந்த object இருக்கு. அப்படினா definitely first thing you should do is 360 by theta. அது பண்ணும்போது you will be getting an odd number, இல்லனா ஒரு even number தான் you are going to get. அப்படினா whatever happens, even or odd, definitely to get the number of images, you should go for 360 minus theta minus 1 da venum. புரிஞ்சுதாடா? Everybody got it? Yes or no? Quickly tell me da, yes or no? Yes, very good, very good. So இப்போ வந்து I'm not keeping in the bisector, I'm just keeping somewhere else. புரிஞ்சுதா? I'm keeping somewhere else. அப்படினா even number na same 360 by theta minus 1. ஆனா இந்த கேஸ்ல whenever you are doing 360 by theta, you are getting an odd number. Even number na no confusion, same equation da. Okay, ஆனா இப்போ வந்து if you are getting odd number na, okay, if you are getting odd number na, theta value will given da. Okay, and the plane mirrors kulla irukra angle வந்து they will give, otherwise idellame வந்து we cannot find it na. Okay, so அப்படினா definitely the number of images kuda it will be coming as 360 by theta. Okay, only the confusion is coming only when we are placing the object any point other than the angle of bisector. புரிஞ்சுதாடா? Give me a heart if you understood. Quickly give me a heart da. Everybody note பண்ணனும்டா, இதெல்லாமே வந்து note பண்ணனும். Okay, 360 by theta பண்ணும்போது sometimes you will be getting 5, sometimes you will be getting 6. Okay, that is depending upon the angle. Okay, so no way. Okay, which slide da? Okay, so this one I guess. Okay, so idhula vandu in the angle bisector lallena what will happen 360 by theta odd aranda mattum, even na again number of images vandu idudha, ana odd vandena 360 by theta da number of image. Perfect da, perfect, so cool. So in the plane mirror la important ana points ellame vandu we have discussed. All the points which I have mentioned here is very important. So let us just quickly go through the properties, or let's say the important points regarding the plane mirror. First vandu focal length vandu enna irukanumda, focal length for a plane mirror vandu it is infinity, and the radius of curvature vandu infinity. And what about the image distance and object distance? Tell me da, what is the image and object distance order relation? Adu vandu equal ah irukum. Perfect, yes, very good. So ipo vandu size of the object and size of the image vandu it will be again coming as equal. Perfect. And another one, the property of the image na, idu vandu eppovume virtual ah irukum, and also it will be always erect ah irukum. Next one vandu another property, lateral inversion, so that also we know. And when we need to see the full image of the object na, and the mirror size must be, tell me da, what must be the mirror size? Tell me everybody quickly. If you need to see the full image of the object, அப்படினா what must be the object or mirror order size enna irukanum? What is the, yes, very good Yuvraj, it will be h by 2. Yes, very good Shahid, that is h by 2. Very good. So next one is nothing but whenever we are just rotating the mirror now. Okay, when we are rotating the mirror now, the reflected ray will rotate for, tell me what will happen? Reflected ray will rotate for If it is rotated for an angle theta, na, what will happen to the reflected ray? How much it will rotate? Very good, Savida. Very good. It will be 2 theta. It will come perfect. Okay. And next one, if you are placing 2 mirrors with an angle theta, then definitely they will ask the number of images. So first you should do 360 by theta. So adila odd or even. If you are keeping the object at the bisector, na, number of images la, no confusion. 360 by theta, we already found it, minus 1 the number of image. And now if we are keeping any other point other than the bisector, na, even na ennada, tell me, for even, okay, if you are getting 360 by theta as an even number, tell me da, what is going to be the number of images? Very good, it will be 360 by theta minus 1 da. Ana, in the 360 by theta, if it is coming as odd, na, what will happen? What will happen? Very quickly tell me da, what will happen? What will happen? It will become just 360 by theta. Very good. So, this is the first level we should understand. Next one is velocity part. Okay. So, now a few things. I mean, whatever I have written over here, you guys know it. Okay. So, very good. Everyone has given the right answers. I can't see the messages because it is going quickly. Thank you so much for the response. If you are just giving answers, I will feel like, okay, whatever I am teaching you, you are getting it. And the confidence, I will be getting some energy. So, always maintain this rapport. I can also maintain this energy. Okay, perfect. So, now quickly we are going for the velocity part. Okay, thank you guys, thank you so much. Okay, even sometimes I forget, but you people are remembering about the heart. Thank you so much. Okay, so now the thing is like, we just need to know the velocity. So, now mirror mirror. Okay, so now mirror. So, in the mirror, first one the object. Okay, so now what I'm going to do, I mean, in the point mirror the stationary. Purinjiko, what I'm saying, in the mirror the stationary. So now, focus over here. So, now the mirror stationary. Now, I am moving with the velocity u. Okay, let me just take it as velocity as u. Okay, not the object distance, don't get confused. Now, we are just talking about the velocity, but we are just going to discuss. Okay, va? Marakama like paniko. So now I am moving with a velocity u. What is the velocity of the object? U da. What is u? Velocity of the object. Now my question is, what is the velocity of the image? What is going to be that? Just imagine, okay, and the makeup under time, you are just very late. So you will be taking something from here and you are just walking with some, speed, and you will be just putting the eyeliner and everything. And the moment, just go recall. Okay, if you are just sitting in your home, just quickly go and just let me know what will be the image or a speed. It will be same. Okay, ana direction the opposite. Object move and image it will be coming in the opposite direction. So adanala direction wise we can say that image order object order speed velocity equal to minus. Okay, minus da irukum. And the minus represent pandrathu and the direction the opposite irukku. Understood, yes or no? Give me a heart if you understood. Yes, same but different. Yes, Asmita, perfect. Okay, so next one innum simple irukku. Okay, innum simple irukku. Ipo the mirror started moving. Okay, so definitely in the questions ellame complicated aakanumla. So adukkaga what they are doing, in the mirror is actually moving in this way. Okay, mirror is actually moving in the vertical plane. Purinjida? It is actually moving in this way. So, anta momentilla, focus paniko, anta momentilla what is happening? In the mirror is actually moving in the vertical direction. In the object order and the image order, speed change irukuma illaya. So, idhukku simple, I will give you an example. So, quickly you can give me the answer. Another secret da, hama, correct. So, let us say, if the river is flowing. Correct? So, on the moment you will see your reflection on the river, right? Do you, I think if you are just, sometimes if you are going to your native place and all, you can see the river is flowing and you will play in the river. So, now, just focus over here. What is exactly happening? I am just standing on the shore and I am just observing my reflection. river is flowing. Okay, river is flowing. So, but my question is, what about the speed of the reflection you are seeing there? Is it changing? Yes or no? Quickly tell me. Is it changing? Yes or no? Yes or no? Quickly tell me. I want the answer quickly. Yes, very good, Kavin. Very good. It is no. The answer is no. And the speed of the object வந்து change ஆகாது. Same தான் இங்க இருக்கு. Okay, object வந்து actually move பண்றது இந்த directionல இருக்கு. And mirror வந்து இப்படி move பண்ணாலும் அந்த speedக்கு வந்து there is no change. Understood? So vertical motion. இப்போ வந்து இந்த mirror is actually going for a vertical motion. Speed will be remains the same. புரிஞ்சுதாடா? Everybody got it? Everybody got it? Yes or no? Yes or no? Yes or no? Yes or no? மறக்காம லைக் பண்ணிக்கோ நவ்யா and others. Okay, so இப்போ வந்து we got it. Next one. Okay, imagine the mirror is actually coming towards me. Okay, mirror is actually coming towards me. அந்த டைம்ல இமேஜோட ஸ்பீட் என்ன இருக்கும்? புரிஞ்சுதாடா? புரிஞ்சுதாடா? What is my question? இப்போ வந்து இந்த mirror is actually approaching. Okay, so I am also moving, mirror is coming to me na. What is the image oda speed? அது வந்து 2 times of the object oda distance. I mean object oda speed இருக்கும். Okay. Of course. Mirror move பண்ணோம்னா definitely அதுல ஒரு ghost இருக்கும்டா. So just imagine, instead of mirror we can say ghost. Okay, so if the ghost is actually coming towards you, na, what will happen? Unga image is actually coming with a speed 2 times the object oda speed. Purinjidada? Everybody understood? Yes or no? So now the thing is like, in the ghost konjam kuda what to say, wanted to make it little bit more harder. Okay, so in the moment in the ghost enna pannanumna random direction la it will move. Okay, it is not just coming in this way, it is not just coming in the vertical direction, ஏதாச்சும் ஒரு random directionல போக போறேன்டா. So what will happen? So what will happen? Okay, not object வந்து stationary இல்ல, objectக்கு வந்து speed இருக்கு u. அதனால தான் இமேஜோட speed வந்து we are saying 2u, right? Okay, so now we are making this little bit more complicated. Few things we have discussed. Now just focus over here da. So here the object is moving in a random direction. Idudha vandu namma mirror. Okay. Okay, so idudha vandu namma mirror. So mirror kuda, mirror which direction it is moving, any direction it can be. So now this time it is actually coming in this direction. Idudha vandu mirror oda velocity. So obviously inga vandu image irukum, இந்த இமேஜுக்கு கூட ஒரு velocity இருக்கும். So that is what vi, இதுதான் வந்து vo. So இந்த மாதிரி questions கிடைச்சேனா first வந்து நாம என்ன பண்ணணும்டா? What is the, so u is not speed of mirror, u is the speed of mirror, sorry, u is the speed of the object. Okay, not mirror. Okay, so now just focus. Okay, so இப்போ வந்து இதுதான் வந்து நம்ம complicated scenario. So இது வந்து இந்த velocity வந்து 2 dimension னா first வந்து உங்க மைண்ட்ல என்ன வரணும்டா? What is the first thing which is coming in your mind? Tell me quickly. What is the first thing which is coming in your mind? Yes, everybody tell me. இப்போ வந்து ஒரு 2 dimension கிடைச்சேனா first வர போறது it is nothing but the vector components ஆக்கணும் இல்லடா. So now I am going for making the components. So இது வந்து VO perpendicular. Okay, so இது வந்து VO parallel, which means the perpendicular and parallel component. Exactly the similar way, inga kuda there will be VM perpendicular, VM parallel. So inga kuda there will be another one, VI perpendicular and VI parallel. Got it, everybody? Okay, mirror is also moving, object is also moving, obviously image will also move. So in the case everybody is getting, I mean everybody understood the diagram, yes or no? Give me a heart if you understood quickly da. Likes vandu innum kammiya irukenda. I don't know why you people are becoming so selfish in case of this likes. Tell me. yes, yes, all the, I mean, இங்க இருக்கிற எல்லாமே வந்து random motionல போயிட்டு இருக்கு. So first வந்து we made into components. Okay. So இன்னும் வந்து question என்னன்னா they might be asking any type of question. ஆனா நாம வந்து we will study only one equation for this. Okay, we will only study one equation for it. Whatever be the question comes, we don't care about it. We will only care about one equation, and the equation use panni you can go for solving any of the question. So adukkaga irukkiradhu enna, definitely we know that ipo vandu in the velocity, okay, in the object ku velocity irukke and in the image ku kuda velocity irukke. So parallel components vandu we are not going to touch that. Now think about the perpendicular components. Okay, perpendicular components. Just focus here, da. Now I am going to think on the perspective of mirror. Okay, ipo vanda and the ghost nanda. Okay va? So ipo vanda and the ghost nanda. Appadina just think, da. Now even with respect to me, which means with respect to the mirror, the object is coming closer with the velocity VO perpendicular. Correct? So for the, according to the mirror, the object is coming with the velocity VO perpendicular. And exactly same way the mirror வந்து இப்போ வந்து இந்த image பார்க்க போறேன். So definitely according to the mirror, it will be coming with a velocity VI perpendicular. அப்படினா இந்த கேஸ்ல I can say that the velocity of object with respect to mirror, only the perpendicular component, will be equal to velocity of image with respect to mirror, that is again the perpendicular component, will make a relation like this. In the relation mattum podum, which means the relative velocities of object and image with respect to mirror will be equal but opposite in direction. Understood? Everybody getting it? What I'm telling right now konjam complicated ah irukke. Repeat pandradhukku no issues da. I will repeat as much as times you are asking. No worries on it. Just focus over here. Ipo vanda whatever be the question vandena, just focus on one equation. Okay, ennada and the one equation, it is nothing but the velocity of object with respect to the mirror, only the perpendicular component. Okay, only the perpendicular component, and the velocity of image with respect to the mirror. Okay, relative velocities basically. Okay, the relative velocities of mirror, the object and image with respect to mirror will be equal and opposite. Okay, adu vandu consider panna vendiyadhu illa Sabida. Just focus on this one. Okay, in the one equation podumda, the rest and the in the velocity related arikra ella questions me vandu we can solve it. So now the thing is like, what is VOM perpendicular? So relative velocity, ipo vandu if I am saying VAB, now what you will say? What is VAB? What is VAB? It is nothing but VA minus VB. Correct? It is nothing but VA minus VB da. Appadina. Okay, we will do the question also. Don't worry. Okay, so on the time you will get more clarity. Yena idu vandu relative motion irukke, ray optics irukke, ellame vandu it is a chaos. Adinala tha paravilla. Okay, so now VA minus VB da. Correct? So on the madrina, tell me now, what is this VOM perpendicular? Can you just give me the expression for it? In the relative velocity na enna? It is nothing but VO minus VM. Idellame vandu perpendicular component. Am I right or wrong? Which is equal to minus VI perpendicular minus VM perpendicular. Am I right or wrong? Is this velocity is minus because direction vandu opposite irukkulla da. Adinala tha. Okay va? So now this is the expression. Everybody understood this expression. Give me a heart if you understood. So what I did in the VOM perpendicular, அது வந்து I have what to say and the relative velocity equation use பண்ணி I have expanded it. கரெக்ட்டா? So இந்த சைடுல கூட மைனஸ் இருக்கு and VIM னா VI perpendicular minus VM perpendicular இருக்கும். Perfect. Okay. So இப்ப வந்து now the thing is like இந்த part I'm going to rewrite again. VO perpendicular minus VM perpendicular which is equal to minus VI perpendicular plus VM perpendicular. I'm just multiplying the negative side. Okay. V minus V allada. V minus V enge we have written nowhere. Okay. So now just focus over here. So idha vanda right now the expression. So maybe they will be asking the question velocity of the object. Okay, adha vanda they will be asking. Appadina you can just create an equation from this. Ipo vanda sometimes they will be asking the velocity of mirror. Adula kuda you can just find the equation from it. Understood? So in the ore equation podum the relative velocities of the object and this image with respect to mirror will be equal and opposite. In the ore relation use panni whatever be the given data you can just go for this. Okay, diagram onwards. Oh my god. So VO in the object oda velocity da, idu vandu image oda velocity da, idu vandu mirror oda velocity. Adala vandu we didn't do anything. Okay, we didn't do anything. What we have done, we just made into components. So adukku vandu or perpendicular component and parallel component irukum. Avlodha irukke inda. Yes, very good Arun Prasad. The equation vandu perfect. Okay, so ipo vandu what I said, so idukku vandu perpendicular and parallel component adudha vandu diagrathila irukke. Okay, adu vandu diagrathila avlodha irukke. So now and the components okay, so adha vandu Ajay I have mentioned no on the vertical direction ipo vandu and the mirror move pannalum there is no change. Adha vandu and the river example use panni we have explained no. So adu vandu you can just completely ignore. Okay, so how to find the velocity of mirror na you can just go for in the case la VO perpendicular plus VI perpendicular will be coming as 2VM perpendicular. So idilirundhu the 2 kuda you can just take it down. So you will be getting the perpendicular component. In the perpendicular component you will get. Then once you know the theta, then you can find the velocity. Okay, they will give the values, don't worry about it. Okay, we will do the question, then you will be getting more clarity. Okay, va? So let me just go for the next part. Okay, in the question we can do it, no worries on it. Just hold on. Okay, va? Okay, va? Everybody, yes or no? Fine. And likes are not coming. I don't know. Everybody do like the session. Okay. Done. Now we have done with the scenarios, velocity related things. Now I think we can just straightly go for the spherical mirrors. Okay, spherical mirrors na adu vanda yes. So plain mirrors la irukra majority ana topics vandu we have finished. Few more questions we will do, so on the time la you will be getting more clarity. Ipo vandu we are going for the spherical mirrors. Ready ada? Everybody ready? Spherical mirrors ku ready ya? Ready na? Give me a quick heart. Ready na? ஆரம்பிக்கலாமா? பரவாயில்லடா, questionல we can do the question. So அந்த timeல you will be getting more clarity. பரவாயில்லடா. Okay, don't worry. Yes. என்னடா, what you have written? Yes, physics. That I understood. What is the rest? Okay, so yes, fine. Yes, ready. Very good. So in the spherical mirrors na adu vandu oru adu vandu oru sphere oda part ah irukum. Correct? Okay, adu vandu oru sphere oda part ah irukum. Okay, so yes, physics angel. Thank you so much da. Thank you so much. So ipo vandu we understood idu vandu oru spherical na adu vandu oru whatever we have mentioned adu vandu oru part of a sphere ah irukum. And we have two types, concave irukke, convex irukke. Okay, so idha vandu two types. So idhula vandu first you should know the ray diagrams. Okay, so ray diagrams illa I have added all the ray diagrams in the slide. I will tell you how to do it. No way da, just 1 hour kuda agala. How I'll be, you are just coming for saying this break. No way. Okay, so now yes Asmita, tell him. Okay, so now Understand what I have mentioned right now? What I have mentioned right now? I was talking about the spherical mirrors. So, idhula vandu first na ray diagrams da mukkiyama irukke. Okay, ray diagrams vandu you should know. How to draw the ray diagram vandu you should know it. So, adukku vandu few rules irukke. And the rules that I'm going to tell you. So, இப்போ வந்து நம்ம வந்து we have a concave mirror over here. So, இதுதான் வந்து நம்ம principal axis. Principal axis na, it is nothing but the axis which is passing through the pole. அப்படினா you will ask what is pole ma'am? So, அது வந்து இந்த aperture இல்லையாடா, இந்த curve, okay? அதோட center தான் இந்த pole. Okay வா? Center தான் இந்த pole. Thank you, you are the best teacher. Thank you so much. Thank you so much. Oh my God, God of physics. Thank you. Okay. So now, இதுதா வந்து pole and the curve da aperture. In the pole la pass பண்ற ஒரு line da நம்ம principal axis. And also, we should know few of the things, that is, this is nothing but the focus. இதுதா வந்து நம்ம center of curvature. And definitely in the center of curvature லருந்து இந்த pole இருக்கிற distance da usually we will be saying the radius of curvature. In the focus லருந்து இந்த pole வரைக்குள்ள distance da we will be call it as focal length. Now tell me quickly, in the R and F க்கு ஒரு connection இருக்கு, correct? So now you guys have to tell me what is the relation connecting R and F. In the image பார்த்தாலே தெரியும்டா. So what is going to be the, yes Gangashri. So what is going to be this relation? In the R will be nothing but 2F. In the relation you should know it. Okay, in the relation வந்து you should know it. Very good, very good, very good, very good. R வந்து F by 2 இல்லடா. R வந்து F is equal to 2R. எப்படிடா? R வந்து பெருசா இருக்கணும். Okay, அதுதான் வந்து you should think. You guys are giving the wrong answers. Hey, R is equal to 2F. Yes, R is equal to 2F, not R is equal to, F by 2. Okay, yes. Fine. So, மறக்காம like பண்ணிக்கோ. So, இதுதான் வந்து first relation we should know. Next வந்து, okay, next வந்து, இதுல we can place the object anywhere. Okay, we can place the object anywhere. Now, understand. இப்போ வந்து இந்த object is at infinity ல இருக்கு. Okay, object வந்து எங்க இருக்குடா? Infinity ல இருக்கு. அப்படினா, okay, இப்போ வந்து எங்கேயாவது they have mentioned object at infinity னா அதிலிருந்து வர rays இல்லையாடா? அந்த object ல இருந்து வர rays வந்து எப்பவுமே parallel ஆ இருக்கும். இது வந்து only for the infinity ல இருக்கிற objects. Okay, try to understand when we are mentioned. இல்லனா அந்த questionல they have mentioned infinity ல இருக்கு. அப்படினா the rays should be parallel to the principal axis. Note பண்ணிக்கோ, everybody note பண்ணிக்கோ. R is equal to 2F. அதுதான் வந்து I have mentioned, right? Yes, R is equal to 2F. Okay, don't confuse me da. Okay, so what I said right now, so இப்போ வந்து object infinity ல இருந்துடுச்சுனா, object வந்து infinity ல இருந்துடுச்சுனா, definitely rays வந்து parallel ஆ இருக்கும். No, paraxial lines adella, don't be get confused. Okay, so parallel rays are இருக்கும். Okay, parallel rays are இருக்கும், which means object infinity na in the rays வந்து இப்படி, you can just mention the rays like this. இது வந்து parallel to principal axis ஆ இருக்கும். Paraxial lines na, which is close to the lines, the rays which is close to the principal axis, அதுதான் வந்து paraxial rays. Okay, so and the paraxial usually வந்து இந்த chapterல we will be mention about the paraxial rays only. At the end we will say some kind of what to say, and the drawback சொல்லும்போது மட்டும்தான் we will be talk something other than this. Paraxial lines na இந்த principal axis கூட close ஆ இருக்கிற lines தான் இந்த paraxial lines or இல்லனா paraxial rays. புரிஞ்சுதாடா? So now infinity na rays வந்து parallel ஆ இருக்கும். And now the first rule comes here. Focus everybody. இப்போ வந்து இந்த ray is actually coming from, or let's say இந்த ray is actually parallel na, அது வந்து it will definitely fall on the surface of the mirror. அதுக்கப்புறம் it will passes through the focus. First rule note பண்ணிக்கோ. Ray diagram na first வந்து you can go for a parallel line. அந்த parallel line reflection க்கு அப்புறம் it will passes through the focus. Understood da? Everybody மறக்காம like பண்ணிக்கோ if you understood. Next one light க்கு reversibility ங்கற ஒரு property இருக்கு. அந்த reversibility property தான் I'm going to tell. Now what I said, இப்போ வந்து இந்த ray is actually parallel to the principal axis na after reflection it will passes through the focus. Now connecting with the reversibility na என்னடா yes இப்போ வந்து இந்த ray is actually incident on the surface and that is actually passes through the focus. அப்படினா tell me da what will happen after reflection? After reflection in the ray ki enna agum? Tell me quickly. Reversibility that I'm telling. So இப்போ வந்து இப்படி போய் இப்படி வர முடியும். அப்படினா இப்படி போயிட்டனா how it will come? It will be parallel. Very good. After reflection it will reflect back and that will be parallel to the principal axis. Very good. Understood? So this is what the another rule. First rule வந்து parallel. இப்போ வந்து இந்த rays parallel na after reflection it will passes through the focus. Now I am just saying the reverse thing. Reverse thing என்னடா இந்த rays வந்து actually passing through the focus. Okay, passing through the focus na after reflection it will be parallel to the principal axis. Now another one. Let us say we have mentioned about the center of curvature. Okay, we have mentioned about the center of curvature. இப்போ வந்து இந்த ray is actually falling through the center of curvature. Okay, இதுதான் வந்து incident ray. So அதுக்கப்புறம் what will happen? Tell me quickly. So in the center of curvature la da இந்த ray is actually falling na இதுக்கப்புறம் it will follow the same path. Can you give me the reason? Yes, very good Kevin, very good Sasmita. Whatever you said is correct. Now my question is what is the reason behind it? And the reason there you know le. So now let me just ask you a question. Very good Jay, very good. I got the answer. Okay, now the thing is like the question is if I have a circle over here. இதுதான் வந்து அதோட center point. In the center point if I am drawing any line towards the surface, are you guys getting it? What I said? So இப்போ வந்து ஒரு sphere இருக்கு இல்லனா ஒரு circle இருக்கு. So அதுல center point அதோட center point இருக்கு. அந்த center point if I am drawing a line towards the surface, definitely what is going to be this angle? The angle made with the radius. Okay, angle made with the radius and the surface will make an angle. Tell me, you guys are very good in mathematics, I know. You tell me what is going to be this angle. இது வந்து எப்பவுமே 90 degree இருக்கும். Okay, it is nothing but the 90 degree. Coming to the mirror. So in the portion the mirror I am choosing. Okay, so in the portion mirror na definitely when I am completing I will be getting a circle and the circle oda center da in the center of curvature. Correct? So now what I said in the center of curvature la irundha pass pandra light is falling. அப்படினா tell me da இது வந்து it will be making an angle. What is the angle it is made with the surface? What is going to be this angle? What is this angle? இது வந்து 90 degree da. Okay, so இப்போ வந்து consider this as a whole circle. அப்படினா இதுதான் வந்து the radius of the circle. So அப்படினா in the center point இருந்து I am drawing a line towards the surface. அது வந்து எப்பவுமே 90 degree இருக்கும். Beginning sessionல I have told you in the normal incident na reflected ray will make an angle. What is the angle made by the reflected ray? Quickly tell me da. Beginning la we have studied normal incidence la what is the reflected angle? Tell me. Those who have understood that portion, the beginning part, tell me da. Very good. Adu vanda Kevin 90 degree illada 0 degree. Okay, so adu vanda it is coming as 0 degree. Adinalatha it is actually bounce back. Purinjidada? Purinjidichina give me a like. Also give me a heart in the chat box. The reason behind this bounce back in the center of curvature la irundhu vara ray is actually retracing its path. What is the reason for it? We already understood. Okay. Thank you so much da. Thank you so much. Now we understood this reason. So இப்போ வந்து center of curvature la irundha definitely it will retrace its path. Now again another thing. So இப்போ வந்து again this is the mirror. Okay, this is the mirror, this is the principal axis. Now, actually, this is coming towards the pole. Okay, incident ray is actually making an angle. Incident ray is actually making an angle I with the principal axis. Again, what is going to be the sign? Can I say that that is the incident angle? Can I say that the incident angle? Thank you so much, Shahid. Bhuvanesh, which one is 0 degree, ma'am? Reflected angle will be 0. In the case, reflected angle will be 0. Now, suddenly tell me, everybody tell me. So, can I say the incident angle? What is incident angle? What is the definition we have mentioned in the beginning? The beginning in the incident angle, we have mentioned some definition. What was that? The angle made with the incident ray and the normal. So, in the case, என்னடா இந்த normal? எங்கடா இந்த normal இருக்கு? What is that normal? What is that normal? In the normal na enna? Normal na enna? In the surface irundha I mean when we are drawing the perpendicular. Idudha vandu namma radius of curvature illana center of curvature. Correct ah? Appadina in the center point la irundha I am drawing a line. Adha vandu principal axis illaya. So definitely idudha vandu namma normal, and this incident ray is actually making an angle I with this. And definitely after reflection, what is going to be that angle? What is going to be that angle? It is nothing but, yes, principal axis is the normal. Very good, very good, very good, Kevin. Very good, Samsida, Arun, very good, very good. Now tell me, in the case, what is going to be the reflected angle? That is also coming as the same. So whenever you are going for any ray which is falling on the pole, after reflection, it will make the same angle and it will come. Ma'am, physics easy irukku neenga nalla teach pandre. Thank you so much, Preeti. Thank you so much. Okay va, purinjadada everybody? Everyone is getting this. So these are the few rules for the ray diagram. Okay, these are the few rules. So now the thing is like let us say ipo vandu inga oru concave mirror irukke. Idudha vandu nama principal axis, pole inga irukke, f vandu inga irukke, center of curvature vandu inga irukke. So now I am placing, I am just giving one example. The rest of the cases I have already pasted here. Adukku time I am not going to spend much. Okay. So ipo radius of curvature la I am placing an object. So the thing is like, if you need to get the image at least 2 rays must intersect. At least minimum avada 2 rays it should intersect. So ipo whatever be the rays we have mentioned, adilirundha whatever be the ray you need it, you can take it. Usually, okay, இப்போ general பார்க்கும்போது you can see that எப்பவுமே we will choose the line parallel to the principal axis and center of curvature ல pass பண்ற line. ஏனா இந்த 2 rays ல if you are marking அந்த diagram கொஞ்சம் neat-ஆ feel பண்ணும். And then definitely it is not the thing that you should choose only those 2 lines. It is not at all necessary. Whatever be the lines we were discussed in the beginning, adellame you can just use. Now why we are going for parallel and the line which is passing through the center of curvature? Because we know that adula 3 rays mattum da we need to draw. Okay, ena center of curvature la irundhu retrace pannumla. So the diagram will looks little beautiful. Adukkagatha. It is not something which is any complicated reason irukku adhu illada. Okay, so ipo I am just taking the parallel ray. Parallel ray after reflection it will passes through the focus. Next one idhu we cannot just go for the center of curvature la pass pandrathu. So definitely I can go for in the focus la. Okay, in the ray is actually passing through the focus. Appadina what will happen idu parallel irukkum. Correct ah? Idu parallel irukkum. And actually if you are drawing correctly in the image the intersection of this two will be happening exactly at the center of curvature da. Ipo I didn't even took the scale and pencil, so the konjam difference irukkum. So this will intersect here and we will be getting the image over here. So if you want you can also go for this one. In the pole it will be making an angle. After reflection it will be making the same angle. Again it will intersect at this point. புரிஞ்சுதாடா? So any ray you can choose, there is no restriction. And now I have placed concave and convex mirror க்கு what is the properties of the image and the diagrams at different positions ல object place பண்ணும்போது what are the diagrams coming எல்லாமே வந்து I have marked over here. So அதனால guys இந்த class முடிஞ்சதுக்கு அப்புறம் if you have any confusion in the ray diagram na you can just go through it. Okay, இதுல வந்து confusions எதுக்கு possibility கிடையாது. ஏனா we know this rules. Okay, in the rays what is the way they will be going, no worries da, இதுக்கு அப்புறம் you will be getting. Okay, class முடிஞ்சதுக்கு அப்புறம் PDF கிடைக்கும்ல. I'm not going to explain this also. Okay, so that is what the thing. I have placed all the diagrams, everything. Next one is mirror formula da. And the mirror formula, do you guys remember what is mirror formula? You guys remember what is mirror formula? What is that? What is that? What is that mirror formula? So now we are going for the mirror formula da. Okay, now we are going for the mirror formula. Okay, mirror formula tha 1 by u plus 1 by v which is equal to 1 by f. And for this mirror, again, the sign convention is a very difficult part. Okay, so adu kuda I will explain. Adukapram we can just go for the magnification. So ipo vandu in the whenever we are choosing the object distance, whenever we are choosing the image distance, idukellame vandu konjam confusion irukke. So understand one thing. So ipo vandu idudha vandu nama mirror setup. Okay, so ipo vandu the object I am placing over here. Okay, so ipo vandu paakumbodhu this is how the what to say in the object order distance vara poradhu idudha. Usually we will be represent it as u. Okay, so inga da object irukke. So now the thing is like the incident ray is actually falling to the mirror in this direction. Okay, eppavume just focus over here. Horizontal distance, which means in the line la irukra distance vanda if you are finding na mark panniko, if you are finding any length in the horizontal direction na you should start with pole. Okay, so ipo vanda in the image object distance if you are finding na you should start from this point. Okay, so idudha vanda nama object distance. You should start with pole. And always understand if this u is there, okay, in the what to say in the nama object distance irukke. So now if it is in the same direction of light, what is the same direction of light indicating? This one. Okay, and the direction la irundha you can choose positive. Ana inga u paakumbodhu what is happening da? What is happening? Ipo vandu in the u nala, if I'm just finding u na, I should start with no compromise on it. I should start with the pole, and definitely what will happen da? It should come in the opposite direction of light. Appadina in the u will be coming as negative. Okay, now tell me da, in the case la, in the radius of curvature for a concave mirror vandu positive or negative on the basis of whatever I have mentioned, tell me in the case la, in the radius of curvature illada, in the radius of curvature vandu is it going to be positive or negative for a concave mirror? What is it? Start from the pole and you should check it is in the same direction of light illana opposite direction. Radius of curvature na inge da irukum. So pole la irundhu start பண்ணும்போது light oda opposite direction la da irukke. So definitely this will also come as negative. What about the focal length? Tell me what about the focal length? What about the focal length in this case? Adu kuda it is going to be negative. Yena that is also we will be calculating in the opposite direction of light. So now in the convex mirror la, I'm going to ask you what about the radius of curvature? Convex mirror la, okay, convex mirror la what is going to be, okay, what is going to be the value positive or negative for the radius of curvature? Convex mirror la, tell me what is going to be that radius of curvature? Very good. அது வந்து பாசிட்டிவா இருக்கும். ஏனா it is actually light ஓட direction வந்து இப்படிதா. Radius of curvature வந்து இந்த directionல இருக்கும். So definitely in the radius of curvatureல this will be coming as positive. Okay? And next one வந்து focal length. What about focal length? Positive or negative? That is also in the same direction of light, and we will be calculating from the pole, which is also coming as positive. Now tell me in the case, what about the object distance? Positive or negative? Or what about this object distance? Positive or negative? Positive or negative? It will be coming as negative. Yena idukku vanda we will be finding in the opposite direction. So in the u value vanda it will come as negative. Okay, so this is what the thing. Next one vanda, let us say we have the mirror and we got the object over here, image over here. Okay, so ipo vanda I'm talking about vertical direction la. Okay, whatever be the points I'm telling you da adu vandu note panniko, ellame vandu important da. Okay, so vertical direction la irukkiradhu da now I'm going to tell. Vertical direction paakumbodhu ipo vanda it is upside na. Okay, if it is upside na adu vandu positive ah irukum, and if it is downward na it will be negative. No more confusion. Okay, no more confusion. Ana horizontal distance paakumbodhu da and the confusion irukku. You should always go for the horizontal distance paakumbodhu you should start from pole. Ipo vanda and the point is actually starting from the pole. If it is in the same direction of light na adu vandu positive ah irukum. Ipo vanda it is in the opposite direction and the value vandu negative ah irukum. Okay, vertical up na positive, down na negative. Very good, very good, very good. Purinjidada everybody? Got it? Yes. So now we are going for the magnification equation. Magnification equation now we know how much it is magnified. Object vanda, as I mentioned, object vanda 5 cm da length irundiruchu, ana image ku vanda 10 cm irundiruchuna I will say it is the size vanda double ah irukku, which means magnification vanda 2 ah irukum. இப்போ வந்து இதோட size வந்து 5 cm தான், ஆனா image வந்து 2.5 தான். அப்படினா I will say that இது வந்து magnified as 1/2, which means இதோட length வந்து இல்லனா size வந்து half ஆ இருக்கு. புரிஞ்சுதாடா? So next one வந்து magnificationக்கு we can say hi/ho, which is also equal to minus v/u. V na image distance da, u na object distance da, and using this expression we can also come to another equation, f/f minus u, which is equal to f minus v divided by f, which means in the magnification equation if they are giving in terms of focal length and image distance na, straightly vanda you can use this equation. Okay, straightly you can go for this equation. Adanala da I'm telling you. Purinjidada everybody? Last slide la enna irundiruchu? Idu upward and downward Sanjana? So simple arke, upward direction la irundiruchuna vertical direction la we will say positive, downward na. Okay, ipo vanda inverted image na adukku vanda height of the image sollumbodhu it will be coming as negative. Okay, and height of the object sollumbodhu it will be positive, yena adu vanda upward direction la irukku. So next one in the magnification. Okay, in the magnification this equation is actually for the lateral magnification, which means ipo vandu in the length 5 ah irukke, length vandu 2.5 ah irukke, illana 10 ah irukke, which means laterally how much it is magnified. Adudha vandu we were just explaining. Now in the magnification value adoda magnitude vandu just I'm saying it is 2. அப்படினா you will get to know அது வந்து image வந்து it is actually a bigger one. Okay, now let us say the magnitude வந்து less than 1 ஆ இருக்கு, which means 1/2 you are getting. 1/2 you are getting na, you should understand and the image size வந்து comparing with the object reduce ஆ இருக்கு. Next வந்து in the magnification actually coming as a negative value. Okay, negative value na adula வந்து you should understand and the image வந்து inverted ஆ இருக்கு. Okay, which means that is a real image da. Okay, magnification வந்து if it is positive, okay, magnification வந்து positive ஆ இருந்துச்சுனா you will get to know the image வந்து erect ஆ இருக்கு, and magnification is equal to 1 na you will get it is as the same size. For example, இப்போ வந்து center of curvature la we are placing an object na, we know that and the image is also coming in the same position, same size da, and the case la magnification will be coming as 1. Okay, next one the longitudinal magnification. I will tell you, you can just study the equation only, no derivations, nothing required. Ana in the equations rarely they have asked, but we cannot take any risk. Okay, adanala we have to study. Okay, so ipo we know that idudha nama object. Okay, object initially ippadi da irundiruchu. So definitely what will happen in the this is u1 and this is coming as u2. So which means in the longitudinal side la idukku oru size irukku. Ana image பார்க்கும்போது let us say it is coming like this, which means this is what v1, this is what v2, which means what is exactly happening, so on the size the longitudinal size reduce ஆயிருக்கு. So in the situation la you should know, right? Okay, lateral magnification we have mentioned, now longitudinal magnification also you should know. So adukkaga thank you Durai, thank you so much. Okay, so adukkaga irukra equation da image order length divided by object order length, which will be coming as minus v2 by v2 minus v1 divided by u2 minus u1, or let's say you can go for minus delta v divided by delta u. So ipo in the length in the object avlo small arkena, in the minus delta v by delta u will become dv by du agapore. And finally whenever you are doing this, you will be getting this equation minus m square, which means in the longitudinal magnification, okay, purinjiko, the longitudinal magnification will be equal to minus of the lateral magnification order square. So you should study this equation. As I mentioned, no, idu avlo times they didn't ask, aanalum you should study. Okay, risk, we cannot take risk. As I mentioned, idu 90 plus da. So in the chapter la irukra ovvaru point me you should study. அதனால தான் I'm telling you, okay வா? So in the magnification, longitudinal, in the direction ல இருக்கிற magnification ஓட expression for a very small object னா, அது it will be equal to minus m square. இந்த m னா என்ன? Lateral direction ல இருக்கிற magnification ஓட expression தான். Okay? So you should write all these equations, all are important, very, very important. So next one is, we have seen the diagrams, everything. Yes. So now I think we can just go for the refraction part. Are you guys ready? Refraction ready ada? Refraction, everybody ready? adile explain பண்றதுக்கு எதுவும் இல்லடா Ganesh, you can just study the equation, nothing else. Okay, just study the equation and the values enna irukku adu you should study. Yes, Pooja, yes, Damodara, Anu, yes, Ganesh, Jia, Shahid, Durai, Lakshmi, Aisha, yes, very good. So now we are going for the refraction part. Okay, so now tell me, what is refraction? Ipa ஒரு light, okay, ipa ஒரு light is actually falling from a medium to another medium. Okay, so ipo ஒரு மீடியத்துல இருந்து வேற இன்னொரு மீடியத்துல it is actually going na, definitely what will happen, so ipo what I said, when the ray is actually coming falling on the surface and adukapram it is when it is going to a different medium na, what will happen, adukku ஒரு bending இருக்கும். Okay, when a light ray, note paniko, when a light ray is traveling from one medium to another medium na, what will happen, there will be a bending of light, and the bending of light da in the refraction. So now idila you should study a term that is refractive index. What is refractive index? First I will talk about the absolute refractive index. Okay, absolute refractive index na, adoda expression c by v da. What is C? Speed of light. Okay, what is V? Speed of light in a medium. இதுதான் அந்த மீடியத்தோட absolute refractive index. புரிஞ்சுதாடா? Everybody understood? Yes or no? So இப்போ இந்த refractive index is actually talking about the optical density, which means in the refractive index அதிகமா இருக்கு. Okay, if I'm telling refractive index is more for this medium na, அதோட optical density அதிகமா இருக்கும். அப்படினா இந்த optical density என்ன? It is nothing but, let us say, how easily a ray can passes through the medium. So density is more, இல்லனா இந்த refractive index more na, அந்த objectக்கு அந்த மீடியத்துல இல்லனா அந்த ரேக்கு அந்த மீடியத்துல to pass through the medium கொஞ்சம் difficult இருக்கும். Are you guys getting it? So, if I'm saying refractive index adhigam, it is actually more na, anta mediathula, in the ray will struggle to move, which means velocity it is going to be kammi. And we can see from this equation as well. C na constant da 3 into 10 to the power 8 value that we know. Appadina, in the mu value is actually inversely proportional to V. So, optical density is more na, velocity will be less. Understood the first point? Optical density is more na. What is the meaning? In the velocity in the medium will be very, very small. So, this is the absolute refractive index. Purinjidada? So, now focus over here. Focus over here. So, let us say, we have rarer medium, we have a denser medium. Rarer medium, now what is it is indicating? Rarer medium, now optical density less. Optical density less, now what about the velocity? What about the velocity? Optical density is less da, rarer medium. Appadina in the rarer medium, velocity calculate பண்ணும்போது, it is going to be higher, lower. Higher, lower. Tell me, quickly tell me. High or low? Everybody tell me. It is going to be very high. Yena refractive index is going to be less. So, V will be more. So, first I am going to draw the normal. So, this is the normal. Okay, so, here is normal. Now, focus over here. So, in the normal, there is an incident ray. Okay, incident ray. It will be making an angle I with the normal. I will call it as incident angle. Correct? I will call it as incident angle. Come on guys, like the session fastly. Okay. So Damodara is requesting for me. Thank you so much. Even I forgot about the likes. So now we know that in the point, okay, in the rarer medium, velocity is more. When it comes to the denser medium, velocity is going to be less. Okay, velocity is going to be less here. So what will happen? In the bending will be towards normal, illa away from the normal. Tell me what will happen in the bending will be towards the normal or away from the normal. Quickly tell me. Velocity is less. Appadina, what will happen? After refraction, it will bend towards the, okay, bend towards the normal. Very good. It will be towards the normal. Appadina, I can say that the incident angle, what is this case? When light is traveling from rarer to the denser medium, so what will happen? Incident angle is more than the refracted angle. Got it? Incident angle will be more than the refracted angle. And this is the first medium. This is the first medium. This is the second medium. So, in the case, velocity in the first medium is more comparing with the velocity in the second medium. Yena, refractive index of the first medium is less than comparing with the refractive index in the other medium. Okay, now again I am going for another scenario. So, this is the denser medium, this is the rarer medium. So, how will be the relations? Can you just tell me about the relations which we have already written? What will happen? So, you can just see that this is the denser medium. So, this is the incident angle is coming. So, what about the refracted ray? It will move towards or away. When it is traveling from denser to rarer, velocity will be more, correct? So, initially it was coming slow, and suddenly it will be having higher velocity. So, it will move away from the normal. And now tell me the same relations which we have mentioned over here. What will happen? I will be less than comparing with the refracted angle. Velocity V1 will be less comparing with the velocity V2. And refractive index will be more comparing with the second medium. Understood? This is what actually happening in the denser to rarer medium. And now we understood all of this thing. And now we are going for the laws of refraction. Okay, laws of refraction. So, laws of refraction are same as reflection. Okay, same as reflection. We can say that the incident ray, refracted ray, the normal are in the same plane. Okay, are in the same plane. Another one is sin I divided by sin R will be coming as the relative velocity, which means mu2 by mu1. Sin I is a sign of incident angle. Sin R is a sign of the refracted angle. It will be coming as mu2 divided by mu1. Okay, relative velocity oda ratio agapore. So this is what we are calling the Snell's law. So Snell's law will be nothing but sin I by sin R, which is equal to mu2 divided by mu1. Got it, everybody? Everybody understood? Yes or no? Yes or no? Give me a heart if you understood. Quickly give me a heart, Dada. Quickly give me a heart. Okay. So now, yes. In the chapter again, time but let us just try. Okay. So sin I by sin R will be mu2 by mu1. So we know that in the mu2 mu2 C by V2 da, mu1 C by V1 da. So while we are giving the ratio, we will be getting V1 by V2. And velocity is nothing but frequency into lambda da. When the, important point, note paniko. So when the light is falling from one medium to another medium, the wavelength will change. Okay, wavelength will change. Ana frequency will be remain same. Frequency na adu vandu oru source property da. Adu vandu it is not going to change with the mediums. Purinjadada? For example, let us say we are sitting in a classroom. Okay, so ipo vandu we are just sitting in front of, with our friends. So appa irukra oru kind of what to say, the talking style irukattum illana the way you are interacting with the friends ellame vandu, let us say the same scenario, you are sitting with the teachers. You will be behave yourself, right? So on the external things irukku. Okay, external things, and other than the lambda and everything, when the medium changes and the values when the change agum. Ana we know that, let us say someone is falling suddenly. Okay, if you are just sitting with your friends in alum, if you are sitting with your unga teachers gida, if you are sitting nalum, definitely if you are seeing someone is falling na, you will go and you will pick him. Right, which means and the kindness and the madri what is the internal arke. Okay, so adha what I'm saying, the source kulla irukra qualities da. Okay, so which means and the madri in the case definitely we can say that the frequency will be remain same. Yena adu the source property da. Lambda the wavelength da. Okay, lambda the wavelength da. So definitely wavelength will vary. So we can just make the ratio lambda 1 by lambda 2. Each and every equation you should note it, and adellame you should study. Got it? Next another thing, in the relative velocity you can just write in terms of real and apparent depth. So first example definitely let us say I'm just talking about you are observing something from a rarer medium and the object is in the denser medium. Purinjadada? So the observer is at the rarer medium, object is, observer and the rarer medium, object is in the denser medium. Purinjadada, everybody? Everybody got it? Yes, Aisha, thank you so much. Okay. Innum teachers kitta nalla pesa poriya. Very good. Yes. So now, tell me da. Yes, wavelength will vary da. Okay, wavelength will vary and frequency the same arukum. So adanalata whenever we are taking V1 by V2, V1 na F lambda 1 da, V2 na F lambda 2 da. Purinjida? Okay. So now, what I have mentioned, observer rarer mediathil irukke. I am just observing from the rarer medium, and actually nama object irukkirathu denser mediathil irundhu. So which means ray is actually coming from the denser to the rarer medium. Purinjidada? So for example, I will tell you, ipo oru swimming pool irukke. Okay, so anga oru stone irukke. I am going to watch this stone. Got it? So this is what the thing. So on the case in the relative velocity order ratio it is nothing but real depth divided by apparent depth. So whenever the ray is actually coming from the denser to the rarer medium, in the apparent depth comparably it is going to be less. Now the thing is like, yes, coming to the normal shift. நார்மல் ஷிஃப்ட்னா இந்த ரியல் டெப்த் அண்ட் அப்பேரண்ட் டெப்த்ல இருக்கிற சேஞ்ச் தான். ஓகே, இந்த ரியல் அண்ட் அப்பேரண்ட் டெப்த்ல இருக்கிற சேஞ்ச் தான். அந்த சேஞ்ச் வந்து HR மைனஸ் HA, HRனா ரியல் டெப்த் தான், HAனா அப்பேரண்ட் டெப்த் தான். அதோட எக்ஸ்பிரஷன் வர போறது HR into 1 minus 1 by mu. Muனா அந்த டென்சர் மீடியத்தோட வாட் இஸ் அந்த ரிஃப்ராக்டிவ் இண்டெக்ஸ் தான். சேம் வே யூ ஆர் டூயிங் ஃபார் த இப்போ வந்து ஒப்சர்வர் இருக்கிறது டென்சர் மீடியத்தில். இப்போ வந்து லெட் அஸ் ஐ அம் இன் த ஸ்விம்மிங் பூல் அண்ட் ஐ அம் observing something in the what is it, something on the tree and all, so I'm just observing it, which means in the case la observer வந்து denser mediathil irukka, object வந்து actually வந்து rarer mediathil irukka. So light rays actually coming from the what to say in the rarer mediathil irundha the light rays actually coming. And the time la in the refractive index வந்து apparent depth divided by real depth ah irukum. So just understand Ganesh, simple ah irukku, two different scenarios da we are explaining. First scenario na, in the light rays actually coming from denser to rarer medium. Correct? We are observing something from the what to say in the swimming pool kulla, I mean not inside, we are just standing outside. In the pool kulla ஒரு stone இருக்கு, அதுதான் வந்து you are observing. Are you guys getting it? Which means observer in the rarer medium and this what to say நம்ம what is object வந்து denser mediathil irukku. அந்த டைம்ல அந்த denser mediathோட refractive index if you know na, you can go for this equation, real depth divided by apparent depth. Now if you wanted to find the change, okay, apparent depth na enna, the depth which we are feeling, adu vandu real depth varakum definitely there will be a change, and the change oda expression vandu the real depth into 1 minus 1 by mu da aga pore. And exactly the similar way ipo vandu naama vandu we are in the swimming pool and we are observing something outside, something which is happening outside. அந்த டைம்ல இந்த equation வந்து உல்டா ஆக போற, refractive index will be coming as apparent depth divided by real depth, which means the observer ஓட medium change ஆச்சுனா இந்த refractive index ஓட expression கூட it will change. Understood guys? So now idhila irukra shift oda expression vara poradhu HR into mu minus 1 da. In the expressions, in the equations vandu you should study. Idukku vandu and the detail irukra explanation, derivations ellame vandu actually sollumbodhu we have already done. In the session la I'm not going for it. As I mentioned, idu vandu point by point irukumda. So just study all these equations and the scenario purinjiruchilla. So when we will be using these equations, adu vandu correct ah purinjirukke. So definitely you can just go for that. Now another scenario, let us say we have in the இப்போ வந்து ஒரு pool இருக்கு, ஆனா அந்த poolக்குள்ள different layers of water இருக்கு, which means different layers of liquid இருக்கு, அதுக்கு வந்து different ஆன refractive indexes இருக்கு. புரிஞ்சுதாடா? So இப்போ வந்து what I said, இப்போ வந்து we have a beaker or something, okay, அதுல வந்து different liquids வந்து fill ஆருக்கு. Just for an example. Okay, problems வந்து இந்த chapter முடிஞ்சதுக்கு அப்புறம், okay, or otherwise if you are feeling bored now, we can just go for the question practice after this. 5 or 6 questions we can do, again we can come back. But I mean whatever you are suggesting, I will go for that. Okay, so இப்போ வந்து இந்த refractive index and the different mediathukku வந்து refractive index different ஆ இருக்கு. ஒவ்வொரு மீடியத்துமே it is actually in D1, D2, D3 and அததான் வந்து ஒவ்வொரு liquid ஓட width வருது. Okay, இல்லனா அதோட depth வருது. அப்படினா இந்த questionல what is the apparent depth? இப்போ வந்து if I am observing something from here na, what is going to be the apparent depth? And the apparent depth da D1 by mu1 plus D2 by mu2 plus D3 by mu3. Okay va? Real depth na enna? Real depth in the case la what is the real depth? Real depth is nothing but D1 plus D2 plus D3 da. Correct ah? இதுதான் வந்து real depth. Ana apparent depth, which means if I am observing from here, what I can see, okay, so adukulla what is the actual irukra depth, adudha vandu enakku puriyanum. Okay, sorry, what is the apparent depth which I am feeling? So if I am just considering this one, okay, if I am just considering this one na, I can say that it is nothing but D1 by mu1 da. Now focusing on this one, அதில் இருக்கிறது D2 by mu2 தான் apparent depth and இதுக்கு வரது D3 by mu3 தான். So the apparent depth total if you wanted to find na, you can just add it. Now in the case if you need to know the effective refractive index, okay, effective refractive index, okay so in the I mean in the scenario புரிஞ்ச போதும்டா இதுக்கு வந்து derivations அதெல்லாமே வந்து தேவையில்லை okay real depth na d1 plus d2 plus d3 தான் ஆனா now I am focusing on the apparent depth so in the first layer ல வர apparent depth na d1 by mu1 தான் second layer ல d2 by mu2 தான் and third layer ல d3 by mu3 தான் புரிஞ்சுதாடா now apparent depth I got it. Now the thing is like inga mu1 irukku mu2 irukku mu3 irukku idoda effective refractive index enna adukkaga I will be going for the equation real depth divided by apparent depth ஏனா இங்க வந்து பாக்கும்போது we know that இப்ப வந்து இந்த observer வந்து rarer mediathil irukena refractive index oda expression da real depth divided by apparent depth appadina real depth is actually coming as d1 plus d2 plus d3 divided by d1 by mu1 plus d2 by mu2 plus d3 by mu3 got it everybody yes or no yes idukapra we can go for the questions. Okay, yes, I too feel exhausted. Now I can take rest, I can give some questions to you people, right? Everybody? Okay, so understood this concept everybody, yes or no? Tell me yes or no, or give me a heart quickly. My energy is draining da. Where are the students, I mean like those who are giving hearts. Now I'm not getting any hearts. Let us do some questions. Ready, Ada? Ready, everybody? Let us do some questions. And whatever I am saying, adu vanthu correct note pannikoda. Ena few days appuram if you are starting solving the questions in ray optics na, in the concept ellame vanthu teliva puriyanumla. Adukkaga da please write each and every concept whatever I am saying. Yes, let us go for the questions. First question, simple question. Tell me the answer. Quickly, Vanthu, you can tell me the answer. First question oda answer Vanthu avlo easy ah irukku. Are you guys getting the answer? Simpler, you can give me the answer. What is the angle of incidence? What is the angle of reflection? Very good. What is the answer it is coming? It is nothing but, ipo vandu idu 35 na, this will be coming as 90 minus 35, so which will be nothing but 55. We know according to law of reflection both this will be same, so option B is going to be the right answer. Very good guys. So now let us move on to the next question. Idukku vandu konjam geometry theriyanumda. Okay, you should know how to draw this diagram. Avlo da irukke. So a mirror is inclined at an angle of theta with the horizontal. If ray of light light is incident at an angle theta as shown the figure. So idudha vandu namma surface. Okay, idudha vandu namma plane mirror oda surface. Now the thing is like it is the incident ray is actually making an angle theta with the, okay, it is actually making theta with the surface. Okay, purinjida. Then the angle made by the reflected ray with the horizontal the question. அப்படினா first வந்து இந்த surface-க்கு we are going for the normal. We are drawing the normal. Okay, because ஏனா incident angle, reflected angle எல்லாமே தெரியணும்ல. So now I can say that இதுதா வந்து நம்ம what is this angle? Incident angle, correct? Incident angle. Can you give me the expression in terms of theta? What is going to be the incident angle in terms of theta? Tell me. What is the scary question? Idu vandu simple question. 10th grade student will do. So now tell me, this is 10th grade question da. Don't say this is difficult. So now tell me, what is going to be the angle between this normal and this incident ray? Hey, hey இங்க வந்து 2 mirror எதுவும் இல்லடா, only 1 mirror தான் இருக்கு. இது வந்து ஒரு surface தான். Okay, it is inclined for an angle theta. Okay, so now the question, yes, very good, it will be coming as 90 minus theta. Now you can just tell me what is going to be the angle made with the, or let's say what is the angle of reflected ray. What is going to be the reflected ray will also make an angle 90 minus theta. Am I right or wrong? Am I right or wrong? So now we know that இது வந்து normal தான், and definitely இது வந்து 90 degree இருக்கணும் because it is making with the surface இல்லையா. So normal to the surface, which means it is actually 90 degree. அப்படினா tell me da, in the angle what is going to be this angle? We know that this angle is 90 degree, total வந்து 90 தான். அப்படினா இந்த small angle வந்து என்ன ஆக போறே? What is going to be the small angle? Tell me. Theta, very good, geometry mattum da here we are using. Physics edu illada, physics ella what we have mentioned in the laws of reflection vandu we have used. Adukapra we didn't do anything. Okay, so now in the case illa in the angle theta na idu vanda normal da, so total vanda 90 degree, idu vanda total ah vara poradhu 90 degree. Till this understood everybody? Yes or no? Give me a quick heart, instantly give me a heart. So idu vanda making an angle 90 degree here, this will be making an angle 90 degree here. Correct? Yes or no? Yes or no? Getting it? Yes, very good. அப்படினா இது வந்து 90 na, this angle, okay, this angle will be coming as 90 minus theta. We know incident angle and reflected angle வந்து same இருக்கும், அதனால இந்த angle கூட 90 minus theta தான். We also know இது வந்து total angle வந்து 90 degree. So this angle, let me say initially I don't know na, so I am writing x. So x plus 90 minus theta will be coming as 90. So now what will happen? In the 90 will be get cancelled and I am going to get x is equal to theta. Now what is the question? What is this reflected ray made with this horizontal line? Okay, what is the angle between this reflected ray and the horizontal? What is that angle? Tell me. What is this angle? In the reflected ray is actually going like this and this is a horizontal. What is the angle between them? What is the angle between them? Theta. How the horizontal is making an angle theta? Very good, Kevin. It will be 0. Both are parallel, right? Both are parallel. So definitely the angle between parallel lines will be 0. So hence the option D will be the right answer. Very good. Understood everybody? Everybody understood? Yes or no? Yes or no? Give me a heart if you understood. Quickly give me a heart, da. Quickly give me a heart, everybody. Quickly give me a heart. Very good. Now let us move on to the next question. So next question, inga irukke. If a ray of light is traveling from point A, okay, if a ray of light is, Ganesh, you are feeling this question is difficult, I mean the previous one. Okay, tell me now. Simple arkellada. Don't think it is a complicated question. If ipo vanda avlo lines ellame irundiruchna, that is not going to be a complicated question. Easy question irukku. So now, okay, marakama like pannikoda. If a ray of light is to travel from point A to point B after reflection from the plane mirror. Okay, after reflection from the plane mirror, as shown in the figure. Okay, so idhila vanta they have given this is actually 12 centimeter, idu kuda 12 centimeter da, and this is coming as 4 centimeter. Now the question is where should the line should strike on the mirror? Simple da irukke. Actually vanda in the A ilirundha one ray will come, it will fall on the plane mirror and it will reflect and it will go to B. Okay, in the plane mirror la entha point la actually vanda it is striking, adudha vanda theriyanum, purinjidada. So appadina I will just mention, I'm just assuming in the point la da actually vanda it is striking, purinjida? Everybody understood the question? Yes or no? Quickly tell me. So I am assuming in the point la, okay, in the point la da, maybe I don't know. Okay, I don't know. I'm just saying. Okay, ma'am, neenga solve panni kancha easy irukka or it's confusing, like doesn't know what to do. Paravaillada, konjam questions vandu indha madiri you have to do, then only you will feel like more confidence. ஓகே பரவாயில்லடா பிகினிங் ஸ்டேஜில் அப்படி தான் இருக்கும் ஒவ்வொரு ஸ்டூடெண்ட்டுக்கே அப்படி தான் இருக்கும் பட் ஆனால் பரவாயில்ல we will do it no worries on it okay trust me so now இப்போ வந்து a point இருக்கு okay we have a point a so now what I said first line first ray வந்து it will incident over here okay வா so இந்த pointல I'm going to draw the normal okay I'm going to draw the normal so normal இருக்கட்டும் இங்க தான் இங்க normal இருக்கு so now can I say that இதுதான் வந்து நம்ம incident angle I can I say that incident angle I yes or no so இதுக்கப்புறம் what will happen Nikita if your target is like around 80 90 na in the 12th grade portions மட்டும் போதும் ஆனா அதுல ஒவ்வொரு சாப்டருமே நல்லா you need to study it very well then only okay guys மறக்காம லைக் பண்ணுடா அதுக்கப்புறம் what will happen it will reflect to this point இதுதான் வந்து questionல mention பண்ணிட்டு இருக்கேன் everybody got it so now we know that according to law of reflection in the angle I will be equal to R தான் இருக்கும் கரெக்ட்டா so now I'm just taking this distance இல்லையாடா இந்த distance வந்து I am considering x அப்படினா what is going to be this distance what is going to be the rest of the distance tell me quickly tell me what is going to be that distance இப்போ வந்து இந்த distance வந்து x ஆக போறே அப்படினா tell me what is going to be this one tell me what is going to be this one very good Sabida it will be coming as 12 minus x now focus well so இப்போ வந்து பாக்கும்போது you know 4 cm இருக்க x இருக்கு ஓகேவா 4 cm இருக்க x இருக்கு இங்க பாக்கும்போது 12 minus x இருக்கு 12 cm இருக்கு consider two triangles here okay here we have two triangles in the two triangles la we know the two sides adula வந்து only x da let it be okay two sides இருக்கு and now my question is இப்போ வந்து இந்த angle okay இந்த angle I na tell me what is going to be this angle this angle is coming as I அப்படினா what is going to be this angle அது கூட ma'am it is coming as I only okay ஏனா இது வந்து opposite angles தான் okay இது வந்து two parallel lines இருக்கு okay two parallel lines இருக்கு அப்படினா definitely இந்த angle and இந்த angle வந்து same ஆ இருக்கும் we know I is equal to R தான் so இப்போ வந்து இந்த angle R னா what must be this angle everybody tell me what is going to be this angle if this is R what is going to be this angle ma'am no confusion that is also same concept that we are using here ma'am adu kuda it is nothing but R da very good Pooja very good Arun very good Oliva so now we got this one can I say that in the angle kuda let me just mark it as theta this is also coming as theta yena I is equal to R which is equal to theta now if I am finding tan theta in both the cases idla sollumbodhu what is tan theta da what is tan theta yes very good alternate interior angles tell me what is tan theta according to the small triangle opposite side which means x by 4 okay opposite side na x by 4 till this everybody understood any confusion so far till this any confusion everybody tell me any confusion irukka opposite side by adjacent side so it will be x by 4 not 4 by x okay and also in the triangle consider பண்ணும்போது what is tan theta for this other triangle very good da so now this will be opposite side not 12 minus x divided by the adjacent side will be 12 so considering equation 1 and equation 2 I can see that the left hand side is same tan theta same theta value da adu vandu already proven correct appadina 1 is equal to 2 I am just equating the left hand side x by 4 which is equal to 12 minus x divided by 12 from this can you find the x value you people should find the x value adukapram we can just go for the next question and during that time I'll go and take some water also okay are you guys getting it idhila irundha x value da you need to find it quickly give me the answer da x by 4 will be equal to 12 minus x divided by 12. புரிஞ்சுதா? Everybody understood how to do it? Just வந்து geometry மட்டும் தான் பார்க்க போறேன். And also we will be substituting the laws of reflection here. அதுக்கப்புறம் we will be finding tan theta. We got it that the two sides வந்து right hand side வந்து equal தான். அப்படினா left hand side வந்து equate பண்ணலாம். And we will be getting very good. We will be getting 3 centimeter as the answer. Very good. Now let us move on to the next question. Okay, two plane mirrors M1 and M2 inclined at an angle 70 degree. A ray incident on the mirror M1 at an angle theta falls on M2 and then reflected parallel to M1. So in the question la first vanda, okay. So first vanda we should do one thing. Idhila diagram vanda you should draw. Okay. So first vanda you can draw the diagram. So what is actually they are saying? So ipo vanda two mirrors irukku. Okay, idha vanda first mirror, idha vanda second mirror. Okay, angle between them is coming as 70 degree. So this is what the reflecting surface also we have marked. Okay, so ippadi da mirror irukku. 70 degree da the angle between. Of course, in the few questions kapram we can go for the lunch break because already 1:30 irukku. In the two more questions mudinjadukku kapram we can go for it. Fine? All fine? Everybody tell me? Is it okay for you guys? 1:30 ki we can go for it. Ana, the thing is like in the break mudinjadukku appuram you should come back. Okay? Adu vandu promise pannanom. You should, everyone who are here, you guys have to come at sharp. I mean, once we have done with the break, na everyone should come on time. அது வந்து ப்ராமிஸ் பண்ணணும் இல்லனா I will be get angry. Okay, so now 70 degree la it is actually sitting. Let's see after the lunch break. You will feel sleepy and you will go and you will sleep. Okay, so I'm challenging you. I want this number of students after the session, after the lunch break also. Let's see. Okay, so இப்போ வந்து first line முடிஞ்சிருக்கு. Two mirrors வந்து 70 degree la place பண்ணிருக்கேன். A ray incident on the mirror M1. Okay, a ray incident on the mirror M1 at an angle theta. Okay, so let us say I'm just assuming in the point it is actually falling. So let me just draw the normal over here. So incident ray irukke, and what they have mentioned, it is idha vandu M1, idha vandu M2. It is actually making an angle theta, right? Theta. Mirror M1 at an angle theta falls on incident on the, okay, so incident angle vanda theta, we got it. Now after reflection what will happen? It will go here. Adukappuram what is happening? It is parallel. Okay, it is actually coming as parallel to the M1. Idudha vanda diagram. Okay va, purinjidada? Idudha vanda diagram. And what is the question? We should find this angle theta. Can you find it, everybody? Can you find the value? So how we will be finding it? So in the point la kuda I'm just marking the normal. Okay, in the point inga kuda this is coming, right? So now the thing is like ipo vandu incident angle theta. Okay, incident angle theta na definitely this angle is also going to be theta. Am I right or wrong? Yes or no? Now if this is 70, idu vandu parallel lines, appadina can I say idu kuda 70 degree aga pore? Can I say that? Very good. I can see the answers. Very good. Okay, now tell me according to law of reflection, I can say that incident angle and reflected angle will be same. So this will be theta, this is also going to be theta. Now I can say that idu vandu two parallel lines da. So adinala ipo vandu idu 70 na, this is also coming as 70 degree. Okay, everybody. Yes, now tell me guys, what is going to be? Okay, what is going to be this small angle? Tell me now, what is going to be that small angle? In the small angle vanda, what is going to be that value? What is going to be that value? Tell me. So we know idu vanda normal, right? So total vanda 90 degree irukum. Till this everybody understood? Till this everybody understood, yes or no? Very good, very good. Adu vanthu it is going to be 20, correct? So that will be coming as 20 degree. How we got it? Yena in the surface ku idu vanthu normal da. Appadina if this is 70, the small angle will be coming as 20. Okay, so now we know in the reflected angle the 20. So of course this angle, what about this incident angle? What about the incident angle? இப்போ வந்து இது வந்து 20 degree na reflected angle da we got it as 20. அப்படினா இந்த M2 ல இருக்கிற incident angle என்னடா? It is again ma'am 20 degree. Okay, that is again coming as 20 degree. Now how we will be finding the answer? Now we got almost all the angles. Now you can just find for theta. Now you can find for theta. Find it da everybody. Find it. Everybody find it. Perfect. So yes, definitely this angle theta will be coming as 50 degree. So we got this alpha, beta and everything. Now you will be finding this theta as the 50 degree. Okay, so on the triangle vandu you have to consider. So adula vandu we know and the normal will be coming to, so inga paakumbodhu here we can see idu vandu 90 degree and this whole we got it as 40 degree and this is what theta and total angle in a triangle vandu 180 degree da. So 90 plus 40 plus theta will be coming as 180. So now you will be getting 50 as this theta from this equation. Very simple. Okay, in the small triangle வந்து consider பண்ணனும். Okay, in the small triangle தான் வேணும். So 40 theta plus 90 degree will be coming as 180 degree. Done everybody? Let us go for the next question. Ready ada? Ready na? Give me a fire everybody. Next question ku ready na? Give me a quick fire. Adukapram we can go for a break. Yes. Let us go for the next question. So, in the given figure, find the coordinates of the image. In the madri questions vantena, very simple, very simple. People are thinking like this is a complicated stuff, but no da, just focus. So, in the madri, if you are getting object vandu inge da irukke. So, now the thing is like, first vandu, you should extend this mirror. You should extend this mirror. Okay, process vandu note panniko. First vandu what I said, in the mirror vandu extend pannanom. Adukapram in the extended line la you should draw a perpendicular line. Okay, you should draw a perpendicular line from the object. Okay, so what we said, first step enna, in the mirror oda length vandu extend pannanom. Just go for a straight line. அதுக்கப்புறம் இந்த objectல இருந்து you should draw a perpendicular line to the extended line. Okay, in the extended line la you will be going for a perpendicular and definitely we will be getting this. According to this, now you can see that what is this length? From the question, can you just tell me what is going to be that length? What is going to be that length? It is coming as -2, correct? It is coming as -2. Yena question la given. Now tell me, what is this angle? What is this angle? Tell me. What is this angle? Very good, Arun. Now tell me, what is the angle? What is this angle? It is coming as 45. Yena in the angle 45 na, this will also come as 45. Purinjida. Again, you will do the same thing over here. You will draw a perpendicular to this line. So this will intersect at this point. We know total vandu 90 da. So this will also coming as 45 degree. Now the thing is like you should find the coordinates of this point. Okay, angatha in the image irukum. Okay, angatha image irukum. So just focus over here. Understand the steps. What I said. Definitely we will be having a mirror and the mirror vandu extend pannanom. Adukapram object la irundha or perpendicular you have to draw. And the same point la irundha you should draw a perpendicular to the y axis. And the y axis la irukra point oda coordinate da inda image oda coordinate. அப்படினா of course we know இது வந்து y axis ல தான் இருக்கு. So அதனால x value வந்து 0 தான். So let it be. Now you should find this y value. In the length வந்து you should find. How you will be finding it? So we know that இது வந்து symmetric da, correct? 45 angle 45. Okay, so definitely what we will be getting, otherwise you can just go for finding tan 45. Okay, tan 45 will be giving you the answer. Illana sin 45 bodumla, sin 45. So just consider the small triangle. What is sin 45? What is sin 45? Opposite side. Let me just mark it as x. X divided by hypotenuse na 2 it will come. So sin 45 na 1 by root 2 da. So x by 2 will come. So 2 by root 2 na root 2 will be x in the distance. Okay. So this distance will be coming as, in the x distance one the coming as root 2. Okay. And same here 45 da. So definitely we can just find this length also, which is also coming as root 2. We can find this length also, and finally you will be getting this length is also same here. So you are going to get 0 and minus 2 as the coordinates. Purinjidada? So very simple. So we will extend the mirror, draw the perpendicular to the, image distance and object distance one the same arukumla. So we will be getting root 2. Here also we will be getting root 2. Adukapram you can just find this side over. Okay. So we will be getting option C as the answer. Very good, very good. Okay. Now let us do one thing. We can just go for a break. Okay. On a break kapram, you guys have to be here. We need to do more questions. Ray optics in mudiyalada. We have to focus more. Okay. So evlo time venoda lunch break? Lunch break evlo time veno? Lunch break evlo time veno? Sure. Let me see. Yes, ma'am. What up, it? Oh my God, Lakshmi. 20 minutes, everybody. 1:30, 1:55, 30 minutes, 40 minutes. Oh my God. 30, 40, 40, 30. Okay, let us go for a 30 minutes of break. Okay. Not 35, 25 minutes we can go for it. Sharp at 2 p.m. Okay. Okay, sharp at 2 p.m. you guys have to come back. Okay, I will be on time. You should also come on time. I want to see all these people at 2 p.m. Okay, so guys, namma like target irukke. So see you guys. We will continue with the ray optics after this. So see you da. Bye. Hello guys, are you guys here? Yes or no? Please let me know quickly. Quickly let me know the power of the students who are here. Everybody. Yes ma'am, yes ma'am, yes, hi. So let us, we are on time ma'am as we promised, yes, but I was a bit late because there was a meeting, so adnala konjam late irukada, but paravalla, like yeah, you got, I mean, so many students were asking 40 minutes, avangalukku vandu correct 40 minutes kadichirukke, correct? Yes, I'm late, I agree, I'm sorry. So let us continue. Yes. So now let us just continue with the concept part. Adukapram again we can come back and we can just study this. Ingada irukke. Yes. Next one, we are talking about the lateral shift da. Okay, we are talking about the lateral shift. So lateral shift na very simple. So let us say inga vandu oru glass plate irukke. Okay, inga vandu oru glass plate irukke. So let us say in the oru point la the light is incident at this point. Okay, the light is actually incident at this point. So which is making an angle I with the normal. Correct? It will be making an angle I with the normal. அப்படினா definitely after some time இது வந்து ஒரு rarer medium தான், இது வந்து ஒரு glass slab, so obviously denser இருக்கும். Again the light is emerging out to a rarer medium. So now looking at this diagram, you can see that when it is traveling from rarer to denser medium, it will bend towards the normal, and with the normal it will be making an angle R. Next thing is the light is falling at this point, so here also we have a normal, so this is again coming as R. Okay, this angle is also coming as R, and adukapram what is happening? So denser to rarer medium da, so it will be moving away or towards da. Tell me, moving away or towards? So இது வந்து denser to rarer da, so obviously velocity will increase, so there will be an emergent angle that is coming as E. So இதுதா வந்து whatever we are calling emergent ray. Okay, emergent ray, இதுதா வந்து whatever we are saying. Now the thing is like I just wanted to see, okay, இப்ப வந்து இந்த incident ray deviation எதுவுமே இல்லாம, okay வா? Till this everybody understood? Everybody please let me know da. Till this understood? Light வந்து it is falling on this interface, so adukapram it will just go close to this normal. ஏனா இந்த rarer mediathila irundha denser mediathila da it is coming actually. Adukapram what is happening da? Adukapram denser to rarer medium da, so adukapram it will just move away from it, and now it will be making an angle E with the normal. In the emergent ray is actually making an angle E with the normal. So இப்ப வந்து let us say if this light is not deviated at all, okay, light is not deviated at all, na, this will be go like this, correct? So this will be go like this. Okay, so the light will இப்ப வந்து இந்த incident ray deviate பண்ணலனா this will go in a straight line, correct? This will go in a straight line. அப்படினா definitely we can say that இங்க ஒரு separation இருக்குல்ல, that is what we are calling the lateral shift, which means in the emergent ray and the expected, okay, expected this incident ray will be parallel to each other. Got it everybody? Yes or no? So what I said, when the light is actually going through a glass slab who is having a thickness T, okay, adukapram what is happening? It will come with a emergent ray, and the emergent ray and ipo vandu in the incident ray deviate pannalena, that will also create a that is also coming as a ray which will be parallel always, and on the distance of separation between these two lines, the lateral shift, adukku vandu or expression irukke, and the expression da sin of I minus R divided by cos R into T. I na in the incident angle da, R na first refracted ana angle da, so that will be coming as R, and T na adoda thickness. So in the equation vandu you should study direct some years la idukku vandu values they will give, you should substitute and you should find the answer for it. Understood everybody? Everybody got it? Yes or no? So in the D, it is nothing but sin I minus R into T divided by cos R. Equation very important. Note panniko. So next the total internal reflection. Okay, straight we are going for total internal reflection. In the total internal reflection define pannanomna, adukku vandu two conditions da you have to define. First condition enna, in the light ray, okay, light ray should passes through total internal reflection da. So light should pass from the denser to the rarer medium, and also the incident angle should be greater than the critical angle. Just observe here da, just observe. So inga vandu oru point irukke. Okay, inga vandu oru point irukke. So this is actually making an angle, I mean this is what the normal at this point. Okay, so idu da vandu நம்ம denser medium, idu da vandu rarer medium. புரிஞ்சுக்கோ, இங்க ஒரு denser medium இருக்கு, இங்க ஒரு rarer medium இருக்கு. I have draw a normal at a point. ஏனா இந்த light is actually, okay, the light is actually falling to that particular point. So now tell me da, idu da vandu incident angle. After reflection, after refraction, in the angle, refracted angle vandu increase or decrease, which means in the case in the I will be less or greater than the R value. Quickly tell me da, everybody, tell me, quickly tell me. So quickly tell me da. Yes, of course, இது வந்து the velocity will increase, அதனால refracted angle வந்து இன்னும் அதிகமா இருக்கும். So let me call it as I1 and this one as R1. Now again I'm considering another point. So இங்கதா நம்ம normal. Okay, so the incident angle I'm increasing a little bit. Okay, incident angle I2 I'm increasing a little bit. So what will again happen? Incident angle increase aachuna, of course this refracted angle will also increase more. So refracted angle will be coming like this. Correct? So now again I'm considering another point. So idudha vandu in the point la irukra normal. Now focus over here da. I am increasing the normal again. Okay, so ipo vandu in the angle da I'm just calling it as I3. So in the point, what is exactly happening? We know that when we are increasing this incident ray angle, I mean in the incident angle increase agumbodhu, what is exactly happening? In the R2 kuda, it is actually increasing. Ana, oru particular incident angle, okay, or particular incident angle, what is exactly happening? In the refracted ray will passes through the interface, which means refracted angle vandu 90 degree agapore. Purinjida? Everybody understood? Everybody understood what I said? At a particular angle, at a particular incident angle, definitely in the refracted angle vandu 90 degree agapore, which means and the refracted ray will be passing through the interface. Appadina I can say this incident angle, in this case in the incident angle vandu I will be call it as critical angle. Appadina define panikoda, what is critical angle? When the refracted angle becomes 90 degree, the corresponding incident angle is nothing but the critical angle. So now the thing is like again if I am going for இதுதா வந்து நம்ம normal. Again if I am going for this more than in the angle I4 na actually வந்து more than the critical angle da. அப்படினா what will happen? It will reflect back to the same medium, which is known as the total internal reflection. Everybody got it da? Yes or no? Quickly tell me. So what I said, whenever we are talking about critical angle na refracted angle 90 agara corresponding incident angle da in the critical angle. Now the thing is like, even again if I am increasing the angle more than critical angle na, okay, incident angle vandu more than critical angle irukke, so definitely this will reflect back to the same medium. So adinala I will be call it as total internal reflection. அதுக்காக இருக்கிற condition தான் denser to rarer இருக்கணும் and in the incident angle should be greater than the critical angle. புரிஞ்சிடுச்சுனா give me a quick heart everybody. Everybody give me a quick heart if you understood. Everybody give me a quick heart. So now we are straightly going for prism. Okay, prism that we are going to study. So in the prism you know that. Okay, I will draw. That will be better, I guess so. Okay, so inga vandu oru prism irukke. Okay va. So I will draw it little larger. So usually vandu in the angle da we are calling it as the what is the angle of prism. Okay, thank you guys, thank you so much. Angle of prism na idha irukum. So now let us say I'm giving a ray. Okay, ipo vandu oru incident ray actually falling on the first surface. Okay, first surface of the prism in the incident ray is actually falling. Appadina inga vandu paakumbodhu we have a normal here. Okay, in the surface perpendicular oru line I have drawn. So definitely this angle is going to be the incident angle. Am I right or wrong da? Am I right or wrong? Incident angle is nothing but the angle between this normal and the incident ray. So now we know that compare பண்ணும்போது இது வந்து rarer medium da, இது வந்து denser medium da, இது வந்து again rarer medium da. So what will happen after the first refraction? This ray will come towards the normala illa away from the normala da. Quickly tell me what I asked. இப்போ வந்து இங்க ஒரு ray இருக்கு. இந்த ray ல when it is passing through the surface, it will be close to the what to say in the line illana away from the normala. Definitely rarer to denser, so it will come close to it. I will be call this as R1. புரிஞ்சுதா? I will be call it as R1 towards the normal. Very good, towards the normal. Now in the point again we should consider a normal. Okay, we should consider a normal. Okay, I have considered a normal. So this refracted ray will make an angle with this normal, which means adudha vandu namma what to say R2, that is actually coming as the incident angle for this face. Getting it? Okay, so adu vantha usually we won't be mentioning, even though we will consider. Okay Ganesh, listen here, idu vantha we will consider air, idu vantha prism. So usually vantha glass appadina in the air vida adukku refractive index adhigama irukum. That is what the understanding. Okay, so now in the surface la incident angle vandu R2 da, and when it is going out na again denser to rarer da, so it will move away. This is what the emergent angle, and this is what the emerged ray. Got it everybody? Give me a heart if you understood quickly. Okay, so now the diagram is over. Now I just wanted to know the deviation. What is deviation? I am assuming that இங்க வந்து medium change எதுவும் இல்லை. அப்படினா இந்த light வந்து இல்லைனா இந்த ray வந்து straight line ல travel பண்ணும். கரெக்டா? It will move in a straight line. அப்படினா I am assuming it will go like this. Okay, it will go like this. So first வந்து பாக்கும்போது இங்க ஒரு deviation இருக்கு. இந்த surfaceல ஒரு deviation இருக்கு. So I will be call it as delta 1. What is that? The deviation happened in the first surface. Now looking at the second surface, இதுதான் வந்து emerged ray. So I will just extend it back. Okay, I will just extend it back. So அப்படினா again there is another deviation which is nothing but delta 2. Okay va? Now the thing is like you can better go for finding this angle. This is what the deviation. So what I said as deviation will be nothing but delta 1 plus delta 2. Ennada in the delta 1, the deviation happened in the first surface. What is delta 2? The deviation happened in the second surface. Adoda sum da total deviation. Yena ipa vandu just consider da இந்த ஒரு triangle consider பண்ணிக்கோ. So what is this triangle? So இங்க வந்து பாக்கும்போது இது வந்து delta 1, இது வந்து delta 2, இதுதான் வந்து delta. அப்படினா we have studied in the triangle குள்ள இருக்கிற two angles ஓட sum வந்து will be equal to the exterior angle. So internal angles na delta 1 plus delta 2 da, which will be equal to delta. Got it everybody? So இதுதா வந்து diagram we should understand. Everybody got the diagram? Everybody draw the diagram in your book, yes or no? Quick-a tell me da. Quick-a tell me everybody. Quick-a tell me da everybody. Yes, perfect. So appadina we are getting this diagram. Now let us go for the sum of the information regarding this. First one you should know, okay, we should know that in the delta the total angle in the angle of prism vanda it will be coming as r1 plus r2 da. Idellame vanda and the diagrathil irundhe puriyum. Okay, so inga vanda paakumbodhu you can just see that idudha vanda angle, correct ah? So now you can just see that idu vanta will be equal to this angle A, correct ah? Yena idu vanta opposite da, so definitely this angle A will be same as this angle. Now you will be getting the angle A will be coming as R1 plus R2. Okay, now my question is, what is delta 1? Can you give me this delta 1 in terms of I and R1? Can you give me the answer? What I was asked, what is delta 1? Okay, what is delta 1 in terms of I and R1? What is going to be that? We know that in the total I in the angle, which means I which is equal to delta 1 plus R1 da. Okay va? My question is delta 1. Appadina I minus R1 will be giving you delta 1. Got it everybody? Yes or no? So ipo vandu we know that this angle will be equal to this angle. Appadina I will be equal to delta 1 plus R1. So now we will be getting I which is equal to delta 1 plus R1. Delta 1 will be I minus R1. So like this way, tell me da, what is going to be delta 2 in terms of E and R2? E and R2. Now I can say that this total angle, which means delta 2 plus R2 will be coming as this emergent angle. Now I can say delta 2 will be coming as E minus R2. So in the two expression we can just give it here. So adudha vandu actually, what is that? All slides getting confused. Order change achada. Yes, that one only. Okay, so idudha vanda actually we are getting A is equal to R1 plus R2, delta is equal to delta 1 plus delta 2, and on the delta 1 and delta 2 we have represented, we already saw it. And idhula vandu paakumbodhu R1 plus R2 na A da, we will be replacing it. So now you are getting this deviation which is equal to I plus E minus A. Understood till this everybody? Everybody understood, yes or no? Yes or no? Quickly tell me da. Till this four equations, everybody got it? In the four equations vandu avlo important da. Guys, marakama like kuda panikoda. Okay, so now yes Shahid, thank you Ganesh, thank you Arun, yes Lakshmi. So now we are going for another one. Okay, so inga vandu paakumbodhu oh my god, the slides, yeah. So inga vandu paakumbodhu we need minimum deviation, and the delta value illada adu vandu minimum ah irukanum. Only at a particular angle only in the minimum deviation will come, and in the rest of the whole angles, okay, ipo vandu you are just finding the deviation at any point na adu vandu the same deviation you can see for different, okay, two different angle ku vandu you can see the same deviation. It is only because of the what is in the light order reversibility property da anga kuda use pannite iruke. So inga vandu paakumbodhu just observe carefully. So I'm telling you one important point. Except this minimum deviation, okay, except this minimum deviation, ஒவ்வொரு பாயிண்டிலுமே, okay, ஒவ்வொரு பாயிண்டிலுமே definitely ஒவ்வொரு பாயிண்டிலுமே we can see that at the same deviation we will be getting for different angles. okay? Ana minimum deviation mattum is actually only for one angle. And on the minimum deviation kaga irukra conditions da whatever I have written here, adula vandu in the incident angle vandu it should be equal to the emergent angle, and in the R1 R2 illada the first surface la happening refracted angle, and in the second surface la incident angle. So idu vandu actually equal ah irukanum, and also appadina idu vandu equal na I can just put it as R1 which is equal to R2 which is equal to R. And what was A we said in the previous case? A which is equal to R1 plus R2 da. Appadina I can go for 2R. Appadina A by 2 da namma R value. Understood? Understood? Got it everybody? Got it everybody? So now A by 2 which is coming as R. Next one. Next one. We know we are going to, on the diagram we are actually going for the Snell's law. So when we are looking for Snell's law na, sin I by sin R, okay, what we said as I, incident angle na ennada, incident angle vandu inga vandu paakumbodhu you can just see the incident angle, we can just rewrite it as A plus delta m divided by A plus the minimum deviation divided by 2, and R vandu we already got it, adu vandu A by 2 da. So you will be getting the refractive index of the prism will be coming as sine of A plus delta m. Delta m na ennada? Delta m is nothing but the minimum deviation divided by 2 whole divided by this sine A by 2, which means sine R. Basically the Snell's law da. Mu is equal to sine I by sine R. Purinjidada everybody? Yes or no? Give me a heart if you understood quickly. Quickly give me a heart if you understood. Yes, 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 yes. Okay. So this is what the condition for minimum deviation, and also on the first in the prismathukkulla refracted ray irukelle, and the refracted ray should be parallel to the base, or let's say base of the prism. Okay, and the base ku vandu parallel ah irukanum in the line. Okay va? Got it? Yes, yes, perfect. So in the equations allame important, everyone should study all these equations, all the relations which I have mentioned, because yena idellame vandu they will ask. Okay, now for a thin prism na and the angle vandu it is going to be, and the angle of prism vandu it is even lesser than 5 degree. Adha vandu thin prism we are saying. Okay, it is going to be very small. Okay, it is going to be very small. In the angle vandu it is going to be very small na, we will call it as thin prism. Appa vandu paakumbodhu we know whenever we are substituting for the sin I and all, we know that mu is equal to sin I divided by sin R da. Correct ah? So ipo vandu in the case la thin prism na what will happen da, in the angles vandu, okay, in the angles vandu actually vandu paakumbodhu it will become very small. So now let us say I'm just focusing on the first surface. So idu da vandu normal, this is what the incident angle, and definitely refraction will happen. So idu da vandu R1. Correct? So now I can say that the refractive index will be sin I divided by sin R, and this angle, okay, angle vandu avlo small na, sin I will become this just I, and the sin R will become R. Appadina I can say that mu into R will be coming as I. Incident angle will be coming as mu into this angle. So idu vandu R1 da, so I will be writing mu into R1. Now for the same, okay, emergent ray kuda we will be applying this. So we will be getting, we are just actually in the sin I vandu we will write it as I. Yena small angle irundiruchina we can just make sin theta approximately to theta. So and the madri inga kuda we are just doing it. Next one is emergent ray. So emergent angle, adu will be coming as same application, we will be getting mu R2. Then we are just substituting in the deviation part. On the deviation la, we will be getting this equation. This is also an important relation which students used to miss this. Okay, they used to miss this equation. For thin prism, the deviation, okay, the deviation will be coming as mu minus 1 into the angle of prism. Okay, mu na and the refractive index da -1 into A da actually the deviation. And we know that the refractive index, okay, இப்போ வந்து white light பார்க்கும்போது you know that red to violet, okay, colors இருக்கு. So இதுல வந்து பார்க்கும்போது இந்த red கலருக்கு தான் refractive index கம்மியா இருக்கு, violet கலருக்கு தான் refractive index அதிகமா இருக்கு. அப்படினா refractive index value substitute பண்ணும்போது you will be getting the deviation will be very less comparing with the very less for the what to say நம்ம red color comparing with the violet color. All these points understood? Wave optics da, wave optics. Everybody understood? Quickly you can give me the what happened, Ganesh. Any difficulties with the video, audio, anything? Yes, violet will have more deviation, red will have less deviation. Okay, va? Yes, perfect. So now we are going for the angular dispersion. Okay, angular dispersion na very simple. Definitely when we are just talking about the prism, the white light is coming. So after refraction, what will happen? The light will split, right? The dispersion will happen. What is dispersion? What is dispersion? The splitting of light da, correct? Ipo vandu white light paakumbodhu it will split to 𝐓𝐺, correct? So what to say, that angular separation between, okay, so in the white light it will be spread as 7 colors. So in the violet irundha red varaikum it will be spreaded over, right? And the angle da actually namma angular dispersion. Okay, the angular separation between, very good. Okay, so the angular separation between the extreme colors, which means red to violet, idudha vanda namma angular dispersion. Usually idu vanda represent it as theta. Okay, it will be represented as theta. Appadina the deviation produced by violet minus deviation produced by this red color will be giving you the theta value. Okay, so this thing you can just substitute in the deviation equation and you are going to get mu v minus mu r into a. In the equations by heart pannikoda, because yena idukulla hardly vanda rare other questions they will ask, aanalum we cannot skip it. So equations vanda avlo better you can study. Angular separation na in the violet and red kulla irukra angle da. Okay, so appadina you should know the deviation produced by this, okay, into A da, you can just replace with the refractive index and into A will be giving you the angular dispersion. Next one the mean deviation. Simple, same thing da, okay, same thing da. Ana when we are talking about mean deviation, actually it is actually for the mean color na adu vanda yellow, which is actually coming in between, yeah. So adinala mean color na yellow color da. So this mean color order refractive index, okay, refractive index of yellow will be coming as the way we are finding the average value, yeah, and the madri we will be finding the refractive index of the violet plus the refractive index of the red divided by 2 it will come. Okay, divided by 2 it will come. Idha vanda refractive index of the yellow color, which means refractive index of the what to say, the mean color. Okay, yellow color na mean color da. And now you will be substituting in the deviation equation la, you are going to substituting instead of refractive index of any other color, you will just replace it with yellow color. Got it, everybody? Everybody understood? Yes or no? Please let me know quickly. Yes, of course, we'll get we will get. Sorry, you will get. Next one, the dispersive power da. Very simple. In the two values illaya, whatever we have studied over here, adoda ratio da in the dispersive power. Okay, so on the dispersive power will be coming as delta v minus mu r divided by mu y minus 1 it will come. Just you know what is this angular dispersion, you know what is mean deviation, adoda ratio da in the dispersive power. Okay, now the thing is like dispersion without mean deviation na, mean deviation in the delta y value vanda 0 da. Okay, when we are placing two prisms together, so adala vandu in the yellow color ku vandu deviation kedayadu. So that is what delta y is equal to 0. So on the case the deviation produced by the first prism and the second prism should be equal. Okay, next one is mean deviation without dispersion. Okay, dispersion na inga da irukke, dispersion, this delta theta must be 0. Okay, adha vandu we will be call it as achromatic. And the terms vandu konjam purinjiko, and the condition vandu purinjiko. If you are finding without mean deviation na in the delta y vandu 0 irukum, without dispersion na in the value leya, in the what is a nama angular separation theta value vandu 0 agapore. Okay va? So marakama like panikoda everybody marakama like paniko. In the page la irukra things vanda just you need to study the things, the equations, and try to understand what exactly it is. Okay, adu mattum podum, don't give much time for it, just the basic equations and the conditions. Now we are going for the refraction at the spherical surface. Okay, understood? Got it? Let us go for refraction at spherical surface. Ready ya? Ready na? Give me a fire da. Ready na? Give me a fire quickly. Refraction at the spherical surface. Refraction at the spherical. Okay. So now we know that இப்போ வந்து இங்க ஒரு spherical surface இருக்கு. Okay, இங்க ஒரு spherical surface இருக்கு. இந்த surface ஓட I mean this is what the spherical surface. Okay, so adukku vandu radius of curvature irukku illana center of curvature irukku. So the distance from the center point to the C will be radius of curvature, and also we can say that this will be coming as mu2 by V minus mu1 by U, which is equal to mu2 minus mu1 divided by R da namma value varapora. If you are considering a what to say namma refracting surface consider பண்ணும்போது this is what actually happened. Okay, so idha vandu mu1 and the refractive index for this surface is mu2. Equation vandu you should know, yena we are going for the lens, adula vandu these equations da actually vandu we are applying. Okay, so idukku vandu magnification irukku. Magnification is nothing but the image oda height divided by height of the object da. So in the equation avlo important alla in case of spherical surface, ana vandu lens la varumbodhu these equations we should study. So major in the equation you can just focus mu2 by V minus mu1 by U, which is equal to mu2 minus mu1 divided by R. So guys, marakama like panikoda. So next one we have convex lens and concave lens. So adoda ray diagram da exactly similar to, okay, exactly similar to mirrors. The light will follow the same path only, which means anga vandu paakumbodhu we will say pole, right? So in the lens kulla irukra center point. Okay, so lens kulla irukra center point vandu we will call it as optical center. Okay, we will say it as optical center. So idha vandu namma HEPC we will be doing it on 23rd, I guess so. Okay, so optical center da inge irukke. Instead of pole we will say optical center. Idu da vandu optical axis. Okay, and now we can see the axis over here. So idula kuda we will be having focus on both the sides. Radius of curvature will also be there on both the sides. And now the thing is like, it is actually combination of two spherical surfaces. Let us say I have two sphere. Okay, I have two sphere. I will be just combine this two. And this part is basically the lens. Am I right or wrong? Am I right or wrong? Yes or no? So, whenever we are talking about two spheres, okay, two spheres, when it is combining, okay, when it is combining, definitely we will be getting a common area. That is what the lens. So definitely, maybe sometimes what will happen in the spherical surface oda radius of curvature vandu R1 irukkalam and idoda vandu R2 irukkalam. So depending upon that, these values will also change. So that's the basic idea. And also, like the same way how we have discussed in the previous mirrors, ipo vandu ray vandu parallel na, okay, ray vandu parallel na, what will happen after refraction? It will go through the focus. Ipo vandu ray is coming through focus. Okay, if the ray is coming from the focus, now what will happen? It will pass us parallel to the principal axis. After refraction, it will pass us through, or let's say it will be parallel to the optical axis. Okay, va? So and the madri we will be having the rest of the cases also. If it is passing through the center of curvature, sorry, if it is passing through the optical center, it will just retrace its path. So these are the rules which we should learn, and exactly how we have taken the sign convention mentioned there, here also we will be taking the. So now the thing is like I'll go for the questions. So during that time we can just apply this. Okay. Now I'm not spending time for it. All the diagrams, the properties, everything I have marked over here. So in the class you are going to get the PDF, and the PDF you can just utilize. Okay. So next on the lens maker's formula. Okay, so if you wanted to make a lens with a particular focal length, you can use this equation. What is the equation? Mu minus 1 into 1 by R1 minus 1 by R2. R1, we know that in the lens is actually made up of two spheres, right? So the first sphere order radius the R1, second sphere order radius the R2. Okay, and inga kuda lateral and longitudinal magnification irukku. Magnification lateral, which means in the height change agulla. So adha the lateral magnification. Adoda equation, when we are comparing with the mirror equation, and the minus sign irukad, the rest is same. Okay va? So magnification oda equation just V by U da. Mirror la varumbodhu it is minus V by U da. Okay va? Next longitudinal magnification da. Longitudinal magnification, that is also same as how we have dealt with the mirror. It will also, longitudinal magnification will be equal to the magnification, lateral magnification or a square. Okay va? Next the power it is coming as 1 by F. F should be in meter, unit the diopter. Okay, that's the optical power. Till this everybody understood? Till this everybody understood? Of course. Yes, Oliva, we will do it. Okay? Everybody understood? Give me a quick heart. So spherical surface discuss பண்ணியாச்சு, lens also discussed. So இதல combination of lens எல்லாமே இருக்கு, அது questionல பார்க்கலாம். Because if I'm just explaining it as a concept, அது கொஞ்சம் confusing இருக்கும். ஆனா questions பார்க்கும்போது we can do it. Okay வா? Yes. So next one, I just wanted to introduce two new terms also. Two new terms. Okay, wow. Now, the thing is like, let us say, I'm just going for, thank you so much guys, thank you so much, okay. So, I'm talking about the spherical aberration. Yenada in the spherical aberration? This is lens, mirrors. So, it is actually based on, we know that we have studied parallel rays are whether it is on mirror or let's say in lens, what will happen? Parallel rays after reflection or refraction, what will happen? Tell me quickly in the chat box everybody. After refraction in the parallel rays will converge or diverge to which point? Which point? Tell me quickly. Which point le idu converge agunda? Yes, very good Aisha, it will be at focus, right? So now previously we mentioned about the paraxial rays. Paraxial rays, now what I said? What is paraxial rays? What I said? So in the principal axis kuda close arikara. Okay, principal axis kuda close arikara rays da nama paraxial rays. Okay, paraxial rays na, it is basically the rays which is coming close to the principal axis. So appadina in the rays which is close to the principal axis avanga correct and the focus illa converge illena diverge pannum. Purinjudha? Everybody understood? So now I'm talking about so not about the paraxial, the rays which is far from the principal axis, which means now we will be call it as marginal rays, which means the rays which is far away from the principal axis. Avanga correcta, they won't come to the focus. Purinjidada? So basically speaking, when it is paraxial rays, it will come to the focus exactly. It will converge or diverge to the exactly at the focus. Ana, pakumbodhu, when we are just observing the far away lines, even if it is parallel also, exactly avanga in the focus illa, they won't come to the focus. So adha we are calling it as spherical aberration, and the focus illa change varum. Okay va? Next the chromatic aberration. Okay, chromatic aberration na, it usually we can see in case of lenses. Okay, lenses illa in the chromatic aberration we will see. So lens oda focal length illa, we know that we are using refractive index, correct? So whenever we are talking about refractive index, red to violet over color different refractive index da. So adinala over color again this focus will be different. Okay va, if I'm talking about the what to say in the red color adoda refractive index different da, so adukku corresponding ana focal length kuda different da. Now I'm taking about violet la enna agum same refractive index is different da, so adanala focus kuda different ah irukum. Purinjidada? So in the two things also you should know. Now let us go for cutting off lens. Okay, cutting off lens illa, okay, we know that when we are just cutting through the optical axis, okay, through the optical axis if we are cutting na, and the focus and the focal length vanda it will increases, okay, it will double 2f agum. Okay va, now we are just we are just cutting parallel to the principal axis or along with the principal axis na, and the focal length vanda it will be remains the same. So in the 2 points you should note, when we are cutting through the optical axis in the focal length vanda double agum, and whenever we are cutting through principal axis in the focus vanda it remains the same. Understood everybody? Give me a like if you understood. Others you can just, those who have already given the like na, others you can give me a heart in the chat box. Everybody, quickly. Yes, so on the cutting off lens on the 2 points vanda avlo important, you should study. Okay, yes. So now, thank you guys, thank you so much. So now the thing is like we are going for the optical instruments. Adikapram in the chapter mudinchirke. Okay va? So now first one we will go for simple and compound microscope. Simple microscope na, it is nothing but the same which we are using. Ipo vanda unga grandparents ellam irundiruchna, they will be using a lens to read the newspaper and all. Adha vanda nama simple microscope. Okay va? So on the simple microscope la, we know that whenever, we need, basically in the microscope, okay, whenever we are talking about simple microscope, illana compound microscope, so idala vanda basically what is the purpose of it? We need the magnified image, correct? Okay, we need the magnified image, adha vanda purpose. Simple microscope, illana compound microscope na, purpose vanda we should get a magnified image. So on the magnified image vanda we will be whatever we are going to deal from now onwards, we should have a clarity. So we will be finding this for two, image should form at two different places. First one vanda namma capital D na enna, it is actually the least distinction, which means visible. Okay, when we are just trying to read something which is close to our eyes, we can't read it properly, right? But whenever we are just keeping it little far away, at some particular point you can just, this thing is very much visible. Correct? So, on the distance, the least distinction. Another one is image at infinity. Purinjidada? Image at infinity. So, now the thing is like when I'm talking about simple microscope, maybe they will say image is at infinity, or otherwise they will say eye is not stressed. இப்போ வந்து இந்த இமேஜ் வந்து இன்ஃபினிட்டில இருந்தா நம்ம ஐஸுக்கு வந்து அவ்வளோ ஸ்ட்ரெஸ் இருக்காது. கரெக்டா? அவ்வளோ ஸ்ட்ரெஸ் இருக்காது. So definitely we can say that when they are mentioning in the questionல, if they are mentioning, note பண்ணிக்கோ, if they are mentioning either the image is at infinity, இல்லனா eye is relaxed, இல்லனா stressed இருக்கல, or the magnification minimum. Okay, magnification வந்து minimum. So in the three cases இவங்க இந்த questionல இருக்கேனா, you should understand, அந்த questionல இருந்து you should understand the image should be at infinity. புரிஞ்சுதாடா? Image should be at the infinity. Are you guys getting it? Are you guys getting it? Yes or no? Yes or no? Everybody tell me. So three things we should understand. If the image infinity na, they will directly give infinity, or otherwise they will say eye is relaxed, illana stress irukalla, or otherwise they will say minimum magnification in the simple microscope, illana in the in the compound microscope use panni you should get a minimum magnification. Appadina you should understand image is at infinity. Now no, Arun, we will do it. That is what I said. The questions we can do it. That will give you more clarity. I think that will be better. So now, we are going for these two conditions. So simple microscope idha vandu idoda diagram varaporadhu you cannot see, right? Is it visible now? Is it visible now? Whitish. Now is it visible? Yes, okay, okay. So now the thing is like, இப்போ வந்து இங்க தான் object இருக்கு and the image is formed at this position, okay? So இதுல வந்து we will be only using one convex lens, okay வா? இந்த simple microscope ல one convex lens தான் இருக்கும் and the magnification ஓட equation in the least distinction ல தான் if you need the image na you can go for the magnification equation as 1 plus d by f தான் நம்ம equation வரப்போறேன். இப்போ வந்து இந்த what is a magnification is actually coming at the infinity na, which means and the image is actually coming at infinity na, adoda magnification vanda it will be coming as d by f. புரிஞ்சுதாடா? So this is what you should understand. Microscope la you will be keeping the object in between optical center and the focus. அப்படினா மட்டும் தான் you will be getting the magnified image. Okay, convex lens la magnified image வந்து you will be get it when it is in between focus and the optical center. And we have two things. Magnification வந்து we should do it for two cases. First case is the object is at infinity. Second case is object is at d, at least distinction. அதோட magnification ஓட equation தான் it is given. Okay வா? So next வந்து compound microscope தான். So compound microscope ல we will be having two lenses. Okay, we will be having two lenses. Here you can see. இதுல வந்து பாக்கும்போது இதுதான் வந்து objective lens. இதுதான் வந்து eyepiece lens. Eyepiece lens na it is nothing but நம்ம what to say which is close to our eyes. Okay, eyepiece lens na which is close to our eyes. Objective lens na adu vandu close to object ah irukum. Okay va? So in the diagrathula paakumbodhu you can see that in the object inge irukku. First vandu in the objective lens will produce an object over here, sorry, or an image over here. Okay va? So forget about the eyepiece. Now I'm just focusing on the what the first objective lens da I'm focusing. So adula vandu paakumbodhu in the object will produce an image over here and in the image da புரிஞ்சுக்கோ, இந்த image which is formed by objective lens தான் actually இந்த eyepiece க்கு image, sorry, object I mean it will change as the object for the what eyepiece. புரிஞ்சுதாடா? Everybody got it? So what I said, whenever we are talking about objective lens, and the objective lens will produce a image. அந்த image தான் actually இந்த eyepiece க்கு object வரப்போற and then this eyepiece will produce an image over here. Understood? So in the case la kuda we can produce the image at this capital D or least distinction, or also we can say that we will be producing the image at infinity as well. So idukku vandu magnification ku irukka equation vandu simple ah da irukke. Magnification oda equation will be coming as MO. What is MO? Magnification produced by objective lens. புரிஞ்சுதாடா? Magnification produced by objective lens. And ME. What is ME? What is ME? Tell me what is ME? ME is nothing but the magnification produced by the eyepiece. Okay, so idoda multiply பண்ணும்போது தான் you will be getting the magnification of the compound microscope. So now we can just see that the magnification at infinity la it will be coming as magnification of the objective will be always remain same, that will be VO by UO naught. Okay, so which means the image magnification. So basically when I'm talking about magnification, okay, when I'm talking about magnification due to objective, which means magnification or a general equation ennada, the image distance divided by object distance dana. So appadina what is going to be the magnification produced by objective? The image distance from the objective lens divided by the object distance. Correct? So இது வந்து common ஆ இருக்கும் both the case ல. When v is equal to infinity, when v is equal to d, in the magnification produced by the objective lens வந்து same ஆ இருக்கும். Now the eyepiece, magnification of eyepiece is same as which we have discussed in the simple microscope. Are you guys getting it? What I said? The magnification equation for the compound microscope is MO into ME. MO vanda, it is nothing but the image distance divided by the object distance. This is same both the cases. Even if you are finding it for V is equal to D, image vanda least distinction image distance vanda infinity in the magnification of the objective vanda same. Okay, so magnification, here I can write it as VO by UO, here also VO by UO it will come. Next one, the magnification of eyepiece. Inga what you have studied. Okay, now the least distinction na, what is the magnification? Inga simple microscope what we have studied? Adu vandu 1 plus D by FE da. So, inga varumbodhu what is the equation? D by FE da. So, this is the magnification in both the case. So, just you need to know, this is the magnification or expression. MO, it will be same for both the cases, and ME, it will be different, and that will be same as how we have done in the simple microscope. Purinjada everybody? Give me a heart if you understood. Okay, va? Got it. So, this is what is it? Compound microscope. Next one is astronomical telescope. So, telescope na D na least distinction. Okay, capital D na least distinction. Image on the least distinction. 25 centimeter la kadakkanumna, you can go for this. So now astronomical telescope da. Astronomical telescope na, we know that in the stars, in the celestial bodies, far away irukra objects we need to get to see. Magnified form we need to get. Adukkaga the astronomical telescope we are using. Idhula kuda two lenses irukum. Okay, two lenses irukum, objective irukum, eyepiece irukum. Now my question is, in the compound microscope compound microscope eyepiece illa objective, which one was bigger? Eyepiece illa objective? Previous case in the compound microscope eyepiece illa objective, which one was larger? Do you remember that? Thank you so much for the hearts, guys. Now tell me quickly, tell me. Yes, bigger one was eyepiece da. Ana inga varumbodhu, in the telescope la varumbodhu, what will happen? In the astronomical telescope la eyepiece da smaller irukum. Okay, which one is close to our eyes, adu vanda smaller irukum. Objective vanda, it is going to be larger. And now the same process da, first objective lens will produce an image, and the image vanda in the eyepiece lens object act pannum, and that will be producing the image. Idhula kuda magnification irukku. So on the magnification we should get two equations. First one V infinity. Okay, image distance infinity na, idha magnification varapore. And the time the length of the tube na, it is nothing but the distance between two lenses. Okay, in the objective and eyepiece distance of separation da tube oda length, capital L represent pandrathu. So if you need to get the image at infinity na, this magnification will be simple FO by FE, which means the focal length of the objective divided by the focal length of the eyepiece. The length of the tube it is going to be the sum of these focal length. Next one is, if you need the image at the least distinction, definitely this magnification will be FO by FE into 1 plus FE by D. Yes, Arun, very good. Okay, then the length will be FO plus DFE divided by D plus FE, it will come. So, this is the astronomical telescope we need to study. So, to overcome all the problems which we have mentioned in the astronomical telescope, which means usually for the lenses, to overcome that and to reduce the expense, we are using the reflecting telescope. Okay, reflecting telescope na anga we are actually using the mirrors. Mirrors or the reflection use pannida, we are actually doing the or we are actually observing the image. Okay, whatever be the problems. Okay, V na, where is V? Image distance. Okay. So now this is what we need to understand from this optical instruments. Optical instruments you should know the diagrams ellame vanda in the PDF la irukku. After the class you can just go through the diagrams and you can understand everything, and all equations were very important. Okay, so now let us just continue with the question practice. So we were actually reached at this point, I guess. So yes, answer, yeah, this we have done. Yes, so this is another question, multiple images formation. Okay va? Okay, done? Is it okay now? Visibility, everything is perfect, right? Major the volume 2 we will finish today, and we will discuss some of the first volume high weightage chapters quick we will revise. We already did those chapters recently. 2 days back we have done the first volume chapters we already done. So there will be on the chapters I will just have a quick revision, and definitely question practice tomorrow irukku. Okay, tomorrow you will be having the question practice as well. Okay, so now inga paakkumbodhu we have two parallel mirrors. Okay va, inga M1 irukke, inga M2 irukke, and what is given here? There is an object O, okay, placed in between the mirrors at a 5 cm from mirror M2. What are the distance of first 3 images from M2? First 3 images from M2. So understand, first of all, okay, just focus over this mirror. I will explain this. If you can't understand, I will repeat, no worries. Okay, so ipo vandu paakumbodhu 5 cm, okay, in front of this M2 mirror, 5 cm in front we have an object. Appadina plane mirror illada, so object distance 5 na, what is going to be the image distance? What is going to be the image distance? What is going to be? Evening la da class da Ganesh. What is going to be the, tell me da, what is going to be the image distance? What is going to be the image distance? Quickly tell me. Of course, I saw it will be coming as 5. So this will be producing the first image at a distance 5. Okay, so now the first part is clear, and we can see that all the options is containing 5, so we cannot finalize. Now coming to the second image. Okay, so now you can see that this is 5 cm, this is also coming as 5 cm. So now you just think about M1. Okay, think about M1. For this M1, actually this one the first image da. Correct? This one the first image da. So now if you are looking at this one, in the M1 in the first image, or let's say in the M1 in the image illaya, in the image formed by M2, adu vandu object act pannu. Okay, it will act as a object. Appadina tell me da, what is going to be that object distance? For this M1, what is going to be this distance? What is going to be this distance? Tell me quickly. Tell me quickly, everybody. What is going to be the object distance? Ipo in the M1 if it is thinking about this point, okay, appadina what is going to be that image, object distance according to this one? Of course, idu 15 da, idu 5 da, so definitely 20 meter apart, okay, 20 centimeter apart. This, due to this one, it will be creating a image. Correct ada? Now again, for this M1, this is going to be the first object, right? So what is this distance? Can I say idu 10 centimeter? Can I say this is 10 centimeter? Yes or no? Yes or no? Tell me da. So now this 10 centimeter nala, this will be creating an image which is also coming as 10 centimeter, which means in the M1 is actually producing an image which is coming 10 centimeter away. Are you guys getting it? Okay, are you guys? No, 20 centimeters not the answer. Just hold on, because idu vandu M1 produce pannirukra image illaya, ana question la M2 produce pandradha venum. Okay va? So now tell me, இது வந்து ஒரு image, இந்த M1 actually produced this image. Correct allada? So this image will become the object for M2. அப்படினா இந்த distance of separation என்னடா? இந்த distance, இந்த objectக்கும் இந்த mirrorக்கும் தமிழ், I mean அந்த distance என்ன ஆக போறே? அந்த distance என்ன ஆக போறே? This will be nothing but 25 centimeter. 15 plus 10, that will be 25 centimeter. So which means the first image formed by M1, okay, first image formed by M1 will produce a image which is at a distance 10 centimeter from M1 and which is at a distance 25 centimeter from M2. So now if you are looking at the diagram, this M2 will feel like this is an image, I mean this is an object for it. So definitely it will produce a, or I mean it will produce an image. What is going to be that image distance? Idu vandu plane mirror. So on the second image vandu, it will be actually 25 centimeter away. So we can say that 5 centimeter, 25 centimeter. So this is going to be the second image formed. Okay va? Purinjida everybody? Yes or no? Yes or no? Okay. So now we already said here we have, I mean in the M1 actually this image order image one, it is actually created 20 centimeter away. Now this will become the image for this M2. And what is the distance? What is the distance? In the M2 consider பண்ணும்போது, what is this distance to the second image formed by M1? What is going to be that? 20 plus 15, which is coming as 35. So the third image will be 35 centimeter away. Hence we can say that option C is going to be the right answer. So simple if you are considering, okay, simple if you are considering na, இதுதா வந்து நம்ம M2, இதுதா வந்து நம்ம M1. இங்கே தான் object இருக்கு. What is the distance of separation da? 5 centimeter. So first image formed by M2 will be, no confusion, 5 centimeter la it will be producing the first image. Okay, it will be producing the first image. Now looking for this M1. So in the M1 பார்க்கும்போது, in the distance is given in the question, that is nothing but 10 centimeter. Okay, so in the 10 centimeter இருக்கு. So due to this, in the 10 centimeter நால M will create, okay, M1 will create an image which is also 10 centimeter away. Okay va? So the first image produced by M1 will be 10 centimeter away from M1 and 25 centimeter away from M2. Am I right or wrong? 25 centimeter away from M2. அப்படினா carefully பார்த்துக்கோ. This image, okay, this image formed by M1 will act as an object for M2, and due to this distance of separation, the second image will be formed 25 centimeter away. Now again coming to back to M1. So M1 பார்க்கும்போது, again you can see that 10 centimeter, 5 centimeter, 5 centimeter. So in the image இல்லையா, இந்த I1 நால, so total distance of separation வந்து, it is coming as 20 centimeter. So this will be creating, okay, this M1 will be creating an image which is 20 centimeter away, which is nothing but the image of I1. Okay, image of I1. And in the image, okay, in the image will become an object for M2. So this distance of separation வந்து 35 centimeter da. So 35 centimeter la you can see another image I3 over here. Understood na? Give me quick heart, quickly give me a heart. Next question. Okay, find the velocity of image in the following case. Okay, find the velocity of image in the following case. Okay, let us go for it. So இப்போ வந்து, if you are just giving quickly response na, ma'am got it na, அது வந்து I will skip and we will go faster. Okay, and I'm not getting that response. அதனால தான் I'm just taking a lot of time. Okay, so now In the question we know it how to deal with it. What is the question? Velocity of the image da venum. So first what we will do da, we will just make it into components. Okay, so 10 centimeter the object oda velocity varapore, and we can just make it into components. Tell me what are the components. What is going to be the parallel? Okay, what is going to be the parallel and perpendicular component? Tell me. 37 degree da, 37 degree. Appadina, tell me da, what is going to be that? Brightness I will reduce. Now is it okay? Is it okay now? Is it visible? This is 3 root 2 meter per second. Angle 45 degree. So now tell me what is VO perpendicular and what is VO parallel. Quickly tell me, everybody. Quickly tell me. So the parallel and perpendicular component da we needed. So tell me what will happen. This is 8 meter per second because 10 cos 45 da. This is 10 sin 45, sorry, sin 37 da. So it will be coming as 6. Okay. So this is the parallel and perpendicular component. And same for this mirror, we will be getting this is 3. This is also coming as 3. Understood? And what was the thing which we have mentioned? The velocity of object with respect to mirror, the perpendicular component, will be equal to minus VIM perpendicular. Correct? Now let us just expand this. So what will happen? VO perpendicular minus VM perpendicular, which is equal to minus VI perpendicular plus VM perpendicular. Okay, va? Okay, va? Everybody is getting till this, yes or no? Please let me know, da, everybody. Please let me know. Give me a second, da. Just a second. Okay, so done. Okay, set. So now what happened? We can say that VI perpendicular da we need it, right? VI perpendicular da we need it. So now we can say that this is 2 VM perpendicular da, and this one will become minus VO perpendicular. 2 into what is VM perpendicular according to this? Hey Aisha, vector da, vector 10 centimeter. This is 10 cos 45. This is 10 sin 37. Okay. Yes. So now tell me what is VM perpendicular from the diagram. Tell me what is going to be that. Quickly tell me da. Quickly. Hey. Simple ana calculation lada. Just observe the diagram and tell me what is VM perpendicular. The perpendicular component of velocity of mirror. What is that? We know it is nothing but 3. Are you guys getting it? Yes or no? You are not responding, and that is what confusing me a lot. So this will be coming as 2 into 3 minus this perpendicular component for this object will be 8. So this will be coming as 6 minus 8, which means minus 2. So the direction will be minus 2, and it is indicating coming in the opposite direction, and that will be along the x-axis. So we will be getting minus 2 I cap. So first term we got it minus 2 I cap. next one வந்து பார்க்கும்போது இந்த mirror move பண்ணாலும் இல்லனாலும் the velocity of the parallel component of velocity வந்து change ஆகாது. We said on the river case we have explained no. So whenever if it is moving perpendicularly or sorry whenever it is moving what is in the in the image object inge irukke and the what is in the vertical direction la if the mirror is moving nalum that is going to be with angle. How to write numbers hey vectors da. So I have done the basic mathematics and vectors chapter, please do watch da please. Okay, puriyalaya idu vandu you couldn't understand, so let me just go for it here. 10 centimeter da namma velocity, correct ah? Yes or no? You guys at least if you can't understand na please let me know, I will repeat. Ipo vandu if you are not responding na I can't understand anything. Okay, so yeah, observe here, idu vandu 10 centimeter, correct ah? Idu vandu 37 degree da. So appadina definitely we can just make this into component. So this will be coming as 10 cos 37, which means by substituting this you will be get 8, and this will be 10 sin 37, which will be nothing but 6. Okay, so அந்த மாதிரி இங்க இருக்கும்போது this will be 3 root 2 sin cos 45, and here it will be 3 root 2 sin 45. So this will be coming as 3, this is also coming as 3. Understood till this? Everybody give me a thumbs up if you understood till this. Understood na? Give me a thumbs up quickly. Thumbs up or heart, anything. I wanted to know whether you guys are getting it. Yes. Now the thing is like we have studied a relation. Okay. So ipo vanda we know that, just go back to the notes. The velocity of object with respect to mirror in the perpendicular direction will be equal to minus v im perpendicular. In the relation vandu we already wrote in the beginning, correct? In the velocity discuss பண்ணும்போது we have discussed this. Now I am going to expand this. So vo perpendicular minus vm perpendicular, which is equal to minus vi perpendicular plus vm perpendicular. Idu kuda we have written there. Okay, wow. So now the thing is like I want the perpendicular component of velocity of image. So I'm taking this, the rest all I'm taking over there. So vi perpendicular will be coming as 2vm perpendicular minus vo perpendicular. Till this everybody understood? Till this everybody understood? So these are all we have just discussed previously. Okay, wow. So now the thing is like 2 into the perpendicular component na idudha vandu perpendicular component. So vm perpendicular na in the velocity of mirror oda perpendicular component adu vandu 3 da, minus in the object oda perpendicular velocity adu vandu coming as 8 da. So which will be giving you minus 2. And which axis it is? X-axis. So can I write it as I cap, yes or no? Minus 2 I cap can I represent? Why that minus sign? Object vandu ippadi na, image vandu ippadi da poga poren. Okay va? And also ipa vandu in the image oda perpendicular component vandu we got it. Now the thing is like we should know the parallel component, and the parallel component will be exactly equal to the parallel component of object. Yena in the mirror vertical motion of mirror la we have mentioned in the component whatever be the velocity of the mirror adu vandu it is not affecting the object or image oda velocity in the vertical direction. Appadina in the object oda vertical direction la irukra velocity vandu 6 da, and that is in the upward direction. So image will also move in the upward direction. Yena vertical direction la direction vandu change agada. So you will be getting the component as 6j cap. So the answer will be minus 2y cap plus 6j cap it will come. All understood? Yes or no? Everybody got it? Yes or no? Please let me know in the chat box. So idhula vandu inga varaikkum we have just done previously. Just we are applying the values. Avlo da irukke. Okay. So values vandu we already found the components, we have just substituted. Done? Okay, now let us move on to the next question. Ready, Ada? Ready na fire? Ready na? Give me a fire quickly. Everybody give me a fire quickly. Ready na? Give me a fire quickly. Yes, yes, yes. So now we are moving on to the next question. In the question, ungalala you can do it. Okay, va? Converging rays are incident on a convex spherical mirror so that their extension intersect 30 centimeter behind the mirror of the principal axis. The reflected rays extension intersect the principal axis at 1.2 meter behind the mirror and determine the focal length of the mirror. This is the question. Okay, va? So, this is a convex spherical mirror. Okay, so convex spherical mirror, which means ippadi. Okay, vada. So, what are the given datas? They have given the image distance. Image distance it is coming as 120 centimeter. And now the object distance also given, that is also 30 centimeter. That is also behind the mirror. So, definitely that is also coming as positive. Okay, now it is a question to find the focal length. So, you can just use the equation 1 by f, which is equal to 1 by v plus 1 by u. Now, you can just, not spherical surface, it is spherical mirror order question da. So, simply you can find the answer. I'll just come in a minute. Okay, so find the answer and give me the answer in the option. Everybody done? Yes, 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 yes. I can see lots of right answers. Very good. The option A will be the right answer. Now let us move on to the next question. Ready? Ready? Give me a fire quickly. Give me the fire quickly. Okay, so now let us move on to the next question. Okay, 2 points P and Q lie on either side of the axis XY. Okay, so axis the XY da. And we have this 2 points P and Q. Real image of P at Q using a spherical mirror with XY as the optic axis. The mirror must be. Read the question carefully, da. Okay, no more breaks, da. Not immediately. We can just go for a break at 5. Okay, because just now only we came after the break. So now in the question la, okay, in the question la, how we can just do it. So we need the real image. Okay, real image can produce which type of mirror, da? So tell me, derivations are important because this is MCQs, but for few derivations you should know because on the derivation you are applying, that is important. So very good, very good, very good. So in the moment, in the last 15 days, don't go for this derivation and all if you are starting from 0. Just focus on the formulas. Like this chapter, how I have dealt with. So the same way you can go for it. So idhula vanthu converging arkanam, correct? Converging arkanam, yena we need the real image, okay? And real image na it should be on the same side of the object, correct? So appadi na what will happen da? What will happen? So we should I mean of course converging la answer kadachudhu and position with left of p da irukkanum, okay va? So simple ah sonna, so in the case la inga xy axis irukku, point p irukku, adoda real image da form pananum. So real image form pannanomna definitely adu vandu converging ah irukkanum, ena diverging ku vandu virtual image mattum da possible ah irukku. So real image na adukku vandu you should go for the converging lens, and also the position with the left of p na mattum da object vandu appadi irukkanum, because we need the what to say in the what to say we need the real image. So adanal in the mirror side la tha illa object side la tha in the image form pannanom, adanal left side la tha irukkanum. So next question quick ah pogalam. Figure shows a spherical concave mirror with the pole 0 0 and principal axis along x axis. There is a point of object -40 and 1 centimeter. Find the position of the image. Okay, so idhula vanthu object distance irukke, height of the object irukke. Now the radius of curvature is also given. So now you can find the focal length, and the question is image. Okay, which equation we can use? Quickly tell me da. Which equation we can use in this case? Which equation we can use? Which equation we can use? R is equal to 2f da, so idu vandu 5 ah irukum. Very good. F vandu 5 da. So first vandu you can go for 1 by f, which is equal to 1 by u plus 1 by v. Okay, so in the equation la irundhu you can find the image distance, which means x coordinate vandu you can find it using this. Once you got it, you can go for hi by ho, which is equal to minus v by u. Adila irundhu you can find the height of the image, which will be giving you the y coordinate. Yena question la x and y coordinate we have to find. And also in the case la x coordinate you need to just find the x coordinate, yena one time the no options are repeating. Okay, so adanala you can just go for it. So now you can just substitute the value. F vandu -5 da, and height of the object vandu +1 da, u vandu -40 da. Substitute and give me the answer quickly. 1 by -5, which is equal to 1 by -40 plus 1 by v. Idhila irundhu you can find v. Once we got it, substitute the v value over here. So what about the v value? V value is going to be positive or negative. Adhe logic use pannalam. What is going to be the not option C? Check again. Check again, check again. So in the v value vandu you will be getting -40 by 7 centimeter. Now this you can just substitute here, even though once you get the answer, option B is very, got it, that is done. Okay, ana vandu the thing is like we know, we should know the process, right? Adakaga in the hi value you can find it. Hi na y coordinate da, so hi will be minus v by u into ho. So minus v na it is -40 by 7 divided by 40 into 1 da. Okay, again this will be minus. U value is also minus da, and also here there is another minus sign. Yes, done everybody, got it? Yes, perfect. So now let us quickly go for the another question. An object is placed a distance of 15 centimeter in front of the concave mirror of focal length 10 centimeter. Concave mirror da, so object or a distance vandu u 15 centimeter da, so object distance will be -15. And here in this the focal length is 10, again still concave mirror da, so f will be -10 da. Next one determine the distance of image and magnification. So again similar question, I'm not going for it. 1 by V plus 1 by U, which will be giving you 1 by F. Once you got it, you can go for minus V by U. Okay, so once you got this, once you got this V value, you can substitute over here. So the U value will be coming as minus 15 centimeter and this F will be coming as minus 10 centimeter. Yena idu the concave da. Okay, va? So now let us go for another question. Another question. So few questions I'm skipping here. So now this question is a direct application da. Okay, I'm not doing it. I will explain this. So this is nama glass slab la irukra what is in the deviation illiyada adudha vandu question varudha. So idhula incident angle 60 is given and refracted angle 45 degree is given. Thickness is also given 10 centimeter. Now it is asked for the lateral shift. Okay, the lateral shift. What is going to be the lateral shift? Yuvraj, all the rest of the questions which I'm not doing in the class, adu vandu homework da. Okay, so in the class PDF kadake pore, so on the PDF you can just take all the questions. Okay, va? So in the lateral shift the question, so lateral shift order equation we know, sine of I minus R into T divided by cos R da. All values are given in the question, just the substitution. Should I explain this, yes or no? Yes or no, tell me. Eye paining. For everybody you need a break. Is it required? Just now only we just done with the break. No, 1.5 hours I guess so. Should we go for it? No, right. Let us continue. Okay. By 4 o'clock I will give you break. Is it okay? 4 o'clock I will give. Because now epo mein break we can't just finish it. Even still first chapter still we are doing it. I think it's almost 4 hours. Not 4. More than 4 hours. Okay, because in the ray optics avlo detail you should know adu I felt so. Okay, yes. So now in the question a man is standing on the edge of 1 meter deep swimming pool completely filled with idoda refractive index root of 3 by 2 da. Okay, the eyes of the man is actually root 3 meter above the ground. A coin is located at the bottom of the pool, appear to be at an angle of depression 30 degree. This is the angle of depression, which means you should turn your eyes this much to see the coin. Okay, 30 degree with the reference to the eye of the man. Then the horizontal distance of the coin from the eye. Okay, so this is what actually X. It is not given in the question. This is what actually X. The horizontal distance we need to find it. How we will be finding it? Okay, so simple. Is this question feeling difficult? Anybody? This question is feeling difficult? Yes or no? Thank you, Samsida. Thank you so much. So tell me quickly. So in the question complicated, easy. இதுக்கு எல்லாமே பேசிக்கா மேக்ஸ் புரியணும்டா ஜியோமெட்ரி மட்டும் தான் இங்க கூட யூஸ் பண்ண போறேன் ஓகேவா சோ இதுல பாக்கும்போது I wanted to consider 2 triangles okay 2 triangles தான் வேணும் so just focus over here da can I say that almost this distance and this distance will be same because in the eye level la irukke so can I say that these two distance will be same let me just call it as this is y same as y here can I say that yes or no please let me know now just consider this triangle in the one triangle consider panniko so this will be root 3 in the angle given 30 can we find this y we know one side and one angle. So can we find it yes or no? Can I go for tan 30? Tan 30, what is tan 30? Opposite side which means root 3 divided by y. Appadina y will be root 3 divided by tan 30. Correct? So now tell me what is going to be y value? What is going to be y value? Quickly tell me. What is the y value? Everybody tell me da. What is going to be y value? What is going to be y value? Quickly tell me. Very good. So this will be coming as 3. Yena tan 30 vandu 1 by root 3 arukum. So it will be going on the top and we are getting y is equal to 3. So this part is sorted. Okay, this part is sorted. Next vandu in the small distance da venum. Okay, small distance da venum. So can I say that in the angle vandu 60 degree? Can I say that? Idu vandu or perpendicular da. So idu vandu 30 na, idu vandu 60. Which means incident angle is 60 degree. And can I say idu da on the refracted angle? Can I say this is the refracted angle? Now, can you find R? How we will be finding R? How we will be finding R? Quickly tell me how we will be finding R. Can we use the Snell's law? Yena inga is actually happening the refraction, right? So can I say that sin I divided by sin R will be the refractive index? What was the refractive index? Root 3 by 2. Am I right or wrong? It is coming as root 3 by 2. Okay. Very good, very good. Snell's law da we will be using. Now sin I na ennada sin 60 da. Sin 60 oda value enna root 3 by 2 da sin 60 oda value divided by sin R will be coming as root 3 by 2. Can I say this? Can I say this? Yes or no? Everybody tell me. Can I say this? Appadina tell me what is going to be the R value. What is going to be the R value? So this will be coming as root 3 will be get cancelled and in the 2 will be coming over there. So I'll be getting sin R will be coming as 1 by root 2. So R na, it will be coming as 45 degree. So I got this angle as 45 degree. Okay, and I know ipo vandu in the small triangle consider pannina, okay, in the small triangle consider pannina, in the side vandu I know 1 meter, angle also I know 45 degree. Now tell me da, what is this going to be the small distance? What is going to be that small distance? Let me just call it as A. Okay, what is going to be that distance A? Again we can go for tan 45. What is tan 45 according to this triangle? Opposite side, which means A, divided by adjacent side, which is 1. Tan 45 na 1 da. So we will be getting the small distance is 1. Already in the y one the 3 da. So 3 plus 1 it will be coming as 4 da. Nama answer varapore. Understood everybody? Everybody got it? Everybody got it? I mean, in the question la millimeter la da we need to find it. So this will be coming as 4000 millimeter. Okay, so we will be getting answer as option C. It is sorted. So this is the refraction another question. Can you find it? Can you do it? Can you do it? Do it. Nice question, beautiful question. So now tell me the refractive index of the material of the prism. Okay, adudha vandu we need to find it. So adukkaga what we can do, refractive index na, it is nothing but sin I by sin R da. Correct? Sin I vandu we know it is sin 45 da. Now tell me what is going to be sin R. Can we find it? Can we find that value? Yes or no? Can we find it? So using the geometry we can go for it. Correct? So idu vanda 60 degree arukum. If you are considering this triangle na, okay, idu vanda 30 degree, idu vanda 90 degree na, this will be coming as 60 degree. And what about this line and the surface? What about this angle? What about this angle? What is this angle? What is this angle? Idu vanda 90 degree da. Okay, idu vanda 90 degree da. Appadina this angle will be coming as 30 degree. So now you got sin 45 divided by sin 30 will be giving you the refractive index. We will be getting the refractive index. So now I was also done with ray optics, but there are many questions, guys, many questions. Paravaillada naalekku vandu PYQ session irukke, adula vandu we can just solve all the questions. Now let us just quickly go for the wave optics. Okay, பரவாயில்ல நாளைக்கு 5 மணிக்கு. Okay, 5 o'clock we have this session. So adila வந்து இந்த questions we will discuss. No worries on it. Okay, so because it is almost for 5 hours, not 5, 4 hours. Correct? So 4 hours la almost, not for 5, almost 5. Okay, so இப்போ வந்து okay, இப்போ வந்து we can just do these questions tomorrow. No worries. Okay va? All good, all good. Now let us go for wave optics. Ready? Ready now? Give me a fire da. Current electricity kuda Aisha we have just done. Okay. Last class I think 3 days munnadi the current electricity we have done. Before next chapter little break. Okay, let us go for a 10 minutes break then. Okay. Can we continue by 3:55? Okay. 4:10 வரைக்கும் break ஆடா. No way at all. Okay. Okay, so the timing will be, we will resume at 3:55. Okay. Sharp, you guys should come. Okay, va? Thank you. So yes, Shahid 7 years இருக்குடா. So எப்படி எல்லாரோட preparation எப்படி போகுது? Is it all going good, well? Tell me everybody. So how was the NEET preparation? All going well? Yes or no? பயத்துலையா போகுது மேம். மேம் கிளாஸ் எடுத்துட்டேன். நவ் ரெடி மேம். பயமா இருக்கு மேம். நோடா இந்த மாதிரி பயம் எதுவும் தேவையில்லடா. We have to anyway இது வந்து நம்ம லாஸ்ட் சான்ஸ் தான். ஓகே 15 days இருக்கு. As I mentioned, no, இப்போ வந்து ஒவ்வொரு சப்ஜெக்ட்லுமே you can just make sure some sort of what to say இப்போ வந்து யுவர் டார்கெட் இஸ் 500 இல்லைனா 600. ஸோ அந்த மாதிரி ஒரு டார்கெட் ஃபிக்ஸ் பண்ணி அது வந்து சப்ஜெக்டில் யூ ஸ்பிளிட். ஓகேவா? அண்ட் இந்த டைமில் ஐம் டெல்லிங் யூ பயாலஜி தான் ஐ மீன் உங்களால் யூ கேன் ஜஸ்ட் ஸ்கோர் பெட்டர் இன் த லாஸ்ட் ஃபியூ டேஸ். ஸோ அப்போ வந்து பயாலஜியில் அவ்வளோ ஐ மீன் லைக் 300+ இல்லைனா 330 அவ்வளோ மார்க்ஸ் வந்து செட் பண்ணிட்டேன்னா கெமிஸ்ட்ரியில் 100 அண்ட் ஃபிசிக்ஸில் வந்து 80 போதும். ஸோ அப்படின்னா ஆஸ் ஐ மென்ஷன் இந்த ஒரு சாப்டர் ஐ மீன் இந்த செஷன்ஸ் இந்த மேரத்தான் செஷன்ஸ் அண்ட் த அப்கமிங் PYQ செஷன்ஸ் எல்லாமே வந்து இஃப் யூ ஆர் attending-na, I think that will help you. No worries on it. அதுக்கு வந்து இப்போ வந்து பயம் மறந்துருச்சுன்னா nothing else can be done, right? பயத்துக்கு what we can do, we can I mean we will be get in a panic situation and நம்ம preparation timeல we can't concentrate. So அதனால let it be டா. உங்களால முடியறது I mean whatever be the things you can do it. அது வந்து you can just continue. அவ்வளோதான். அனன்யா ரைட். அனன்யா இது வந்து எல்லா ஸ்டூடெண்ட்ஸுமே ஃபேஸ் பண்ணுறதுடா. ஆனால் வந்து ட்ரை டு அண்டர்ஸ்டாண்ட் 15 days தான் இருக்கு. ஓகே இந்த 15 days முடிச்சேன்னா யூ கேன் வாட்ச் யுவர் ஃபோன் டிவி எவ்ரி திங் ஃபார் அ லாங் டைம். ஆனால் ஐம் டெல்லிங் யூ May 3rd அப்புறம் இப்போ வந்து எக்ஸாம் இஃப் யூ குடின்ட் பெர்ஃபார்ம் வெல்னா பேரண்ட்ஸ் ரிலேட்டிவ்ஸ் கசின்ஸ் நைபர்ஸ் எல்லாருமே டார்ச்சர் பண்ண போகிறேன். ஸோ அந்த மொமெண்ட்டே யூ கேன் ஜஸ்ட் திங்க். ஸோ தென் யூ வில் டெஃபினெட்லி கம் பேக் டு த கிளாஸஸ், யூ வில் ஜஸ்ட் வாட்ச் தி லெக்சர்ஸ், யூ வில் ஸ்டடி, யூ வில் டூ த கொஸ்டின்ஸ். அதுதான். நாட் பேட். வெரி குட் வெரி குட். சம்சிதா அது கூட பரவாயில்லடா. மிஸ்டேக்ஸ் வந்து இந்த மொமெண்ட்டில் யூ டூ மேக்ஸிமம் நம்பர் ஆஃப் மிஸ்டேக்ஸ். ஓகே இப்போ வந்து இஃப் யூ ஆர் டூயிங் மிஸ்டேக்ஸ்னா லேட்டர் ஆன் அது வந்து எக்ஸாம் டைமில் யூ ஒன்ட் பி ரிப்பீட்டிங் தட். ஸோ அதனால ஐ வுட் லைக் டு சே இந்த 15 daysல முடிஞ்ச அளவுக்கு யூ கேன் டூ த மிஸ்டேக்ஸ். அதுக்கப்புறம் நோ வரிஸ்டா. எக்ஸாமுக்கு அந்த மிஸ்டேக் யூ ஆர் நாட் கோயிங் டு ரிப்பீட். ஓகேவா? Of course Priyanka, we will do, no worries. Okay, break முடிஞ்சதல்ல, let us continue. Wave optics start பண்ணலாமா? Are you guys ready? Ready-na give me fire டா. ஏன்னா உங்களோட எனர்ஜி லெவல் வந்து ரெடியூஸ் ஆயிருக்கு, ஏன் எனர்ஜி லெவல் கூட ரெடியூஸ் ஆயிருக்கு. ஸோ அது வந்து இவ்வளோ தமிழ் வந்து என்னால் முடியாதுடா. லெட் மீ ட்ரை பிகாஸ் மை ரிலேட்டிவ்ஸ் நீட் இன்விஜிலேஷன் போயிருக்காங்க. ஸோ நிறையா கேர்லெஸ் மிஸ்டேக் லைக் ஷீட் ஏதோ ஷேக் ஆனனால ஏதோ ஷீட் ஷேக் பண்ணனால OMRல என்னால் I mean I couldn't understand that. So let it be. We can just start with the wave optics chapter. Okay, so wave optics chapterல first வந்து you should know one thing. இப்போ வந்து இந்த சாப்டர் ray opticsல we have done that, we have understood. மறக்காம லைக் பண்ணிக்கோடா. ஓகே മലയാളത്തിൽ പറയണമെങ്കിൽ വാട്ട് ഇസ് നല്ലപോലെ പഠിച്ചാൽ സുഖിച്ച് May 3rd ശേഷം ഇരിക്കാം, ഇല്ലെങ്കിൽ കഷ്ടപ്പാടും ദുരിതമായിരിക്കും. ഓക്കെ ഫൈൻ ഡൺ ഷാഹിദ്. ഓക്കെ സോ നൗ understand wave optics la ray optics la we were just dealing light as a ray. Okay, ana coming to wave optics we are just handling light as a wave. Okay, illana to be specific, wavefront we will consider. So இப்போ வந்து first word in the wavefront வந்து you should know. Guys, like பண்ணிக்கோடா. So wavefront na என்னடா? It is actually the collection of all the points. Okay, all the points. No, Oliva, no, I don't know. Okay, collection of all points which is in the same phase. Which means, let us say, in the madri da nama wave irukke. Okay, another wave is here. Okay, so இப்போ வந்து பாக்கும்போது இந்த பாயிண்ட் எல்லாமே வந்து சேம் ஃபேஸ்ல தான் இருக்கு. So I can just collectively I can say that அது வந்து ஒரு wave front தான். So இப்போ வந்து இந்த பாயிண்ட கன்சிடர் பண்ணிட்டேனா this is also in the same phase தான். So definitely I can say that this is going to be another wave front. So wave front na very simple. It is nothing but the collection of, okay, it is nothing but the collection of what is it, the points which is in the same phase. இப்போ வந்து for example we are just throwing something on the pond. Okay, in the pond kulla if you are throwing something na definitely anga waves will be formed, right? So now you can see you will be seeing some circular shape things, right, that is moving away. So on the circle irukra ovvoru point me it will be in the same phase. அப்படி I can say that on the circular இல்லனா அந்த ஷேப்ல இருக்குறது வந்து wave front தான். Okay va? So இப்போ வந்து ரெகுலரா பாக்கும்போது we will be having 3 types of wave fronts இருக்கும். First one வந்து spherical wave front தான். Second one வந்து cylindrical wave front தான். Third one வந்து plane wave front தான். Okay va? So what is this? What is a spherical wave front? Let us say இப்போ வந்து ஒரு point source தான். Okay, point source na அதுக்கு வந்து அந்த point source ல இருந்து definitely there will be a lots of waves coming. Correct? இந்த point source ல இருந்து 3 dimensional there will be a lots of waves coming. So in the waves ல we will be taking the collection of all the points which is coming under the same phase and then we will be called that is a wave front. So அந்த மாதிரி இப்போ வந்து இந்த point source ல இருந்து அவ்ளோ number of wave fronts இருக்கும். Okay, so next வந்து இப்போ வந்து if you are just seeing a linear source, for example the slit. Okay, yes, very good Arun, very good. Okay, இப்போ வந்து what I am saying, so you are just going for a slit na அது வந்து ஒரு linear source தான். So in the linear source will be actually having the cylindrical shape and the wave front oda shape வந்து it will be actually coming as the cylindrical. Okay, cylindrical shape ஆ இருக்கும். புரிஞ்சுதாடா everybody? Are you guys getting what I am saying? Yes or no? So cylindrical shape, linear source na என்னடா wave front oda shape என்ன? You can just tell me. Those who are there, please. எல்லாருமே தூங்கி இருக்காடா? Hey, where are you guys? So இப்போ வந்து point source na wave front oda shape என்னடா? Point source na wave front oda shape என்ன? Spherical da. Linear source na அதோட shape வர போறது cylindrical da. Okay va? Next வந்து let us say in the source, whether it is point source or linear source, whatever it may be, அது வந்து அங்க infinity ல தான் இருக்கு. Okay, infinity ல source வந்து infinity ல தான் இருக்கேனா definitely what will happen? We will say இதெல்லாமே வந்து plane wave fronts ஆ இருக்கும். மறக்காம லைக் பண்ணிக்கோ. Okay va? So இதெல்லாமே வந்து plane wave fronts ஆ இருக்கும். இப்போ வந்து source infinity ல இருந்துச்சுனா it will be coming as what? Yes, Damodara, very good. So it will be coming as the plane wavefront. So idhula vanda we will be adding the few datas from the waves chapter. So ipo vanda we know that when the distance increases, okay, in the source la irundha in the distance increase aachuna in the amplitude illiyada in the wave oda amplitude vanda reduce agum. Common sense, correct? So for a spherical source na in the amplitude will be proportional to 1 by d na the distance of separation da. Okay, so we know that in the intensity and this amplitude is having a relation. What is the equation connecting intensity or and the relation between intensity and amplitude? Intensity and amplitude will have a relation. What was that? I is proportional to a square. Appadina in the a is actually proportional to 1 by r, which means the radius of the spheres. Appadina intensity will be coming as I proportional to 1 by r square. Purinjidada? So this relation you should know. For a point source, the wavefront oda shape வந்து spherical wavefront ஆ இருக்கும். Note பண்ணிக்கோ, spherical wavefront ஆ இருக்கும். And அதோட amplitude will be connected as proportional to 1 by r. அப்படினா intensity according to this equation. So amplitude வந்து 1 by root r இருக்கும் ஏனா அந்த area okay அந்த area வர போறது it is coming as 2 pi rl. So இப்போ வந்து you will be getting the amplitude will be proportional to 1 by root r. அப்படினா intensity will be coming as intensity is proportional to இதோட square value which means 1 by r it will come. புரிஞ்சுதாடா? So simple சொன்னா whenever we are talking about cylindrical wavefront, it is actually produced by the linear source and also amplitude will be proportional to 1 by root r and intensity will be proportional to 1 by r. Third one that we have mentioned plane wavefront. Ana in the plane wavefront is not actually depending upon the amplitude. ஏனா அது வந்து infinity ல இருந்து வரல. So அதனால amplitude intensity எல்லாமே வந்து it is not going to change. Understood everybody? Understood? Now give me a heart quickly da. Quickly give me a heart everybody. Everybody. Yes, done. So marakama like panikoda. So now we have the Huygens wave theory principle. So idhula vandu innum simple ah irukke. Okay. So we know that in the wavefronts na enna we know it. So இப்போ வந்து let me just go for a wavefront. So இதுதான் வந்து நம்ம source. Okay. So in the source இருந்து I found in spherical shape I'm getting some wavefronts. Now what will happen? In the wavefront ல இருக்கிற ஒவ்வொரு பாயிண்ட்டுமே okay ஒவ்வொரு பாயிண்ட்டுமே act as a secondary source which means what is happening in the ஒவ்வொரு பாயிண்ட்டுமே actually producing the secondary wavelets correctா? So இதில் இருக்கிறதுல same phase ல வர போறது again it will form as a wavefront which means this will be creating a secondary wavefront. புரிஞ்சுதாடா? This will be producing a secondary which means in the primary wavefront ல இருக்கிற ஒவ்வொரு பாயிண்ட்டுமே ஒவ்வொரு பாயிண்ட்டுமே act as a secondary source and it will be producing more number of wavelets and we will be getting and whenever we are going for the tangent of it whenever we are going for இந்த மாதிரி ஒவ்வொரு பாயிண்ட்லமே இருக்கும்ல ஒவ்வொரு பாயிண்ட்லமே இருக்கும். So இதோட tangent if you are going na if you are drawing the tangent na what will happen tell me. Yes, very good. The tangent will give the new position of the wavefront. So இப்போ வந்து after t seconds what is the position of the wavefront ங்கறத you can just find. ஓகேவா? ஸோ ஹைஜன்ஸ் வேவ் தியரியில் மேஜராக சொல்ல போகிறது என்னன்னா இந்த ஒவ்வொரு பாயிண்ட் இந்த வேவ் ஃப்ரண்ட்டில் இருக்கிற ஒவ்வொரு பாயிண்ட்டுமே ஆக்சுவலி ஆக்ட் ஆஸ் அ செகண்டரி வேவ் ஃப்ரண்ட் and the tangent. So இதுதான் வந்து நம்ம secondary wavelets. இதோட tangent whenever we are doing or whenever drawing the tangent for each of these points. Yes, here it is. இதுதான் வந்து new wave. Okay, so the tangent to the secondary wavelets will produce the new wavefront and இதோட speed எல்லாமே வந்து same ஆ இருக்கும். அதுதான் வந்து another important point. Okay, all these points will be continuing with the same speed. So now we can just here at t is equal to 0 position we know. After some time what is the position? அதுதான் வந்து whatever we have done. So on the secondary wavelets la same phase la வர points எல்லாமே note பண்ணி we got it the secondary wavelets. அதோட tangent draw பண்ணும்போது you will be getting the new wavefront and இதுக்கு எல்லாமே வந்து same speed ஆ இருக்கும். ஓகேவா? It will be having the same speed. Now another important thing which you should study is, let us say whatever we have discussed in the ray optics, just now only we have studied ray optics. No, so அங்க discuss பண்ண whatever be the cases, for example இது வந்து reflection. Okay, so light as a wave also. Okay, backward propagation is not possible, which is actually Huygens is saying it is not possible. Okay, and the backward direction la, because if we are just saying this in the tangent vandu we can just add it here also, right? Ana vandu we won't be considering that. Okay, adukku vandu proper explanation edum kadayadu. He didn't even give the proper explanation. He will say that the wave will move only in the forward direction. Okay, wow. So now just observe here. Whenever we are talking about the wavefront, okay, so in the ray optics we said that when the ray comes, it will make an incident angle I and it will reflect. அந்த மாதிரி இங்க கூட the wavefront will come. Here the plane wavefront is there. That will come and it will make an angle theta with the normal. After this it will reflect. Okay va? After this it will reflect. And the angle of incidence and angle of reflection will be same. Exactly like ray optics, here also we can see. Another thing is like, the refraction. Okay, what was refraction? Sin I divided by sin R, which is equal to mu2 by mu1. That is also applicable with the wavefronts. Okay, wow. So this is basically saying, in the first chapter we have considered light as a ray. Ana vande in the chapter varumbodhu light we are considering it as a wave. So anga whatever we have proved, we should prove here as well. So adudha vande nama try pannittu irukke. So inga paakumbodhu when the wavefront is falling on the surface, it will reflect and the angle of incidence and angle of reflection vande same arukum. And the incident wavefront, the reflected wavefront and the normal will be in the same plane. And same we can use for the laws of refraction as well. The incident wavefront, refracted wavefront, normal will be along the same plane. And definitely we can say that in the case sin I by sin R. What is sin I? The sin of the incident angle divided by sin of the refracted angle will be again the ratio of the different mediums. Okay, wow. So next one vande inda madri whatever we have discussed about the converging lens, we have discussed about the diverging lens. Adula enna agapore, in the ray will come, if the ray is parallel adu vande it will converge to the focus. அந்த மாதிரி இங்க கூட you can say, okay, இப்போ வந்து இந்த wavefront is coming parallel to it now, it will be passes through the, or let's say it will converge to the in the wavefront கூட, okay, in the wavefront கூட it will converge to the focus. Okay, understood? So edudha vande you can see some diagrams here, the curved mirrors irukke. So in the wavefront is actually coming, ana this will be converging at the focus. Inga paakumbodhu diverging, exactly similar to the ray optics. Anga vande ray na, inga paakumbodhu wavefront da. Okay va? Everybody got it? So whatever you are doing as a ray there, just replace with a wavefront. This part is over. Okay, so next one in the madri I have added few more diagram. Idu vande representing refraction da. Okay, so wavefront is coming. After that, depending upon the refractive index, it will move towards or away from the normal. So next one, idu vande nama what is a prism irukke. So idula vande we have seen, okay, we have seen the refraction happening at the two surfaces and the emergent ray will come. Exactly the similar way, the wavefront, incident wave ray will come and there will be a refraction happening at one surface, then another surface la another second refraction will happen, then it will come out. Okay, so idu da vande emergent wavefront. Exactly ditto, nothing else. So idu vande lens case la. Okay, so next one we just wanted to discuss about interference. Interference and the name illa irukada. What is interference? Tell me, what is interference? What is interference? Interference na, two waves will superimpose. Maybe it will be giving you the maximum intensity, maybe it will be giving you the minimum intensity. Okay, if it is giving the maximum intensity na, we will say constructive interference. If you are getting minimum intensity na, we will say destructive interference. Are you guys getting it? Yes or no? Tell me da, everybody tell me, are you guys getting it? Yes or no? Yes or no? Quickly tell me. And marakama like panniko. You guys are not liking the session. Okay, yes, perfect. Superimpose each other. Yes. So in the constructive destructive interference எல்லாமே கிடைக்கிறதுக்கு ஒரு condition இருக்கு. இந்த source வந்து coherent ஆ இருக்கணும். So what is the meaning of coherent source? Okay, coherent source னா என்ன? What is going to be the coherent source? Tell me, what is going to be coherent source? It is nothing but when the two source, okay, the two light which is having, we have the two sources. In the two source la irundhu varudha same phase la irukanum, same frequency ah irukanum, same length, wavelength ah irukanum, same amplitude ah irukanum. Phase vantha either it should be same illana constant phase difference, at least constant phase difference agudhu irukanum. Okay va? So in the interference paakanumna, definitely the source must be coherent ah irukanum. Coherent na, what is the meaning coherent source? It should be have the same wavelength, same amplitude, same phase difference or same phase, இப்போ வந்து இந்த condition satisfied na we will say coherent, illana we will say incoherent. Okay va? So if you need to get the interference na, the source must be coherent. Ana there is a problem. Okay, இப்போ வந்து if you are using two different source, okay, if you are choosing two different source na, what will happen? What will happen if you are choosing two different source na? Two different source, carefully பார்த்துக்கோ, two different source na அதுக்கு வந்து coherent ஆக முடியாது. புரிஞ்சுக்கோ, நோட் பண்ணிக்கோ. coherent source வேணும்னா single sourceல இருந்து மட்டும் தான் we can just make it. Okay, so அதனால தான் Young's double slit experiment இல்ல, அதுல வந்து we are using two slits. So actually வந்து இந்த two slitsல வரப்போற light வந்து same sourceல இருந்து தான் வர. Got it? Everybody understood? So coherent source na adu vanda same independent ah irukra two source la irundha coherent source na we cannot mention. Same source indha madri slits ellame use panni you can just make the coherent sources. Everybody understood? Yes, yes, give me a heart if you understood. Give me a heart if you understood. Quickly guys, I just wanted to see you people are sleeping or what. Everybody quickly give me a heart. Very good, very good. So இப்போ வந்து few equations we have to focus. So இப்போ வந்து two waves இருக்கு. அதுல வந்து first wave ஓட amplitude வந்து A1 தான், second one ஓட amplitude வந்து A2 தான். So in the equation actually we are studying in the waves chapter. So A1, A2 we will be placed like this as vectors. Actually வந்து இந்த amplitude vector இல்ல, but to find the net amplitude we will be consider it as a vector. Okay va? So in the two amplitudes irukke, adoda phase difference da 5. Okay, two waves irukke, adoda phase difference if it is 5 na, definitely I can say that ipo vandu in the two amplitudes I will be keep it at an angle. I mean and the angle vandu phase difference ah irukum. Then I can find the net amplitude using the vector addition formula. What is that? Root of a square plus b square plus 2ab cos theta. Correct? இங்க வரும்போது A னா A1 amplitude of the first one, B னா amplitude of the second one A2, and theta na it is nothing but the phase difference between these two waves. Are you guys getting it? Are you guys getting it? So A net, the net amplitude will be root of A1 square plus A2 square plus 2A1 A2 cos phi. What is phi da? Tell me what is phi. Quickly tell me what is phi. Everybody quickly tell me what is phi. What is phi? It is nothing but the phase difference between the two waves. Now the thing is like we have already studied the intensity is proportional to a square. Correct? Intensity is proportional to a square. Appadina, here I have the confusion. Okay, here I have the confusion. Same amplitude equation I wanted to replace with intensity. Na? Okay, same equation I wanted to replace with intensity. Appadina, A1 square will be coming as I1. Am I right or wrong? Correct? Because I is proportional to a square. I wanted to just change the representation. Instead of a1 square, I will write it as I1. Okay. Instead of a2 square, I will write it as intensity of the second wave I2. Okay. And a1, a2, 2a1, a2, I will write it as 2 root of I1, I2. Cos phi will be same as cos phi. So I will be getting intensity is proportional to a square. Now you can just replace with this a1 square enge irukke, anga you can just mention it as I1. A2 square irukke na, anga you can just mention it as I2. Okay, so now you will be getting the intensity equation as the net intensity will be I1 plus I2 plus 2 into root of I1 I2 into cos phi. Okay vada? Understood everybody? Got it? Explain in little Tamila. Of course da. இப்போ வந்து intensity இருக்கு. Okay, two waves இருக்கு. So அதோட individual intensity வந்து A1 தான். And second one ஓட individual intensity வந்து I2 தான். அப்படினா அந்த net intensity வரணும்னா that will be I1 square plus I1 plus I2 plus root of I1 I2 cos phi. Got it? Okay. So now the thing is like you should know another equation connecting the phase difference and the path difference. Okay, phase difference and path difference. So usually வந்து இந்த phase difference na what is, I mean இப்போ வந்து two waves இப்படி தான் two waves இருக்கு. Okay, so இப்படினா I will say the phase difference வந்து 180 degree. Okay, இதுல வந்து phase difference என்னன்னா I will say that this will be nothing but 180 degree. புரிஞ்சுதாடா? This will be coming as 180 degree. Now the thing is like we should know the path difference. Okay, path difference na let us say two waves irukke. Okay, so let us say two waves irukke. So ipo vande it is actually okay, so இந்த மாதிரி தான் two waves. Okay, இதுல வந்து wavelength na 1 2 3 da wavelength வர போற. So next one is something like this 1 2 3 4. Okay, so in the point it is actually superimposing. Okay, in the point actually it is superimposing. அப்படினா in the case delta x, the path difference na I will always mention in terms of lambda. So this will be coming as, this lambda will be coming as total path length of this first one minus second one. So I'll be getting lambda as the path difference. So if you need to get the path difference, you should write in terms of lambda. And now a very beautiful equation is there connecting in the path difference and phase difference. Connect panni there is an equation. Adu vanda nothing but the phase difference will be 2 pi by lambda into delta x. Okay, what is that? Delta phi will be 2 pi by lambda into delta x. In the equation you should know. Everybody got it? Everybody got it? Give me a heart if you understood. Everybody give me a heart if you understood. And marakama like paniko everybody. Marakama like paniko. And I wanted to see you guys understood this three equations. Yena in the three equations vanda avlo important. Okay, I can't see the rest of the people. Where are you guys? Okay, done. Yes, perfect. So ipo vanda we got this interference. Next one vanda I wanted to learn the condition for constructive interference and the destructive interference. Constructive interference na maximum intensity kadikkanum. Okay, constructive interference na enna maximum intensity and destructive interference na enna minimum intensity ah irukum. Okay va? So idukku vanda condition irukenda. So ipo vanda in the path difference in the delta x illiyada, in the delta x vanda n lambda. Okay, n vanda 1 2 3 and madiri irukum. Okay va? So ipo vanda in the path difference n lambda na definitely what will happen, I will get the constructive interference. What I said constructive interference, what I said as the constructive interference. Tell me what was constructive interference? Yes, we need to get, idu vanda superimpose agapora and you will be getting the maximum intensity. Okay va? So on the constructive interference ku condition varaporadhu n lambda da. Okay, n lambda da condition varapora. Appadina phase difference oda expression we know. What was phase difference? Delta phi which is equal to 2 pi by lambda into delta x da. Correct? Ipo vanda in the delta x ku I am going for the substitution. What I will be getting? 2 pi by lambda into n lambda. Yena constructive interference ku path difference oda condition vanda n lambda da. So lambda gone. I will be getting n into 2 pi or else 2n pi da in the phase difference arkanam. So for a constructive interference, what I said da, for a constructive interference the path difference should be n lambda. Phase difference should be 2n pi. Got it everybody? Yes or no? Please let me know in the chat box. Everybody, if you understood na, give me a fire da. Everybody give me a fire if you understood. Yes, perfect. So now we can just discuss about the amplitudes. Okay, in the first wave ku vanda amplitude irukkiradhu a1 da, second one ku amplitude irukkiradhu a2 da. Okay va? First one wave oda amplitude vanda a1 da, second one oda vanda it is nothing but a2 da. Okay, so now tell me if it is a constructive interference, okay, if it is a constructive interference, what is going to be the amplitude? And the net amplitude we have mentioned, no, adula vanda substitute பண்ணும்போது what will happen? What will happen? You will be getting the maximum amplitude, okay, you will be getting the maximum amplitude, which is nothing but A1 plus A2. Okay, amplitude will be maximum, which will be A1 plus A2. Purinchidada everybody? Everybody got it? Yes or no? Yes or no? Maximum you will be getting. Very good, Damodara. It will be coming as A1 plus A2. Next one, in the equation you can apply for the intensity as well. Okay, intensity la you can see that cos phi da. Cos phi na cos of 2n pi da. Okay va? So that will be coming as 1 only. So you will be getting the intensity, the maximum intensity will be coming as I1 plus I2 plus 2 into root of I1 I2. Got it? So I1 plus I2 plus 2 root I1 I2 the maximum intensity vare. And what it is representing? What it is representing? It is nothing but A plus B the whole square, right? Correct? This is nothing but the A plus B the whole square, which means A square plus B square plus 2AB. What is A and B? What is A and B? It is nothing but root of I1 and I2. Correct? A1 na, sorry, idhula vandu A na, it is nothing but root I1, B na, it is nothing but root of I2. Okay, va? So now you can just rewrite this equation. The maximum intensity will be coming as A plus B the whole square, root of I1 plus root of I2 the whole square. Are you guys getting it? If you're getting it now, give me a like, give me a heart. Okay, so adukapram we can go for the destructive interference. Is it okay? Everybody? So what I said, so we were discussing about the constructive interference that we were discussing. Adukku vanda path length must be n lambda, phase difference must be 2n pi, and also amplitude will be maximum, and that is going to be A1 plus A2, and the intensity will be maximum, and which will be coming as root of I1 plus root of I2 the whole square, because in the equation is actually coming as like A plus B whole square. So I'm just rewriting it. All good, all good, all good, all good. Yes, perfect, perfect. Now we are going for the destructive interference. So adula vandu paakumbodhu in the path length, okay, path length should be 2n minus 1 divided by 2 into lambda da. Okay, 2n minus 1 divided by 2 lambda da path difference varapore, and corresponding phase difference will be coming as 2n minus 1 into pi da. Okay, in the conditions vandu you should know, then only we can go for the Young's double slit experiment. Okay va? So ipa vanda destructive interference da irukke. Destructive interference la in the phi value, which means in the phase difference must be 2n minus 1 pi. Okay va? And next one the path difference. Path difference now we can say that it is nothing but 2n minus 1 divided by 2 into lambda. Instead of n lambda, here it will be 2n minus 1 divided by lambda da varapor. Next one inga irukkaradhula amplitude minimum irukum. If the first one is having an amplitude A1, second one is having an amplitude A2 na, idhula irukkara minimum amplitude da varapore, and that minimum amplitude will be coming as A1 minus A2. And we said in the case of intensity we have mentioned in the previous case it was root of I1 plus root of I2 the whole square da. So now can you just tell me what is going to be the minimum intensity here? It will be root of I1 minus root of I2 the whole square. So இதுதா the minimum intensity oda expression வரப்போற. இப்போ இந்த amplitude same na, okay, A1 and A2 same na, and the net amplitude it is going to be 0. A1 minus A2 will become 0, and the minimum intensity will also come as 0. Got it, everybody? Everybody understood? Yes or no? Yes or no? So guys, just give me 1 minute. I'll just come. Okay, I just wanted to take something. Just a minute. Okay, 1 minute I will come. Let us continue. Next chapter வந்து modern physics we will continue. Wave optics அப்புறம் modern physics. ஏன்னா அன்னைக்கு வந்து we have done the class ஆன questions எதுவும் பண்ண முடியலல்ல. So we will just go for briefing of all the chapters, including semiconductors we will complete. That is what I think we can finish today. Okay, wow? Okay. So now again, okay, so minimum the intensity varapora, it will be root of I1 minus root of I2 the whole square it will come. So destructive interference is also done. Now Young's double slit experiment. So in the Young's double slit experiment, what is the purpose of Young's double slit experiment? What do you think? எதுக்காக இந்த experiment எல்லாம் பண்றேன்? So basically the thing is like people were saying in the light வந்து particle da. So அந்த seasonல da Huygens is actually introducing light வந்து ஒரு wave property இல்லனா அதுக்கு வந்து wave அது வந்து actually வந்து ஒரு wave ஆ இருக்கு. It is actually behaving like a wave. அந்த மாதிரி he said. So usually we know that in the interference எல்லாமே வந்து wave க்கு இருக்கிற property தான். Okay, wave க்கு இருக்கிற property தான். So அந்த interference actually in the light produce பண்ணும்னா we can say that actually in the light is also as a wave. Correct? So அது prove பண்றதுக்கு தான் he actually introduced this experiment. Okay va? So now இப்போ வந்து we will be having a single source from here. Okay, single source from here. In the single source the light will come like this and it will pass us through the two slits S1 and S2 is there. So the light will pass us through S1 and S2. Understood till this? Understood till this? So now we know that. So inga varaporadha it is something like this. In the madri da in the wavefronts varum. So this wavefronts will definitely interfere. Okay, this wavefront will definitely interfere. And it will be producing in the screen pathena, it will be producing alternative bright and dark fringes or bands. Okay, wow. The alternative dark and bright bands it will produce. Appadina, the thing is like you just understand. Okay, I'll tell you just understand. So if the alternative bright and dark na, what does it is representing? Actually வந்து alternative it is going for constructive and destructive interference. Constructive interference na என்னடா? Yes, we will be getting the maximum intensity, which means அது வந்து அந்த band வந்து bright ஆ இருக்கும். And when it comes to the destructive interference na, in the amplitude and in the intensity வந்து it is going to be very very less. அதுதான் வந்து represent பண்றது in the dark band or let's say dark fringe. Are you guys getting it? Yes or no? Are you guys getting it? Yes or no? Yes or no? Quickly tell me. So what is actually happening? So he did the experiment. And the experiment kapram screen we are getting the alternative dark and bright branches or sorry bright bands or let's say fringes and the bands that we are calling fringes. And in the bright band na on the point in the wavefronts allame actually it is coming as constructive interference. When it comes to the dark band na anga irukkiradhu destructive interference intensity minimum ah irukum. So alternative in the madri dark and bright fringes vanda anga produce achu. Now the thing is like I just wanted to know few things. Okay va? எப்போ வந்து இந்த constructive interference இருக்கும், எப்போ வந்து இந்த destructive interference இருக்கும். அதுக்கு வந்து condition we already studied. Path difference க்கு என்ன value வரணும் and what is in the phase difference என்ன வரணும், we already know it. And அது மட்டும் அல்ல, we should study one more equation here. One more equation na எப்பவுமே இந்த சென்ட்ரல் இருக்கிற சென்ட்ரல் பேண்ட் வந்து பிரைட்டா இருக்கும். ஓகே, சென்ட்ரல் பேண்ட் வந்து பிரைட்டா இருக்கும். ஏன்னா பாத் டிஃபரன்ஸ் வந்து அங்க வர போறது 0 தான். ஓகேவா? சோ அந்த சென்ட்ரல் மேக்ஸிமா ஆர் லெட்ஸ் சே அந்த சென்ட்ரல் பேண்ட் பிரைட் பேண்ட் இருக்கு, அந்த பேண்ட்ல இருந்து if you need to find the distance to any of the band, which means I'm saying nth band la irukra distance. Okay va? In the yn da we need to find what is yn and the center la irundha what is the distance to the nth band. Idu da vandu yn representing. So and the yn oda expression vandu you should study. Adu vandu nothing but the path difference into d by d. Capital D na என்னடா? Capital D na என்ன? It is nothing but in the screen and source இருக்கேல்ல, இல்ல அந்த screen and slit இருக்கேல்ல, அதுக்கு இருக்கிற separation தான் capital D. Now small d, what is small d? In the slits இருக்கிற separation இல்லையாடா, அதுதான் வந்து small d. Understood everybody? Please let me know in the chat box. Understood everybody? What I said? So whenever we are talking about, yes, very good Arun, very good. Whenever we are talking about the capital D, it is nothing but in the slit and screen order separation, small d na slit irukra separation da small d. And if you need to find the distance from the sender to any of the band, or let's say to the nth band, okay va, adu vandu bright band ah irkalam illana what to say in the dark band ah irkalam. So to how to find it, that is what the equation over here, delta x into d by d. So ipo vandu if you are looking for a bright band, okay, if you are looking for a bright band na, in the delta x enna agumda, in the delta x enna agum, tell me everybody, what is going to be delta x in the if you need to get a constructive interference na, Aisha, you can give me the answers quickly, then you will feel more energetic. Now tell me quickly. Yes, very good Arun, it will be n lambda. Idu vandu dark band na, what is going to be delta x? It will be, in the path difference will be 2n minus 1 by 2 into lambda da varapore. So ipo vandu in the what is it, the things which we ever discussed was over. Okay, we were just try to study constructive and destructive interference for the Young's double slit experiment. Adula vandu you should know. Okay, ipo vandu second dark band enga irukum. Okay, my question is second dark band enga irukum. So what you will do, what a dark band illa, so 2 into n ku instead I will be put n, I mean 2. In the case I wanted to see the second dark band. So 2 into 2 minus 1 divided by 2 into lambda, the distance between the screen and the slit divided by the slit separation. Got it everybody? Give me a quick heart if you understood. Everybody give me a quick heart. Now we understood this. This is what for the constructive interference, we already discussed about it. We will just put delta x value. Okay, so we will be getting n lambda d divided by d. If you need to find the third bright band na, inga vandu you can just put 3. Okay, if you find it for the seventh band na, you can just put it as 7 over here. Okay, purinjadada? Now idu iruken Rohit. Okay, so now destructive interference ku vandu in the delta x value will be coming as 2n minus 1 divided by 2 into lambda into the distance between screen and the slit divided by the slit order separation. Okay va? So you will be getting this equation. Done. So next one, the fringe width. Fringe width na, let us, I am just considering 2 bright bands. Okay, 2 bright bands. And the 2 bright bands, I mean 2 bright bands randomly I can take the neighboring. Okay, இப்போ வந்து ஒரு bright band இருக்கு, ஒரு dark band இருக்கு, ஒரு bright band இருக்கு. And the 2 consecutive bright band குள்ள இருக்கிற separation தான் fringe width. Okay, இல்லனா 2 consecutive dark band குள்ள இருக்கிற distance தான் இந்த fringe width. And the fringe width க்கு வந்து there is an equation lambda d divided by small d. Okay, lambda is nothing but the wavelength, capital D na distance between slit and the screen, small d na என்னடா, it is nothing but the slit ல இருக்கிற, okay, and the separation தான் small d. Okay, understood everybody? Yes or no? Yes or no? Tell me, quickly tell me da. So fringe width oda equation vandu you should study beta, which is equal to lambda d by d. It is going to be same for all the value, I mean all the bands. Okay, ஏனா இது வந்து Young's double slit experiment da, fringe width வந்து எப்பவுமே it is going to be same. Okay, got it. Yes, so marakama like pannikoda everybody, marakama like panniko. So now another thing, ipa vandu till this point we were discussing about in the Young's double slit experiment oda complete setup. Okay, the complete setup was actually we were doing in air illana vacuum. Now I am going to change the medium. What I'm going to do da? I'm going to change the medium. And the medium change agradanaala you can just like this video. Also give me a heart quickly so I'll get more energy. Okay ba? So in the YDSC experiment whenever you are placing this in a different medium which is having a refractive index mu, then definitely what will happen? The wavelength in the medium will change. Okay? The only change will be happening. Okay? The only change which is happening, konjam decrease pannanuma brightness for everybody. Tell me. Brightness problema, inga irukra brightness problema, not in the chapter. In the brightness is adhigama illa problem irukka. Because what I felt like, if you're feeling sleepy, if you're looking at the screen, oh my god, and the sleep will go. Okay. Okay, so multiple answers were coming, so let it be. Okay, so now the thing is like the wavelength will change. The wavelength will change as the lambda divided by mu. Okay, va? Purinjida? So it will be reduces. Okay, and the wavelength vanda innoru mediathile it will reduces 1 by mu times. Okay, va? So now the thing is like wherever we are using lambda. Okay, wherever we are using lambda, ange what will happen and the lambda you will be replacing it with lambda by mu. So ipo vanda just now we were discussing about the fringe width beta, correct? So adoda expression enada, what we have mentioned, beta what expression enna? What is the expression for beta? It is nothing but lambda d by d. So now my question is, if it is in a medium, okay, if it is in another medium with a refractive index mu, what is going to be the beta value, or let's say in the fringe width value? Can you give me the answer in the chat box? Quickly tell me, give me the answer. What I said, initially I was doing in air, and on the fringe width I got it as lambda d by d. I'm just replacing this to a different medium of refractive index mu. What will happen? What will happen? Tell me quickly. Everybody. Yes, very good. Divided by mu it will come. Okay. So the new fringe width will be coming as lambda d divided by mu into small d it will come. Very good guys. So now another thing is like angular fringe width. Okay, angular fringe width definitely we will be taking, okay, we will be taking the in the fringe width, okay, and from this point we will go for the two lines. So this will be giving you the angular separation. So angular separation is nothing but the angular width is nothing but the separation between two consecutive maximas, or let's say minimas. This is what the angular fringe width. Adoda expression enna beta by d da. So equation will become lambda by d. Okay, so appadina when we are replacing this whole system in a medium in the angular fringe width kuda it will reduce by 1 by mu times. Understood guys? So when we are replacing, okay, careful paathuko, when we are replacing the entire YDSC, okay, in the Young's double slit experiment order complete setup, if you are replacing fringe width change agum, it will reduces by 1 by mu times, and also in the angular fringe width, idudha angular fringe width, adu kuda it will reduces by 1 by mu times. Yena idellame lambda irukke. Okay, so definitely it will change. Okay, so now we have another point, diffraction, adukapram polarization, then this chapter is over. Okay, wow. So now let us just focus on diffraction of light. What is diffraction of light? Very simple. So we know that whenever the light is falling on any obstacle, illana ipo or slit, okay, so when it is going through that, definitely there will be a bending will happen. Okay, so in the obstacle illana slit illa definitely in the bending bending will happen na, and the bending and the process da in the diffraction of light. Okay, bending of light da, okay, that is what the diffraction of light. So in the diffraction happen pannanomna adukku condition irukke. Okay va, adukku condition irukke. Diffraction, if the diffraction should happen na adukku condition irukke. Simple ana condition da. Do you know what is the condition? Do you know what is the condition? Please tell me what is going to be the continuation. Okay, avlo detail agadu Susmitha, we will definitely cover important இருக்கிற points வந்து we will cover. Okay, detail இருக்குது தேவையில்லடா. Okay, so diffraction of light illa condition என்னன்னா the light which is coming, no, அதோட wavelength and the obstacle ஓட size இல்லையா, இது வந்து comparable இருக்கணும். புரிஞ்சுதாடா? So what is the condition for diffraction? Note பண்ணிக்கோ, the size of the obstacle இல்லனா the dimension of the obstacle should be comparable with the wavelength of the light. Got it everybody? Everybody understood? Then give me a quick fire da. Quick fire everybody. Diffraction of light, we have reached diffraction of light. Now we need some energy. அதுக்காக கொஞ்சம் fire வேணும்டா. So just give me some fire. So let me see how many of you were active. Few, only very few is there. Yes, fine. Okay, so இங்க இருக்கிறவங்க வந்து அவ்ளோ பவர்ஃபுல்லா இருக்கு, so no worries. So diffractionக்கு வந்து we understood bending of light da, when it is passes through an obstacle or a, let's say a slit or something, definitely bending will happen. So அந்த bendingக்கு இருக்கிற condition என்னன்னா obstacle ஓட size வந்து, okay, obstacle ஓட size வந்து it should be comparable with the wavelength of the light used. So in the diffractionல பாக்கும்போது diffractionல there is some changes. Okay, இப்போ வந்து if you are looking for minima, okay, the thing is like in the diffraction பார்க்கும்போது the intensity la variation இருக்கும்டா. Okay, intensity la variation இருக்கும். In the, I mean, you can see after that in the screen ila ஒரு central maxima you can see. அதுக்கப்புறம் இந்த intensity reduces and it will come to minimum. Okay வா? So இப்போ வந்து பார்க்கும்போது if you need to get minima, okay, if you need to get minima or if you need to get maxima, master the blaster, fine. Okay, so now just understand so ipo vandu we have to find the minima. Okay, so in the previous case la constructive interference, which means in the maxima or let's say we need to get the maximum intensity, adukkaga we said the path difference must be n lambda, right? ஆனா இந்த diffractionல வரும்போது it will be completely ulta. This path difference must be n lambda for the minima. புரிஞ்சுதாடா? For getting the minima, the path difference should be n lambda. Are you guys getting it? Okay va? So for minima inga irukradhula path difference na, okay, path difference na I will just go for a perpendicular line. Idudha vandu path difference. And the path difference na a sin theta da. So in the angle vandu avlo small ah irukum. So definitely sin theta we can approximate to theta. Appadina a theta it will come. So a theta will be coming as n lambda. So now I can say that in the a value illana theta value vandu I can just find it using this expression. So what is the condition for minima? The path difference a sin theta, okay, a sin theta must be n lambda. Okay vada? Got it everybody? And now if you need to get, okay, if you need to get this y value na, adukku vandu you can apply, which means the position of minima if you need to get na, you can go for n lambda d divided by small d. Are you guys getting it? Yes or no? Y value if you need to get, y value na in the minima point, okay, so in the central maxima la irundha how far it is, okay, ipo nth minima da I wanted to find it. Appadina in the central la irundha and the point la evlo distance irukke, so adha vandu in the y value which will be coming as n lambda d divided by a. Equations mattum pododa, nothing else is required. Okay va? So next one the maxima. So maxima na in the path difference must be 2n plus lambda by 2 into lambda it will come. Okay va? So now the thing is like no secrets Asmita, no secrets, nothing. Okay, so now the thing is like maxima da. So maxima vukku vandu in the path difference must be 2n plus lambda. Anga vandu minima vukku we said 2n minus 1 lambda by 2. Ana inga paakumbodhu 2n plus 1 lambda by 2 it will come. Okay va? So sin theta will be sin theta, a sin theta the path difference. So for maxima the path difference a sin theta will be 2n plus 1 into lambda by 2 it will come. And if you need to get the position, definitely you can just replace the path difference. Adu vanda it is nothing but 2n plus 1 lambda by 2 into d by a. A ina slit oda width da. Okay, small a ina slit oda width da. Understood? Okay. When will be the class end na? Around 9 o'clock it will end. Will it be okay? Done? All good? Okay. So, to get the maxima and minima, this is what the condition. And now here also we have the angular separation or angular width for the central maxima. Adoda expression vanda it will be 2 times the lambda by a. Okay, 2 times the lambda by a. So here you can see in the diffraction pattern you can see that central maxima will be having the highest intensity. Then we are moving towards right or left, or let's say up or down. What will happen? Intensity will reduce and coming to minimum. And here also the same thing will happen. Okay, wow. So next one in the angular separation. Okay, so the angular width of the central maxima, if you need to find na, okay, if you need to find na, adoda expression it will be nothing but 2 lambda by a da. Okay, a ina again slit oda separation da. Got it everybody? Okay, done? Okay. So now the fringe width, okay, wow. So if you need to get the linear width of it, okay, if you need to get the linear width of it, adu vanda 2 lambda d by a it will come. Linear width, okay. Angular separation na 2 lambda by a. Linear separation, if you need to know this linear separation na, that will be coming as 2 into lambda d by a it will come. Okay, capital D is again the slit and the screen order difference da, and small a na and the slit order width da. Okay. So now let us go for polarization. Are you guys ready? Ready, Ada? And how was till now? It's getting exhausted, right? Are you guys drinking water? Because sometimes you people are reminding me, so that I'm doing it. I wanted to know, you are having something or lunch everyone had, right? And ipo vanda almost 5 o'clock arike. Edachu snacks irikada? So Amma vanda made something special for you today. Yes, sir. Oh my God. Yes, what happened? I'm asking for what is the next chapter? Next chapter will be modern physics. I already mentioned, no. No, nothing special. Durai, Damodara, you have something special. What was that? Same formula mudichirlam. Paravalla, perfect. And the spirit irukkonda. And a few students ku mattum da and the spirit irukke. I know morning la irundha many students were staying back. I can see the the difficulty. I can understand, and especially when it comes to physics, idu vanda avlo easy alla. Concept புரியணும். இப்போ வந்து கான்செப்ட் புரிஞ்சாலும் questions வந்து பண்ணவே முடியாது. So இதெல்லாமே இருக்கு தெரியும்டா, பரவாயில்ல. Oh my God, Sasmita. I'm also I don't have nothing to eat as snack. Snacks idu leya. Of course I had a dosa. But again I'm feeling hungry. Yena I mean continuous I'm talking, no. So adinala vandu koncham hungry ah irukke. But paravalla, it will go up to like 7-8. Paravalla. Let's see. So okay, so those who have snack, have it da. Okay, those who have not having snacks like me, Sasmita and all, we will just imagine like we are having something really special. Enna venu Sasmita? What do you want to eat right now? So those who don't have snack, na, you tell me what you want to eat. Of course, Davanida, I'm having, just now only I had water. Nothing can be done. So tell me, what is the snack? What kind of snack you wanted? So I can just think about different snacks, no? Adukapram we can just continue with polarization. chicken biryani as a snack kada. Adu vantu what to say main course da. Just go for some snacks. Tell me. Oh my god, chicken biryani and all, I don't want it right now. Hey, why you are triggering me da? Frankie, yes, it's a good option. Okay, others, no one wants nothing da. Oh my god. Everyone, I think. Thank you, Damodara. Thank you so much. Tea mattum poduma. Okay, Sasmita. Chicken biryani along with the tea. It will work. Aisha, bread toast. Okay, I don't want bread toast and all. I want Frankie. Kachori. I don't know what is kachori. Noodles, pasta, vada, bhaji. Hey, Ananya, don't do this to me. Vanida wants coffee only. Okay, very good. Tea. Sasmita is a tea fan. Oh my god. But I don't know. I'm not a tea or coffee fan. I can. I mean, if I'm feeling very much headache and very tired, then I will have something like tea or coffee. Otherwise, I'm not at all a coffee or tea person. But Ananya, this is wrong. Noodles, pasta, vada, bhaji, ellame vandu irritating me right now. Oh my god. Hot chocolate. Cappuccino. Okay. Juice is enough. Okay. Perfect. So, I think everyone had some kind of Kit Kat milkshake. Don't do this to me. Okay, so let us just continue. This is idu vera level poite irukke. So now let us just continue with the polarization. So what is polarization? Polarization na we know that ipo in the normal sunlight ellame hey podum. I am feeling hungry. Okay, initially konjam fun start pannirken ana now I'm getting serious. So ipo I think I will finish this lecture and I will go and I'll have something. Okay, yes, not interested to eat. Hey, first neenga thana sonna you want chicken biryani. What is this, Asmita? Don't change your mind right now. Inneki I will also have chicken biryani. I don't have nothing in my mind, but now something came on my mind. Okay da, so come back everybody, come back everybody. இப்போ ஏதாச்சும் questions கேட்டேன்னா நீங்க இந்த மாதிரி answers தர, I mean you won't give right. ஆனா snacks எல்லாமே all set. ஆமா சஸ்மிதா, எனக்கு அப்படி இல்ல, I wanted more. Aisha, don't do. Okay, so polarization da, ready ada? Let us just start. Give me a fire if you're ready for the polarization. எனக்கு இதுல இருந்து distract பண்ணனும். I mean everybody is talking about something else. I don't want to listen that. Now tell me if you're ready na, give me a fire. Manju, it will be done on 23rd or 21st. I'm not sure about the date. Okay, definitely we will be getting the dates in this week itself. Okay, I will tell you. Yes. Perfect. So appadina let us continue da. Polarization na ipo நம்ம normal sunlight எல்லாத்துலயுமே vibrations it is actually in different directions. Okay, different directions la irukum. So adu I mean it is actually vibrating in multiple direction. Now we will be just make into a single direction, and the vibration will be in the single direction. அதுதான் actually in the polarization. Okay, polarization la இப்படி da multi direction la இருக்கும், multi direction la da இந்த light இருக்கும், and we will be using a polaroid, or let's say the method we call polarization. அதுக்கப்புறம் இந்த light ஓட intensity will reduce and it will only vibrate in a single direction. Okay, இந்த multi direction la இருந்து single direction la convert ஆகும். So அதுதான் okay, அதுதான் actually this polarization method. Okay, so now I can say that இதுதான் plane of vibration. Okay, இதுதான் plane of vibration. Now what will happen in the vibration la we will be using a polaroid na it is something which is converting, okay, in the multi vibration which will allow only in one direction. Okay, in the multiple vibrations irukela adile irundha one direction mattum da in the polaroid will allow. Okay va, so that is what the polarization method. And now you know the plane of polarization and everything. plane of polarization, plane of vibration. Okay, so idha vandu actually it is happening. So now you can just see that this is actually in multiple direction, and when it is passes through the polarizer, it will be allowing only in one direction, only in one direction la mattunda irukke. Okay, so now polarized light na, as I mentioned, in the vibrations, multi-directional vibration irukada, only one direction la da irukum. Okay, of course only in one direction, in a plane perpendicular to the direction of propagation. Got it everybody? Everybody understood? Yes or no? Yes or no? So idu vanda uses da, you can just go through it. Idu vanda avlo important alla. Law of Malus, it is actually not in the syllabus. Okay, syllabus illa correcta they didn't specify. But of course, Neet da, so adanala konjam extension we can expect. Adanala you guys can study just one equation. Okay, in the Malus law la irukra equation vandu you can study, the rest you can just ignore at this point. Okay va? So on the equation enna na, I is equal to I not cos square theta da. So theta na in the angle da. So in idhula vandu paakumbodhu you will be having a polaroid as well as you will be having an analyzer. So polaroid na VZ in the multi direction la irukkiradhu vandu, multi direction la irukkira light e vandu we will be make it into single direction la vibration a irukum. Okay va? So now the thing is like adukapram it will passes through another thing which is called analyzer. In the analyzer kuda actually sollumbodhu in the analyzer kuda it is a polaroid. Okay, analyzer analyze panna poren. Okay va? In the what is it, in the polaroid la irundhu illana polarizing first polaroid la irundhu vara and the light they will just analyze whether it is in a single direction or what. Okay, so now the thing is like there is an angle theta over here. Okay, there is an angle theta over here, which means it is due to the orientation of the polaroid as well as this analyzer. Okay, so in the polaroid and analyzer will be making an angle, and the orientation is making an angle theta. So definitely now the intensity will be coming as I naught cos square theta. So this is the equation. At this point you can just go for this equation only, don't study much about it. Got it? Everybody understood? Of course. Okay, so this is the Malus law expression, and I'm not doing any questions and all, you can just study this. Okay, next one the Brewster's law da. Okay, so it is a very simple concept da. Let us say ஒரு light இருக்கு. Okay, ஒரு light இருக்கு. It is actually reflected from a transparent medium. Okay, it is actually reflected. So the thing is like we know that if a light is falling on a surface na, adula vandu konjam light vandu reflect arukum, konjam light vandu it will refract as well. Okay va? So light vandu it is falling on the surface, definitely what will happen, adula vandu reflection irukum, refraction irukum. So adudha vandu you can see it here. Okay va? That is what you can see here. The light is actually falling on the surface, and some light will reflect, some light will refract. Now the thing is like at some particular angle, okay, at some particular incident angle, what will happen in the what is in the reflected ray la irukra what is adu vandu polarized arukum. Okay, and the reflected ray vandu polarized arukum, which means at a particular, okay, at a particular what is the incident angle, this reflected ray will be completely polarized. What I said, இப்போ வந்து ஒரு incident ray is falling on it, அதுக்கப்புறம் refraction will happen, reflection will happen at a particular incident angle. Actually சொல்லும்போது இந்த reflected ray will be completely polarized இருக்கும். Understood? Yes or no? Understood? Yes or no? Tell me everybody tell me, are you guys getting it? So on the particular what is on the angle, the Brewster's angle. Okay, so on the particular incident angle we are getting the perfect what is completely polarized reflected light. On the process illana on the angle vandu we will say that Brewster's angle. Okay va? And also on the special angle we have mentioned, no, in that angle this reflected ray and refracted ray will be making 90 degree each other. Okay, so this will be making 90 degree each other. Got it everybody? Everybody understood? So idhula vandu innum one more thing which you should study. So the thing which I have mentioned is done. So இப்போ வந்து unpolarized light வர and definitely refracted ray. So இதுல வந்து பாக்கும்போது இது வந்து 100% polarized இருக்கணும்னா okay 100% polarized இருக்கணும்னா what exactly happening? Definitely this angle must be 90 degree and this angle we will be call it as Brewster's angle and idhila you should study this equation mu is equal to tan IB. Okay, tan IB na tan of Brewster's angle will be equal to the refractive index of the medium. Polarization, Brewster's law, everything is done. So, this is what you need to study. Polarization in the multi-direction la vibrate பண்ற இந்த light single direction la convert பண்ற அந்த method தான் polarization. And அதிலிருந்து we know that we will be using Polaroids for it. Basically வந்து இந்த sunglass எல்லாமே வந்து we are using this Polaroids only to reduce the intensity. Because multiple direction la vibrate பண்ணலனா we can understand that intensity has reduced. So, அந்த intensity reduce பண்றதுக்கு தான் we are using this polarization or let's say the device or let's say the thing which is called Polaroid. And next one we have studied about Malus law. So the intensity coming after the analyzer will be equal to I0 into cos square theta. In the I0 value வந்து usually in the initial intensity oda half value இருக்கும். Next வந்து Brewster's law da. Brewster's law la in the unpolarized light will hit on the surface and few will be reflected, few will be refracted. If the angle between reflected ray and the refracted ray is 90 degree, then definitely what will happen? The reflected light will be completely polarized and you can just write the relation mu, the refractive index of the medium will be equal to tan into IB. IB na in the Brewster's angle da. Got it everybody? Everybody got it? Yes or no? Yes or no? Let us do some questions from this chapter. Ready Ada? Give me a fire if you're ready. Give me a fire if you're ready, please, quickly. Yes, perfect. So let us go for the first question. Okay. So, for a point source, okay, for a point, I think it is visible, right? For a point source, at 2 meter distance from the source intensity is I, okay? So, when the distance is 2 meter, the intensity is I. At what distance it will be having the intensity be 4I. So, we should only study, okay, we have already studied this equation. Intensity will be proportional to 1 by R square, okay? That is what Brewster's law. Yes. Okay. So now I is proportional to 1 by R square. So now the thing is like when I can say that I will be, when intensity is I, what is happening? The distance is actually 2 square. Okay, wow. Now the question is, if the intensity is become 4I, what will be the R value? This is the question. Okay, wow. So now you can just go for this one. I1 by I2 will be equal to 1 by R1 square divided by 1 by R2 square. So idhula vandu paakumbodhu I1 by I2 will be coming as R2 square divided by R1 square. So I1 na I da divided by I2 na 4I da. R2 square is what we need to find, divided by R1 square na 2 square, it will be coming as 4. Now can you give me the answer for this question? Can you give me the answer for this question? Everybody tell me the answer quickly. Very good, Sasmita. Others? Yes, Durai, very good. Yes, others. Give me the answer quickly, da. Yes, the answer will be coming as 1 meter. Now let us go for the second question. The wavefront incident at an interface between the media and are shown in the figure. the value of the angle refracted wavefront subtended with the horizontal. Okay, we need to find the refracted angle. Can you find it? Because it is just forget about this is a wavefront and all. Just focus on that, the refraction, the law vanthu you should know. Okay, idhula vanthu refractive indexes is given. For the first medium it is 1, for the second medium it is √2. Appadina you should substitute the value. So simple irukku, sin I by sin R which is equal to mu2 by mu1 da. So idhula vandu paakumbodhu sin I na sin 45 da varapore. Okay, so adu da vandu nama incident angle. Quickly you can give me the answer. mu2 by mu1 vandu it is nothing but √2 by 1 da. Sin I na sin 45, okay, divided by √2 will be giving you the sin R value. So idhila irundhu you can find R. What is going to be R? Quickly give me the answer quickly. Very good. This will be coming as sin R will be coming as 1 by 2. So R will be definitely, it can be 30 degree. So hence option D will be the right answer. Very good. So marakama like pannikoda. So now let us go for the next question. The plane wavefront is incident at an angle 37 degree with the horizontal. A boundary of refractive medium from air mu is equal to 1 to a refractive index of medium mu is equal to 3 by 2. Find the angle of refracted wavefront with the horizontal. Again simple, same relation we are going for, sin I by sin R which is equal to mu2 divided by mu1. So quickly find it da. Quickly you can give the answer. Refractive index order ratio vanthu we can find it, that is 3 by 2. Sin I is given, that is 37 degree. Adilirundha sin R you need to find it. Quickly you can give me the answer, everybody. So quickly go for it da. Simple irukku, sin 37 which is equal to sin R, and this mu2 will be coming as, what was mu2? It is 3 by 2. Okay, so we will be getting 2 by 3. Okay, sin 37 will be coming as 3 by 5. So 2 by 5 it will come. So sin inverse 2 by 5 the answer varapore. Hence option B will be the right answer. Okay, are you guys getting it? Why you are not giving the answer? Any confusion with the question? Please let me know. Quickly tell me da, is there any confusion with this question? Should I repeat? Okay, yes, option B da. Yes Arun, yes, very good. Yes, others, can we go for the next question? Ready ya? Can we go for the next question? Durai, it is very simple da. Nama what is a Snell's law da inga use pannirke. Okay, we know that wavefront aanalum Snell's law ellame vantu valid da. So sin I by sin R which is equal to mu2 by mu1. So mu2 na 3 by 2 da. Okay, and mu1 na 1 da. So basically we will be getting 3 by 2. So just now you need to substitute for sin I na 37, sin 37, and this ratio we can just take it over here. So we will be getting sin R. 3 by 5 da, 3 by 5. So idu da vanthu adoda triangle. Okay, just listen here. So idu da vanthu 37, இதுதான் வந்து நம்ம 53 and this is what 90 degree. So opposite to 37 3, 53 4 and this one will be 5. So sin 37 na it will be opposite divided by hypotenuse, which will be 3 by 5. Got it? Understood everybody? So இதுதான் வந்து இப்படிதான் we will be going for the triangle for 37 53. Yes, done. So now let us go for the another question. A ray of light wavelength 5000 nanometer traveling from a medium with refractive index 3 by 2 suffers a partial reflection and refraction. Okay, partial reflection and refraction. So now you need to find the wavelength of the reflected and refracted ray. So now suddenly I am asking you, for the reflected wave, what is going to be the wavelength? For the reflected one. For the reflected one, which means it is to the same medium, right? So what is going to be that wavelength? What is going to be that wavelength? Incident wave oda wavelength வந்து 5000 da. Now my question is, instantly you can tell me in the reflected wave oda wavelength enna aga pore. Very good Arun, it will be coming as same, so which means 5000 nanometer. So adile irundha we got the answer as 5000. Now the thing is like how we will be finding for the refracted ray. Okay, so adukku vandu we already studied one relation. Okay, previous chapter la da in the relation we have studied mu2 by mu1 will be coming as lambda 1 by lambda 2. Correct? So idhula vandu lambda 1 we know, we need to find lambda 2. So this one will be lambda 1 into mu1 divided by mu2 it will come. Lambda 1 na ennada, it is coming as 5000. Yena in the first mediathil irukra velocity vandu 5000 da, and in the what to say, in the relative velocity, sorry, in the refractive index order ratio you can take it 4 by 3 divided by 3 by 2 it will come. So now you can find lambda 2. All values, everything is given in the question. So now you just need to check 5625. Adha வந்து the answer. So let me go for the next one. So இது வந்து just substitution da irukke, you can just do it. The resultant intensity after the interference of two coherent waves represented by y1 is equal to a1 cos omega t and y2 is equal to a2 cos omega t. What is going to be the resultant wave oda intensity? Illana in the what is a amplitude one you can find it. So adukapra you can just go for the square. So how we will be finding it? The net amplitude will be coming as root of a1 square plus a2 square plus 2a1 a2 cos phi da. So inga vandu paakumbodhu we can see that a1 square plus a2 square plus 2 into a1 a2 cos phi na enada cos pi by 2 da. Okay, cos pi by 2 na in the value vandu coming as 0. Appadina you will be getting root of a1 square plus a2 square as the net amplitude. Now what is the question? Intensity the question. We know that intensity is proportional to a square. So you can just find the square of this part. A1 square plus a2 square, the whole square will be coming as a1 square plus a2 square. Are you guys getting it? Yes or no? Tell me quickly. Tell me quickly da. Are you guys getting it? Yes, very good. Now let us move on to the next question. Two beams of light having intensities I and 4i interfere to produce a fringe pattern on a screen. The phase difference between the beams is pi by 2 at a point A and 2 pi at a point B. Then find out the difference between the resultant intensities at A and B. This is the question. Okay, two beams irukke, intensity is also given. Now you just wanted to find the resultant intensity. Okay, so adukku vandu first vandu you can find it for the intensity when the phase difference is coming as pi by 2. Okay, so now we know that the intensity at A, which is which is coming as I1 square, sorry, I1 plus I2. So that will be coming as, what was that I1? I1 is given as I plus 4I plus 2 into root of 4I square. Yeah, 4I into I. Then cos the angle will be pi by 2. Okay, va? So in the madri you can find it for IB as well. Adikapra you can go for IB minus IA. This is what the question. Quickly you can tell me the answer. Check it again, da, check it again. So find it what is coming as the answer. So in the first case, cos pi by 2, na, it will be coming as 0. Okay. So now the answer will be just coming as 5i. And second case, it will be coming as 9i. This will be 5i. This will be 9i. So this will be coming as 4i. Hence option B will be the right answer. Very good, very good, very good, very good. So let us go for the next question. Ready, Ada? Everybody ready? So in the question, consider YDSA arrangement shown here, lambda which is equal to 0.25d. The number of maxima formed on the screen is, the number of maximas that we need to find. So first one, you can find this d value. Okay, you can find the d value. So inga vandu paakumbodhu lambda vandu 0.25d da. So d will be coming as lambda divided by 0.25. So this will be coming as 4 lambda. So d will be 4 lambda. And we know that at the central maxima it will be coming as 0. And the last one is 4 lambda. So we can say that at the infinity it will be coming as 4 lambda. Okay, va? So now the thing is like, if I'm just going for on the screen, you can see this is 0, this is minus lambda, this is coming as plus lambda, this is plus 2 lambda, this is coming as plus 3 lambda, here again minus 2 lambda, minus 3 lambda it will come. So altogether 4 plus 3, 7 it will come. So hence we can say that option D will be the right answer. Okay, va? So in the case, the total number of maximas na adukku vandu n lambda. Okay, so idu vandu 4 lambda varaikum pogum. So we can say that the answer will be coming as 7 lambda for this case. So now in a double slit experiment, the distance between the slit is 3 millimeter and the slits are 2 meter away from the screen. So we know D is coming as 3 millimeter and capital D is coming as 2 meter. The interference pattern can see on the screen, one due to the light with wavelength that is 480 millimeter, and the other lambda 2 which is coming with 600 nanometer. What is the separation on the screen between the fifth order of the bright fringe of the interference pattern? So bright fringe na, in the case both the case we can say that, okay, bright fringe order what is the equation vanda, we know that y is equal to n lambda capital D. Okay, this is the equation. Correct, Ada? This is the equation. Yes, Arun, any confusion in the previous question? Yeah, B will be the answer, 4i. Okay, so in the case, y will be n lambda d by d da. So you should find y1 as well as y2. So in both the cases, y1 na both the cases n value same da, because we need to find the fifth order bright fringe. Okay, so adanala n value will be coming as 5. Okay, so next one, we know the wavelength order value we know, D value we know, small d value also we know. Now you can just find it, then you can go for y2 minus y1. So So இதெல்லாமே வந்து nanometer தான். Okay. So அங்க வந்து millimeter தான் they have given. So I think it will be nanometer only. So இதிலிருந்து you can find y1 and y2, then you can go for y2 minus y1. Done? Now we have few more questions left. Anavanta, straightly I am going for the next chapter. Okay. So in the rest of the questions, vanda naleki session la we can just solve. So let us go for, now we can just go for the another chapter. We are starting with the modern physics. It is nothing but dual nature. Okay. So this is what the chapter we are going for. Okay. So are you guys ready? Are you guys ready? 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 Now give me a fire quickly. Yes, modern physics. So adukku munadi let us just have a 5 minutes of break. Okay. We can just continue by 5:30. Okay. Okay. So everybody come on time, 5:30 ki we can just continue. So guys, let us continue. Hi everybody. Everyone is feeling exhausted. No, ma'am. Fire. Okay, great, great, great. So, where is my phone? Yeah. Okay. So now we are going to start with the dual nature chapter. And I think dual nature also we can just solve some questions. Adukapram we can go for atom, nuclei and everything. Okay, va? So guys, you can just like the session. Okay, so now let us just start with the chapter dual nature. Okay, wow. So in the dual nature chapter, we can see that, okay, we can see that on the chapter it's talking about light the wave, illa ray, illa particle, it will behave as both. Okay, and the madri in the matter, illana what to say the bulk materials kuda in the madri ta behave pandra, adu kuda particle and wave behavior irukku. Adha vandu in the chapter summary. So in the beginning, in the chapter beginning, first we should know about photons. Yenada in the photons. Illa Aisha actually I went for taking a very small video for you people. So in the 15 days da irukella, so adula how you should plan your day and what you should focus. Adha actually I was just taking the video and I have shared, so that will be uploaded in few hours. Okay, so yeah, so snacks edun saapidlada. I think I will go by class around 8 o'clock we can finish. Then we can just have snacks or else dinner. Okay. Naaliki vanda session irukumda 5 o'clock. I want all you people to be there. Okay. Namukku vanda whatever be the chapters we are skipping today, and the question practice ellame adu vanda we will be continuing in that class. Will it be okay? Okay. Okay. So now, marakama like panikoda. Also, I want you people to share this video. Okay. So everybody be, you have to be, you cannot be selfish. Hey, where is this mouse? Okay, let it be. I hate this mouse. Go. Yeah. So now the thing is we are talking about the yes, sure. I'm waiting for you people for tomorrow's session. Okay, question practice matunda irukku. Adula vandu concept edunda we are not going to cover. We will just focus the questions. Okay, va? So now the thing is we are going for the dual nature. Adula vandu first topic enna photons da. Photons na enna idu vandu energy package da, which means we have mentioned light ku vandu it is not just a wave, adukku vandu particle behavior irukku, and the particle behavior da in the photons. Okay, light kulla irukra particle da actually vandu in the what is in the metal surface illema whatever it may be, it will be interacting. Okay, if in the radiation vandu illana in the waves ku vandu illana light ku vandu if it needs to interact with the matter na, definitely what should be the condition, adukku vandu particle behavior irukanum. In the radiation ku illana in the light ku vandu particle behavior irukanum, and the particle da in the photon. And in the photon vandu eppovume it will travel with the speed of light. What is the speed of light, guys? Can you just give me the value? Yes, we will rock this tomorrow session, definitely, of course. Okay, enakku vanta I have I think I wanted to know, guys, the thing is like what you are looking for, okay, in the physics in the time in the last few days what is your expectation? You are looking for the concept classes, or let's say you're looking for the questions or questions only. What is your requirement? Adu vandu you should know. Almost all the chapters la irundha questions solve pannumda. Major vandu inneki whatever be the chapters we are skipping adula irukra questions da we will start with, then we will go to the 11th grade also. Ipo vandu ray optics la irundha kuda we have skipped some of the questions na adellame vandu we will be doing tomorrow. Also we will be doing some questions from the 11th grade as well. Okay, yes, very good, very good. So ipo vandu in the photon vandu eppovume it will be traveling with the speed of light, and also idoda rest mass vandu we are considering it as 0. Okay, actually vandu in the photon if it is traveling with this much of speed na, we cannot just hold it and we cannot just measure the weight, correct? We cannot just measure the mass of it. So adanal we are just considering rest mass il irukumbodhu. Okay, rest il irukumbodhu adoda mass vandu it is actually 0. Okay, and idukku vandu energy irukku, momentum irukku. Energy ku vandu equation, okay, energy oda equation vandu it is nothing but h mu da. Okay, energy of the photon na adu vandu h mu da, and also idukku vandu momentum irukku. Momentum is nothing but it is h by lambda. I was just trying to write with my left hand, anyway it's a flop. Okay, okay, so ipo vandu momentum enna h by lambda da. So in the things vandu you should study. So in the h mu na, okay, h mu na enna da? H mu na h into frequency illa. Frequency na enna? Frequency na enna? Velocity by lambda da. Okay, ana in the case of photon la in the velocity na speed of light da. So now I'm just rewriting this. This will be coming as hc by lambda. Okay, this will be coming as hc by lambda. So energy equation vandu we got it. Now the thing is like idu vandu the energy of one photon. Ipo vandu n number of photons irundichuna, what is the total energy? If there are n number of photons, the total energy will be n into hc by lambda, or let's say n into h mu da in the total energy varapora. Appadina I wanted to know the power. Power oda expression ennada? Total energy divided by time da. Appadina I can say n into hc by lambda divided by t. So number of photons per time na, okay, number of photons per time na, it will be coming as the small n. So I can say that n into hc by lambda, or let's say n into h mu da namma power value. Got it everybody? So what is the equation? What is the expression for power? Power is nothing but n into h mu, correct? N into h mu da namma power oda expression varapora. Next vandu I wanted to know for intensity. Okay, intensity na enna? Power by area. Illana we can say energy by area into time. So now we got it. What is the power? Okay, so power ennada? It is nothing but n into h mu divided by area will give me the intensity oda expression. Very good Sasmita, very good Durai. All the answers whatever you have mentioned was correct. Okay, very good Aisha. I wanted to write with my left hand, but it's very difficult for me. Okay, so now we got the intensity as well. The what is in the photon oda energy vandu we got it, power vandu we got it. Next vandu another topic which we need to study is, okay, which we need to study is nothing but the radiation pressure. Okay, radiation pressure. Maybe few students were hearing this for the first time, but we should study this. Radiation pressure na in the light ku actually vandu pressure, it can push the objects. Okay va, adana vandu we are saying radiation can push the object, or radiation can what to say, what Aisha, what is the problem? Ma'am, the thing that is concerning is that we know amount of concept, but if see a question I stuck with how to understand the question paper and which formula is suitable. So simple arkeda, adukku vandu I wanted to tell you. Okay, so now the thing is like just focus over. If we are just focusing, you are just focusing on the what to say, question practice. Okay, so idhula vandu how many questions and the chapter la irundhu how many questions you have solved. Okay, adukku vandu or answer kadaikanum Aisha. Okay, so ipo vandu you have done 100 questions, 150 questions, adukapram you are doing the questions, still you are struggling. Okay, and the 100 questions solve பண்றதுக்கு அப்புறம் you are just feeling the same difficulty na, I can understand this message. Okay, whatever you have given the comment, I can understand. Ana neenga vandu you will be doing some 10 questions, and the 10 questions la mostly you cannot do, and you will judge yourself ennala mudiyadu. Okay, adha vandu அந்த attitude da change பண்ணனும்டா. Just understand, இப்போ வந்து if you are focusing on, okay, if you are focusing on the in the question practice na, minimum do 100 questions. Adukapram whatever be the questions you are solving, you will feel like on the 10 questions la 9 questions vandu ungalaala mudiyum. Okay, ana in the judgmental vandu it is coming little early. After 10 question itself we are thinking like I can't. Okay, adu vandu usually students vandu they will be get demotivated at this point, and they will lose their confidence, they won't do more questions. Okay, physics vandu ennala mudiyadu, ana just do 100 questions da, and the chapter la irundha 100 questions solve பண்றதுக்கு அப்புறம் you just do another 10 questions. I'm telling you, initially whenever you are starting the chapter, first 10 questions la 9 questions you cannot do it, ana in the 100 questions க்கு அப்புறம் if you are doing another 10 new questions nalum adula vandu your ratio will increase. Okay, so adudha vandu the logic behind it. So now radiation pressure da concept. In the radiation pressure na, yes Damodara. Okay, so radiation pressure na actually vandu in the light can actually exert force on the object. So on the force, on the expression vandu it is having a expression. Let us say ipo vandu idu reflecting surface ah irukke. Okay, what is happening, idu vandu oru reflecting surface da. So ipo vandu idu oru reflecting surface na, okay, idu vandu reflecting surface na, the photon will come and fall on it, and what is the momentum, ipo vandu in the direction la if I am taking it as positive na, idu vandu h by lambda da. Okay va, reflecting surface nala definitely this will come back with the same momentum h by lambda. அப்படினா change in momentum, okay, change in momentum ங்கிறது 2h by lambda minus 2h by lambda it will come. So now I'm just going to find the pressure, and I will be getting the pressure exerted in this case will be 2I by C. I na intensity da, in the case la power illada, pressure da. Okay, radiation pressure da, which will be coming as 2I by C. Next one, instead of a reflecting surface, I am going for an absorbing surface. Okay, I'm going for a absorbing surface. So what will happen, in the momentum will come in the photon will come and fall, and it will be absorbed by the surface. அப்படினா change in momentum வந்து it will reduce to h by lambda, ஆனா pressure வந்து it will be coming as I by C. Okay va, so pressure in the reflecting surface, radiation pressure due to reflecting surface வந்து 2I by C da, I na intensity, C na speed of light da, and for that case it is absorbing surface da. Absorbing surface la in the radiation pressure வந்து it will be coming as I by C. Got it everybody? Everybody understood? So idha vandu nama first understanding. Everybody do like the video, also share this video with your friends. Ena modern physics na adu vandu easy ah score panna mudiya oru chapter da. Okay va, purinjida? Yes. So now the radiation pressure is done. Next one vandu we know that we can excite the electrons, or let's say electron can escape once it is getting a sufficient energy. அதுக்கு வந்து 3 methods இருக்கேன்டா. 3 methods na, first வந்து thermionic emission. What is going to be thermionic emission? Can you just give me the answer in the comment box, because you guys know it, thermionic emission. அந்த term ல இருக்கு thermionic emission. So இந்த electronக்கு எப்படி it is getting the energy? Thermionic emission na, இதுக்கு வந்து கொஞ்சம் voice increase பண்ணனுமா? Can you just increase the volume of your mobile phone? Okay, because I'm almost done with my throat. Yes, very good, Sasmita, it will be, we are giving temperature, we are giving heat energy, and the heat energy use பண்ணி electron will escape. correct? Next one, the field emission. What is going to be field emission? Thermionic emission na heat energy in the electron and the surface escape பண்றதுக்கு தேவையான energy வந்து the energy required for the electron to escape from the surface will be given by this heat energy. Now field emission, very good Susmita, it will be coming as electric field. Okay, strong electric field we will give, and definitely what will happen? Definitely electron will absorb the energy and it will escape. And the third one is nothing but photoelectric effect. Can you just define what is photoelectric effect? Photo and the term illa irukku, photo na adu vandu related ah irukkiradhu light. Okay, ana vandu all light cannot excite the electrons. There is a more specification over there, light with suitable frequency. Correct? Light with suitable frequency will come and interact with the, okay, appo vandu you should think, okay va. So ipo vandu in the surface il irukra electron, okay, in the surface il irukra electron, okay, idu vandu or particle da. அப்படினா the light is coming. So light க்கு வந்து particle behavior இருக்கணும்ல. அப்படினா tell me da. So இந்த electronக்கு excite இல்லனா அதுக்கு வந்து escape பண்ற அளவுக்கு energy is provided by. இந்த light தான் புரிஞ்சுது. ஆனா more specific how we will be saying yes, இந்த photon தான் energy. Okay, light ல இருக்கிற photon. ஏனா light is interacting with the particle. அதனால light க்கு வந்து particle behavior இருக்கணும். அதனால light ல இருக்கிற photons தான் actually வந்து இந்த electrons கூட interact பண்றேன். புரிஞ்சுதாடா? So now we got to know the photon will interact. Okay, light la irukra photon வந்து interact with the electron, and the photon absorb பண்ணி electron will get an energy and it will escape from the surface. ஆனா இப்போ வந்து if I am giving any photon, okay, or any light, basically won't give you the what to say in the electron emission. அதுக்கு தான் I have asked you, there is a condition, the suitable frequency. ஏனா இந்த photonோட energy வந்து h𝛎 தான். Correct? H na Planck's constant 6.6 into 10 to the power minus 34. So adala vanta we don't have much things to say. So in the Planck's constant in the frequency na we can say that when frequency increases, energy of the photon will also increase. Okay vada? Now the thing is like ஒவ்வொரு மெட்டல்லுமே இல்லைன்னா ஒவ்வொரு மெட்டீரியல்லுமே இருக்கிற எலக்ட்ரானுக்கு வந்து தேவையான எனர்ஜி, which means escape பண்றதுக்கு தேவையான எனர்ஜி வந்து டிஃபரெண்டா இருக்கும். ஓகே, ஒவ்வொரு மெட்டீரியல்ல இருக்கிற எலக்ட்ரான்ஸுக்குமே வந்து the energy required to escape from the surface வந்து டிஃபரெண்டா இருக்கும். அந்த வேல்யூ இல்லடா, அதுதான் வந்து whatever we are calling work function. Okay, what is work function? அந்த எலக்ட்ரானுக்கு தேவையான எனர்ஜி. Okay, sometimes வந்து நீங்க வந்து if you are just sleeping na, I mean suddenly your parents will say வா மூவிக்கு போகலாம். Okay, அப்போ வந்து what you will do, you will suddenly wake up, right? So அந்த மாதிரி தான் இந்த எலக்ட்ரான்ஸ்க்கு தேவையான எனர்ஜி கிடைச்சேனா it will escape. Okay வா, it will escape. So அதுக்கு வந்து தேவையான minimum எனர்ஜியோட amount தான் work function. So usually வந்து work function we will represent it like this, which will be coming as h into mu naught தான். புரிஞ்சுதாடா? So we will be getting work function is equal to h mu naught. In the mu naught da, you were saying a lot, people were saying more than threshold energy, this is the threshold energy. Okay, so in the work function பார்க்கும்போது h வந்து constant da, in the mu naught value will be different for different materials. So இப்போ வந்து I am taking a specific material, அதுக்கு வந்து தேவையா இருக்கிற எனர்ஜி வந்து h mu naught னா அந்த ஃபோட்டோனுக்கு இந்த mu naught விட அதிகமா எனர்ஜி இருக்கணும், which means இப்போ வந்து ஃபோட்டோனோட எனர்ஜி தான் mu. So mu is greater than mu naught, then only the emission will happen. புரிஞ்சுதாடா everybody? Emission happen, I mean if you need the photoelectric emission na, அதோட condition என்னடா, in the frequency should be greater than the threshold frequency. If the frequency is less than the threshold frequency, what will happen? Nothing will happen, ma'am. Emission வந்து it is not going to happen. Got it everybody? Give me a heart if you understood. Everybody give me a heart if you understood. Yes. So இப்போ வந்து we got the condition. Okay va? So now I just wanted to show you a diagram. So on the diagram based பண்ணி we can just go for it. So இதுதான் வந்து நம்ம experiment. Okay, photoelectric effect-க்காக we have done an experiment. So இதுல வந்து பாக்கும்போது this is what we are calling emitter plate. Emitter plate என்ன emit பண்ணும். Okay, அப்போ வந்து we should understand electrons வந்து emit பண்றது வந்து இந்த plateல இருந்து தான். இது வந்து collector plate, which means அங்க இருந்து whatever be the things emitted, இந்த plate will actually absorb. இல்லனா அது வந்து it will take all or it will collect all the electrons coming from this. Understood? So in the beginning, what I'm going to do, I will be giving positive potential to the collector plate and negative potential to the in the second plate. In the in the emitter plate, I will be giving the negative potential. Now imagine, one photon is coming and falling on the surface. Okay, one photon is coming, which is interacting with the electron. Now the thing is like, okay, just listen carefully. இப்போ வந்து ஒரு photonக்கு வந்து it can interact with only one photon. One electron can interact with only one photon. So இப்போ வந்து one photon is coming and it is interacting with the electron. So இப்போ வந்து அதுக்கு வந்து work function விட அதிகமா இருந்தா energy வந்து if it is more na, definitely the electron will escape. So இப்போ வந்து இந்த எலக்ட்ரான் பாக்கும்போது இங்க வந்து more negativity தான். எலக்ட்ரானுக்கு வந்து எப்பவுமே higher potential இருக்கிற ஏரியாவுக்கு it wants to go. அப்படினா இந்த electron will say, okay, I will go to the collector plate. ஏனா collector plate வந்து positive potential இருக்கு. So definitely இப்போ வந்து இந்த electron is thinking like I wanted to escape from the collector, emitter plate to the collector plate. அப்படினா அதுக்கு வந்து ஒரு extra energy இருக்கணும்லடா. அதுக்கு வந்து ஒரு kinetic energy இருக்கணும். கரெக்ட்டா? இப்போ வந்து இந்த plateல இருந்து if it needs to travel towards here na, அதுக்கு வந்து ஒரு எனர்ஜி இருக்கணும். So extra வர எனர்ஜி, okay, இப்போ வந்து ஒரு photon, if we are just focusing on a photon na, அதுக்கு total energy வர போறது h𝛎 தான். அதுக்கப்புறம் it will be having the work function h𝛎0, which means அந்த electron is absorbing the work function. இல்லனா அதுக்கு தேவையான எனர்ஜி வந்து it will absorb and there will be some extra energy. Okay, இப்போ வந்து இந்த mu value is greater than mu0 na, அந்த threshold frequency க்கு அப்புறம் இல்லனா அந்த work function க்கு அப்புறம் it will be having little bit more energy. Okay va, அந்த energy is utilized for the maximum kinetic energy. அந்த emitter plate ல இருந்து collector plate வரைக்கும் வரணும். So அதுக்காக extra இருக்கிற energy na என்ன, h𝛎 தான் total energy. அதிலிருந்து இந்த work function subtract பண்ணினா whatever be the energy it had, that will be nothing but the kinetic energy. புரிஞ்சுதாடா everybody? Everybody understood, yes or no? Give me a heart if you understood. Quickly give me a heart, everybody. Okay, so this is what the first thing. Now the thing is like, we said it will interact, okay, one photon with one electron. Now I am saying intensity increases. Intensity increases na, sometimes நம்ம classல brightness increase ஆகும், decrease ஆகும்ல. So அந்த மாதிரி intensity increase ஆகும்னா more brightness தான். Okay, more bright இருக்கு. Light வந்து more bright இருக்கு. அப்படினா okay, இந்த intensity அதிகமா இருக்கு, more bright light தான் இருக்கு. So definitely what will happen, number of photons, okay, number of photons வந்து it will be more. Now you guys have to tell me, number of photons is more now, what it is indicating? What about the number of electrons emitted? It will increase or decrease? Tell me. So இப்போ வந்து intensity is more, number of photons is more. So now I'm asking you, what will happen to the number of electrons emitted? What will happen? That will also increase. Why the number of electrons will increase? What is the reason? ஏனா one photon will interact with one electron. அப்படினா intensity double ஆச்சுனா 2 photons இருக்கும். அப்படினா 2 electrons will be emitted. Now I am making intensity to 10 times. So 10 photons la 10 electrons will be emitted. So that will also increase. Very good. So it will increase. Now number of electrons increases na, flow of electrons வந்து அதிகமா இருக்குல்ல. So definitely இங்க வரப்போறது, we know that in the flow of electrons is actually due to light தான். Okay, so அப்படினா electrons ஓட flow na usually we will say current தான். அப்படினா இந்த current due to light இல்லையாடா. So அதனால we will just call it as photo current. Got it? We will call it as photocurrent. So now I can say that in the case like intensity increases now, the photocurrent will also increase. Now quickly I'm going to ask you a question. Just give me the answer. Okay, wow. So if I'm increasing the intensity, what will happen to the kinetic energy? Will it increase or decrease? இப்போ வந்து intensity increase ஆச்சு. Now my question is kinetic energy will increase or decrease? Intensity increase ஆச்சுனா what will happen to the kinetic energy? Will it increase or decrease, or what will happen? Tell me quickly. Quickly tell me da. It will be remain same. Yena intensity is not actually depending upon, okay, intensity is not actually depending upon the what in the what is in the kinetic energy and intensity vande the relation illa. Okay, intensity is increases now, we can say that in the current value will increase. Okay, wow. So next one if I am increasing the frequency, okay, if I am increasing the frequency, very good, very good. If I am increasing the frequency, what will happen? Increasing the frequency, kinetic energy ki enna agum? Increasing the frequency na kinetic energy will increase or decrease. You can just mention I or D, make it very easy. I or D, increase or decrease. Frequency increase achuna, what will happen to the kinetic energy? Very good Susmita, it will increase. Now tell me what will happen to the photocurrent? Ipo vand frequency increase achuna, photocurrent will increase or decrease? Photocurrent ku enna aga pore? What will happen? Photocurrent, it is not going to be affected. Correct? ஏனா frequency increase ஆனாலும் பரவாயில்ல, definitely intensity increase ஆனா மட்டும் தான் இந்த photo current நால increase ஆக முடியும் இல்ல decrease ஆக முடியும். So frequency increase ஆச்சு, that doesn't mean like current will change, but definitely kinetic energy will change. Very good, very good, very good guys. No change Arun, yes Durai, yes Damodara, yes Aisha, very good, very good, very good. So now I wanted to check. So in the case we have discussed all those things. Now I'm just changing the polarity. இப்போ வந்து இந்த collector plate ல negative potential, emitter plate ல we are giving positive potential. அப்போ வந்து electronோட mind வந்து change ஆச்சு. Okay, it wants to stay back with the what is emitter plate. அது வந்து positive இருக்குல்ல. So electronsக்கு வந்து actually வந்து they are happy with that. But what I'm doing, I am giving more energetic photons. Okay, more energetic photons. So at some point, okay, even if the electron is just overcoming that potential and it is trying to come to the collector plate. Are you guys getting it? Are you guys getting it? So what is happening? I'm okay, I'm very much okay. No issues at all. Okay, so இப்போ வந்து what is happening da in the photo, in the electrons, emitted electrons when I'm giving high energy photon, and the high energy photon use பண்ணி actually வந்து இந்த electron is actually coming. ஆனா what I'm doing, நான் வந்து இந்த potential increase பண்ணிட்டே இருக்கேன். So what will happen in the collector plate, அது வந்து it is more potential, more negative potential. So even if it is trying to come also, in the negative potential will try to oppose it, and at some point this electron will come to rest. Okay, electron will come to rest na, I can say that in the photo current oda value 0. Am I right or wrong? So இப்போ வந்து if I'm saying the electron oda flow வந்து stop ஆச்சு, which means can I say that photo current வந்து 0 இருக்கு? So now the thing is like அதுக்கு corresponding, which means in the photo current 0 ஆகிற momentல இருக்கிற potential இல்லையாடா, அந்த potential ஓட value வந்து it will be coming as, we will call it as stopping potential. When photo current becomes 0, that particular potential will be called it as stopping potential. Very good, very good, very good. I can see you guys are giving the right answers properly. Very good. So photo current is 0, which means we can say that the stopping potential and the corresponding potential one the stopping potential. Again another question. Intensity increases. What about stopping potential? Will it increase or decrease? Intensity increases. What will happen to the stopping potential? Will it increase or decrease? Quickly tell me. Intensity and stopping potential have no relation. Okay, it is not going to be related. So we cannot just make any relation as well. Now I am asking you, frequency increases, what will happen to the stopping potential? Yes, when frequency increases na definitely வந்து இந்த stopping potential கூட increase ஆகும். ஏனா frequency increase na definitely இந்த electron stop பண்றதுக்கு அவ்ளோ amount of potential they have to provide na. So definitely what will happen? This will be coming in the opposite direction. Now I just wanted to make few relations. Just focus பண்ணிக்கோடா. Total energy, okay, total energy of the photon வந்து h-mu da, which will be utilized for the work function and the kinetic energy. We know that to h-mu naught plus EVS. Now the thing is like we should study some of the graphs. Okay, so let us just quickly go for some of the graphs. Okay, look at this here. First one வந்து photo current and intensity. We know that it will increase. இது வந்து ஒரு linear relation தான். So first graph வந்து முடிஞ்சது. Second one வந்து what will happen if we are increasing the frequency? What will happen to current? It won't change. Okay, stopping potential வந்து increase ஆகும். When frequency increases, stopping potential will also increase. Next one வந்து we have the stopping potential and we are increasing the intensity. When we are increasing the intensity, the current value will change. Okay, வந்து stopping potential will remains the same. Next one வந்து we already written the equation, right? We already written h-mu minus h-mu naught, which is equal to EVS. Now I am taking this E over here. So h by mu minus h by E mu naught, which is equal to Vs. Now I am just comparing this with the equation y is equal to mx plus c. So this is representing a linear, a straight line equation, which means in the y-axis I am plotting Vs, which means the stopping potential, and in the x-axis I am plotting the frequency mu. Okay, wow. So now if I am plotting, I know that the slope, compare this and tell me what is going to be the slope. What is the slope? Very good. The slope will be coming as h by e. h by e na enna? h na Planck's constant. E na 1.6 into 10 to the power minus 90. இது ரெண்டுமே வந்து it is actually constant values da. So அதனால இந்த slope na definitely for any of the material, slope will be same. That will be nothing but h by e. In the y-intercept, in the c value, it is going to be different. Okay, why it is different? And the c value, it is nothing but the work function divided by e. Correct? As we said, in the work function, it will be different for different materials. Adanala, in the y-intercept, it will be different for different materials. Slope, it is going to be h by e. Got it, everybody? Understood? Na? Give me a heart in the chat box, and in the in the video, you can just like the video as well. Okay, nothing, Aisha. Just in the equation parungo. In the y-axis, whatever we are plotting, stopping potential da. X-axis, in the equation you can see that frequency da plot pandre. Now comparing with this, in the slope h by e da. Adu eppavume constant arkum. Whether the material changes, whatever happens, Planck's constant and e value fixed da. Adu change agadu. Okay, and for this the slope will be same for if you are doing for different materials nalum idellame parallel irkum. And now the thing is like, okay, h by e da nama what is slope varudhu, and this y intercept in the c value na enna, it is actually the work function per in the e value da adu different irkum. ஏனா ஒரு மெட்டீரியலுக்கு அது கான்ஸ்டன்ட், பட் for different materials it is going to be a different value. So you are going to get it as, you will be getting it as, you can see that different points you can just see the y-intercept. Okay, so these are the things we should study in the what to say this part. So next one we know that if a particle is interacting with the radiation, okay, particle is interacting with the light illana radiation na, and the particle ku actually wave property irukkanum. Okay, wow. So that is what we are calling matter waves, illana de Broglie waves we are calling. Okay, so on the de Broglie waves we can just see for very small particles like electron, neutron, you can just see it. And huge objects we cannot see it. So in the matter waves, illana the de Broglie waves actually we can say that in the lambda wavelength of this matter waves it will be coming as h by p. H by p na h divided by mass into velocity. Now you can also say h divided by root of 2 into m into e in terms of kinetic energy. Okay. Let us say you can also rewrite this kinetic energy as in terms of potential energy. So that will be coming as q into v. Okay, wow. So now the thing is like this is what the equations you have. And for a gas, okay, and for a gas you can just replace this energy with 3 by 2 kBT. Kb na Boltzmann constant da. So we will be getting the equation for the gas also. Everybody got it? Everybody got it? Yes or no? Yes or no? Now one last concept which is nothing but the why wave theory cannot explain few things. So, we are talking about the photoelectric effect, right? So, in the photoelectric effect, அது ஒரு instantaneous process da, which means 10 to the power minus 9 seconds happening process da in the what to say in the photoelectric effect. ஆனா பாக்கும்போது okay, ஆனா பாக்கும்போது you can just see that in the photoelectric effect, okay, in the photoelectric effect பாக்கும்போது according to wave theory இது ரொம்ப time consume பண்ற ஒரு process தான். ஆனா இந்த photoelectric effect experiment பார்த்தேல்ல அதுல இருக்குறது we understood 10 to the power minus 9 second this is happening. And also light with any frequency, okay, light with any frequency should emit the electron. But that is not the case when we are doing the experiment. Light with the proper frequency, more than the threshold frequency, adu mattum da actually electrons emit பண்றதுக்கு helpful ஆ இருக்கு. இப்போ any frequency which is less than threshold frequency, it is not happening. ஆனா wave theory, according to wave theory, they are saying this is something, I mean in the whatever be the frequency, electron emission should happen. Okay, va? And also intensity increases na kinetic energy increase aganum. Adha according to wave theory. Ana we know that intensity increase achuna photo current increase agum. Ana kinetic energy la there is no change. Done. So dual nature is done da. So let us do some questions. Are you guys ready? Are you guys ready? And hardly 2 hours we can just finish. So the dual nature la few questions we can do, the rest of the questions we can do it for tomorrow. Okay, adukapram atom and nuclei we can just quickly go for it. Semiconductors also adukapram we can just wind up. And in the current electricity, electrostatics as well as nama magnetism idellame we are already done the videos and everything. And mudinjana I will go for one more marathon session. So adila irundhu we can just finish all the volume 1 also. Adukapram we can go for the 11th grade. Okay, idhula ray optics koncham lengthy ah irukku ena I wanted to make sure on the chapter actually I didn't even put any videos for ray optics in the channel. So adanala I was just made it little bit lengthy, little bit detailed version. இருந்தாலும் அந்த சாப்டருக்கு அவ்வளோ டைம் இருக்கும். Okay, even if we are trying to minimize also on the chapter it is not easy to take in a very short time, but yeah, definitely. Okay, next class la whenever we are doing for the quick revision we can just finish in 30 minutes. Okay, vada. So question practice பண்ணலாமா? What is the time now? 6:15. Okay, can we do the question practice? Ready ya? Ready? Okay, so let us go for it. So first question. Do the first question. Meanwhile, I'll take some water and I'll come. This becomes empty. Okay, just give me a second. You can just do this question. Meanwhile, I'll take some water and I will come. Done, everybody? Done. You guys should also drink a lot of water. Yeah, the thing is like we know that what to say. I am taking class and you people are listening, and I know few students when the starting morning you are just continuing, which is not easy at all. I know it. Majority of the students were like from the morning, so it is not easy. I know it. Yes, very good. Option A the answer varada. No photoelectrons will be ejected. Yena idhula vandu paakumbodhu work function is 4 electron volt da. Wavelength vandu 400 nanometer da. So first vandu you can find the energy. Okay. So energy vandu paakumbodhu it is nothing but hc by lambda da. So while you are substituting all the values for lambda, you will be substituting 400 nanometer, and you will be getting the energy of the photon which is less than this 4 electron volt, which means, okay, which means what? Definitely no emission will happen. So next question. The threshold frequency for a certain photosensitive material is 2 mu naught. Threshold frequency. Okay, wow. When it is illuminated by a light of frequency, mu is equal to 2 mu naught. The maximum velocity of the photoelectron is V naught. What will be the maximum velocity of the photoelectron if the same material is illuminated by a light of frequency? Mu is equal to 5 mu naught. Can you just find the answer for this question? Just read the question. I mean, that is enough for solving this. Simpler, you can just write two materials. You can just write the equation. Okay, va. First case la work function vanda 2 mu naught da. Okay, va. 2 into h mu naught da work function varada. And the case la photon order frequency vanda 2 mu naught, which means that energy which is nothing but 2 into h mu naught. And the time la irukra velocity vanda it is nothing but v naught. Second time what happened? We are increasing. Okay, we are increasing. What to say in the frequency one we are increasing to 5 naught. What is going to be the kinetic energy? Idakaga we can just use this equation h mu minus h mu naught, which is equal to kinetic energy. In the equation you can just do it. C. Okay. So I think metal order work function we can just take it as mu naught. Yena 2 mu naught na definitely kinetic energy irukadilla. So you can just take the work function as mu naught. Do it, guys. Check again. Calculation konjam kuda conscious irukkonumda. Yes, option it is coming as B da. Yena first case la total energy of the photon 2 h mu naught. Yena adu frequency of the light 2 mu naught da. Minus work function we will be take it as h mu naught, which is equal to kinetic energy, which is half into mv square. Next case la varumbodhu 5 into h mu naught minus h mu naught, which is equal to half into m into v square. Let me just say v dash square. So now paakumbodhu inga case la half mv square you will be getting h mu. Correct? So in the case la varumbodhu 4 h mu naught, which is equal to half m into v dash square. Now the question is you need to find the velocity. Yeah. So adinala idudha vandu namma equation 1, idudha vandu namma equation 2. So now half into m into v dash square divided by half into m into v naught square, which is equal to 4 h mu naught divided by h mu naught. So just cancel whatever be the things repeating. So v dash square will be 4 into v naught square. So v dash will be coming as 2 into v naught. Hence option B is going to be the right answer. Got it everybody? Everybody understood? Marakama like panikoda and also share with your friends as well. Okay. So now we are going for the next question. Okay. Next question anada. Okay, I hope it is visible. Let me just move a bit. Okay, I will reduce the brightness also. Okay, I think now it is visible, right? Okay, so yes, when a light is given with a wavelength falls on a metallic surface of stopping potential of the photoelectron is 3.2 V. If the second light having the wavelength twice of the first light is used in the stopping potential dropped to 0.7. Wavelength of the first light we need to find it. So idukaga again we know that we should use this equation hc by lambda, which is equal to phi plus E into Vs. In the equation podumda, you can just go for it. Yes. Quickly you can go for it. First case you are taking it as hc by lambda, which is equal to work function plus EVS da. And adula vandu paakumbodhu in the Vs value vandu 3.2 da. Now what happens? Second case la paakumbodhu this becomes hc divided by 2 lambda, which is equal to same material, so work function kuda same irukum, plus E into 0.7. Inga varumbodhu 3.2 E it will come. Now the thing is like you just need to find the lambda. So adakaga you can just subtract both the sides. So 5 will anyway go and you will be getting hc by 2 lambda on the left hand side, and you can just subtract the stopping potential part. Quickly. Yes. So hc divided by 5e the number lambda value. So h na 6.6 into 10 to the power minus 34, c na 3 into 10 to the power 8 divided by 5 into 1.6 into 10 to the power minus 19 will give you the lambda value. Do the calculation again da. Some calculation error is there. 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 5 into 1.6 into 10 to the power minus 19 it will come. So the answer is coming as 2.5 into 10 to the power. So adikaga they have given the Planck's constant value, Boltzmann constant value as well as mass. Okay. So now we know lambda is equal to, as we said, h divided by root of 2 into m into E da, and this value for a gas we have mentioned, we will replace it with 3 by 2 kBt. So in the 2 cancel as we will be getting root of 3m kBt. Okay, so this is the lambda value. This is the value 6.6 into 10 to the power minus 34. Root of 3 into 5.31 into 10 to the power minus 26. Boltzmann constant 1.38 into 10 to the power minus 23. and T you have to convert into Kelvin. So 27 plus 273, the T value will be coming as 300 Kelvin. So substitute and find the answer back quickly. Yes. Quickly everybody, and marakama like panikoda. Yes. Very good, Durai. Others? Very good. So option D, it will come approximately 26 the answer varapore. So now let us go for the next question. Light is incident on a metallic plate having a work function 110 into 10 to the power minus 20 joules. If the produced photoelectrons have zero kinetic energy, then the angular frequency of the incident light, angular frequency the needed. Okay, wow. So angular frequency definitely we can say that in the phi value na h mu da, correct? So now h mu, it is nothing but omega by 2 pi da, correct lada? So now you know the work function value, you know we need to find omega from it. H value is also given, 2 pi value you know. Now it is your turn, you can just substitute and you can find it. Idilirundu omega value. Phi is given 2 pi, 2 into 3.16, h na 6.63 into 10 to the power minus 34. Omega na angular frequency da. Yes, I'm getting the right answers. Very good. Yes. Option D will be the right answer. Very good. So we will be getting option D as the answer. Very good. So now let us go for the another question. The energy of a photon is equal to 3 keV. Calculate the linear momentum. So linear momentum na P is equal to H by lambda da, which we can also say E by C da. So in the case E na 3 into 10 to the power 3 into 1.6 into 10 to the power minus 19 divided by 3 into 10 to the power 8. Just do the question. You will be getting the answer, and quickly let me know the answer in the chat box. Yes. Very good, guys. Yes, the answer will be coming as option B, the 1.6 into 10 to the power minus 24. So, now I'm telling you, in the speed, if you are just maintaining for the exam, no, everything is going to be fine. Okay, so now let us go for the next question. A 2 milliwatt laser operates at a wavelength of 500 nanometer. The number of photons that will be emitted per second is. So, power they have given, power in 2 into 10 to the power minus 3 watt da. Wavelength it is given 500 nanometer, and the number of photons that will be emitted per second, n by t da we need to find it. Okay va? So idukku power order equation we know that power order equation na the total number of photons into energy of photon divided by t. Okay, so idhula varapora in the n by t da they were asking as small n, which means the number of photons per second. Now energy of photon na it is nothing but hz by lambda. So idhula vandu paakumbodhu we can say 2 into 10 to the power minus 3 will be, or let's say divided by hc into lambda will be giving you the n value. Now you can just do the calculation. So மறக்காம லைக் பண்ணிக்கோடா everybody. Everyone should like the session. Also share with your friends. Session will be, I just wanted to finish the content at least for atom, nuclei and semiconductor. Okay, volume 2 வந்து complete ஆகணும். Questions வந்து நாளைக்கு we can just do it. So அந்த 3 chapters எப்போ முடியும் அப்போ வந்து class it's done. Is it okay for everyone? So in the chapter முடிஞ்சேனா we can just go for a 10 to 15 minutes of break because நான் கூட tired இருக்கேன். So let me also have something to have. அதுக்கப்புறம் 15 minutes break எடுத்து we can just come back and we can just rock. We can finish 3 chapters. Content மட்டும்தான், no questions, just doing the content. Will it be okay? We can finish the, otherwise in the marathon sessions வந்து அதுக்கு வந்து slot அவ்வளோ கிடைக்காது. So I just wanted to go for one more marathon session. Let me see. Okay வா? Yes. So இதோட answer என்னடா? Answer என்ன? Normal water da. And you said na KitKat milkshake. That also I like. Yes, very good, very good. So we will be getting the answer as 5 into 10 to the power 50. Now let us go for the next question. The beam of intensity I falls perfectly on an absorbing sphere as shown, then force exerted on the sphere. So we know that the pressure which is equal to force by area da, which will be for a absorbing surface we have Z, it is I by C. Correct? It will be coming as I by C. Appadina, I just want this force. So which means I by C into area da it will come. So now just imagine இங்கே நான் ஒரு sphere தான் இருக்கேன். Okay, so in the sphere you can see that இப்போ வந்து இந்த sphere is actually facing me. So இப்போ வந்து the rays which is falling on the sphere. Okay, just understand. Okay, just focus. Sorry Aisha, sorry. Okay, so யாராவது it is all about KitKat milkshake. Okay, so now about you can see that இங்கே தான் இந்த sphere இருக்கேன். Okay வா, இந்த sphere இருக்கேன்டா, இந்த sphereல பார்க்கும்போது, okay, இந்த sphereல பார்க்கும்போது just my question is very simple. So inga sphere irukke, the rays vanda it will falling on the sphere. Now my question, ipo vanda the what will be the relation, okay, or the number of rays which is passing through the sphere and the number of rays which is passing through the shadow of the sphere. Will it be same? Of course, Samsida. And in the break I'm going for that only. Okay, so now tell me what is the relation? The number of rays which is falling on the sphere and the number of rays which is falling on the shadow of the sphere will be same? Yes or no? It is going to be same. So I'm just replacing this equation. I will be going for the projected area. So in the question la projected area in the sphere oda projected area na adu vanda adoda shadow da. Shadow na it will be coming as a circle illiyada. So definitely I by C into pi r square it will come. Hence I can say that the answer will be Option C will be the answer. Got it, everybody? Everybody understood, yes or no? So next question, a light wave is described by E is equal to 60 into sine 3 into 10 to the power 15 t plus sine into 12 into 10 to the power 15 t falls on a metal surface of work function 2.8 electron volt. The maximum kinetic energy ejected photo electron is approximately. So maximum kinetic energy oda equation enada, it will be nothing but h mu minus h mu naught da. Illana in the work function da. So in the kinetic energy, in the work function is already given. What was that value? 2.8 electron volt da. Now the problem is we don't know the energy, and the energy if you are finding na, it will be easy for us. So on the energy paakumbodhu, in the h mu na, I can just replace h into mu, again omega by 2 pi, like the same in the previous question. And we need it in the electron volt. So I'll be just divide it with 1.6 into 10 to the power minus 19. And idhila vantu you will be having a confusion. In the equation paakumbodhu, sin omega t plus sin omega 1t plus sin omega 2t, correct? Okay, so now the thing is like, this equation will be 60 sin omega 1t plus sin omega 2t. So now the confusion will be which omega we should take. Okay, va? Which omega we should take in this case. So in the case la omega na, we need the maximum kinetic energy. Adinala, among this omega 1 and omega 2, which one is a larger value? Adada vandu nama choose pannanom. So in the case la, which omega is more, omega 1 or omega 2? Which one is higher? Omega 1 or omega 2? Obviously, in the values paakumbodhe, we can see that omega 2 the namma what is a bigger value. So now you can just substitute the value 6.6 into 10 to the power minus 34 into omega na ennada. I will be going for omega 2, which means 12 into 10 to the power 15 divided by 2 into 3.14 into 1.6 into 10 to the power minus 19 will give you the answer. So quickly go for this. Yes. Very good. Definitely Darshika. But Darshika, you were just coming for asking this only. You didn't even give any answers, no. So how I'll get to know? You will be interactive in the, when I'm just taking the, in the 11th grade, and the time you will be again silent. How I'll get to know? Yes, Pooja. How 26 ah? Option la illada. Others quickly do da. Very good. So we will be getting 5.1 as the answer for the kinetic energy. So this I think you will be getting around 7.8 minus 2.8 it will come. So you are going to get 5.1 and the answer is asked in the electron volt only. So you can just go for the answer. So now, a subatomic particle of mass 10 to the power minus 30 kg is moving with a velocity 2.21 into 10 to the power 6 meter per second under the matter wave, considering the particle will behave closely like. So in the particle order behavior da, so at lambda is equal to h by mv da we need to find. H value is already given, mass one the 10 to the power minus 30 da, velocity one the 2.21 into 10 to the power 6 da. So you can substitute and you can find the lambda. Now after that you can check which, the range of that wavelength is coming under which one, X-ray or infrared or gamma or visible. Done. No hurry, no, we are going for that only. So in the chapter, we will be doing few more questions. Adukapram we will be going for a very small break. Adukapram we will go for atom, nuclei as well as the what is a semiconductor and logic gates. Very good, very good. The answer will be X-rays. While we are substituting, I think you will be getting the lambda around 0.3. Correct? You are getting something around this, right? Yes, 3 into 10 to the power minus 10. Exactly. So 0.3 nanometer da varapora. 0.3 nanometer na adu vande X-ray la da vare. Okay. Aisha, few more questions. Da hardly vande 3-4 questions. Adukapram, as I mentioned, no, we can take 15 minutes of break. Okay. Even I am feeling hungry. I want to have something. So next question. A light source of wavelength lambda illuminates a metal surface and electrons are ejected with maximum kinetic energy of 2 electron volt. If the same surface is illuminated by a light source of wavelength lambda by 2, then the maximum kinetic energy of the ejected electrons will be. Okay. So in the question la simple arke direct arke. So first one the source oda wavelength one the hz by lambda da. Okay. And the maximum kinetic energy is given as 2 electron volt. And the work function one the 1 electron volt da. Okay va? So in the first case solumbodhu wavelength one the lambda da and we will be getting this value. On a second case, what is happening? This is coming as hc divided by lambda by 2, which will be coming as work function one the same same material, and the kinetic energy we need it, right? So we can just go for the kinetic energy. So in the question the hc by lambda you will be getting, just substitute, you are going to get the kinetic energy. Quickly. No issues, Hari, no issues, no issues. Very good, very good. So idilirundha we will be getting this value is 3 electron volt. Inga vanda substitute பண்ணும்போது 6 electron volt we will get. Now the kinetic energy we can just find it as 6 minus 1 electron volt, which will be 5. So now the answer is option A. Very good, very good. So now let us go for the next question. The work function of cesium and lithium metals are 1.9 and 2.5 respectively. If the incident light is having a wavelength 550 nanometer, the photoelectric effect is possible in the case of. So simply find the energy of the photon using this equation hc by lambda and just check the photon energy and the work function is having this relation. If this is satisfied, then definitely electron emission will happen. Otherwise, it won't happen. Quickly. Very good, Durai. Very, very, very good. Superb. So what is the energy we are getting? What is the energy we are getting? Energy of the photon. It will be coming as 2.25 electron volt. While we are substituting, we will be getting the energy of the photon 2.25. So, cesium, it will, electron emission will happen. Energy high. Ana lithium, it is not possible. 2.5 we have 2.25. So, we can say that cesium only. Hence, option D will be the right answer. Now, let us go for the another question. So in the question mudinjadukapram we can go for a break. Okay va? An electron in the ground state of the hydrogen atom has the orbital radius of 5.3 into 10 to the power minus 11 meter, while that for the electron in the third excited state is 8.48 into 10 to the power minus 10 meter, the ratio of de Broglie wavelength. Okay, so idu vandu konjam we will be discussing with the what to say nama chapter illada what to say atom chapter la irundhu we are looking for. So now in the case la we know that in the lambda wavelength na h by mv da. Also we will be using some concept from the atom. adila vandu second postulate na enna mvr which is equal to nh by 2 pi da. So idila irundha I'm just taking this r over here, so this will be nh by 2 pi r it will come. Now I'm going to substitute this mv over here, so h divided by nh into 2 into pi into r, h will be get cancelled, we will be getting 2 pi r by n it will come. Understood till this everybody? Yes or no? So actually vandu idu atom chapter la irundhu konjam concepts vandu we are utilizing here. So mv which is equal to nh by 2 pi r we are getting, yena mv ki vandu we need to substitute, and now we understood in the lambda vandu actually it is proportional to r by n da. So now the thing is like you know that ground state n value vandu 1 and the third excited state na n value vandu 4 ah irukum. Okay, so n1 is equal to 1, n2 is equal to 4, third excited state na 4 da value varapora. Next vandu radius oda I mean ratios kuda it is given. In the ground state la 5.3 da. So now vandu you can just go for lambda 1 divided by lambda 2, which will be coming as r1 by r2 into n2 by n1. All the values you can substitute and you can just tell me the answer quickly. So in the question mudinjana we are going for the break. Everybody do it. Yes, very good. Paravaillada, that is not at all a problem. So in the session order what to say the motive enna, those who are attending avangalukku vandu useful ah irukanum. I hope it is useful. Avloda, that is enough and more for me. So definitely we will be getting 4 as the answer. R1 na 5.3 into 10 to the power minus 11 divided by 8.48. Adu vandu you can just take it as 84.8 into 10 to the power minus 11. Yena and the powers vandu cancel agum. And n2 by n1 na inga vera poradhu n2 na 4 da, n1 na it is coming as 1 da. So while doing this you will be getting the answer as 4. Okay, so இதுதா வந்து dual natureல இன்னும் கொஞ்சம் கூட questions இருக்கேண்டா, but பரவாயில்லை, that we can just do it on the next day. And what is the time right now when we can just resume da? Tell me the timing. I wanted to know when you people will be free. Just need to take a proper break. I too wanted to have something. Resume at what time? இப்போ வந்து 6:50. So 7:15 will work. Is it okay for everybody? Yes or no? 7:10 it will work. Okay, yeah. 7:10. Okay. So thank you guys. Thank you so much. Bye bye. Okay. Let us see after 7:10. 7:20 idu lada 7:10. Sharp ah ninge varanum. Okay. Sorry guys, sorry. Let us continue. Everybody is here? Same, some Sasmita, right? Yes. Are you guys here? Yes or no? Please quickly let me know. With the heart, please let me know. Are you guys here? Just call Sasmi. Okay, Sasmi. I think I won't forget. Let's see. So everyone had a proper break. Larkume proper or break kadachirka. Had anything, everybody? Due to Sasmi and Aisha, I went for a shake. You people are making, change in my diet. So now onwards, I have fixed one thing. I'm not going to talk anything about food, snacks and all to you guys. Yes. So let us continue. Do you have the energy? Let us just go for atom and nuclei. Adukapra semiconductors, quickly. Yes. So tell me. Of course. Okay. So now we are going for atom, adukapra nuclei, adukapra semiconductors. Innekku indha session vanda we are going to wind up with that. Okay. So again electrostatics irukke, time irundichna we can just continue. Illanalum paravilla, some other day we can just continue. So whenever you are just going for 90 plus na unga target na in the complete 12th grade, you just focus panikoda, you can just finish it. Okay. Neria means, I'm not getting that word. Okay. So now just focus over here da. We are going for atom chapter. Atom chapter la we have the Thomson's model. So Thomson's model na inna plum pudding model da. Okay. Yes. Neria, right? I'm pronouncing it correct, right? Neria. Okay, I got it now. In Malayalam, we used to say niraye. Okay, so that slight change is there, I think, in pronunciation. Yeah. Okay. Let it be. Let us just come back. Let us just continue. So Thomson's model of atom. So idhula vandu paakumbodhu plum pudding model da, which means the charge is spreaded over the, ipo vandu inda pudding la plum irukra maadhiri da. Okay, plum irukra maadhiri da. Okay, so in the what to say, hey, just now only I had something, now they are talking about plum and all. Okay, let it be. So ipo vandu paakumbodhu we know that the positive charges is actually spreaded throughout the atom. Okay va. So idha vandu what Thomson's has suggested. Adukapram Rutherford's model atom, adula than namma alpha scattering experiment, okay, gold foil experiment irukke. So the experiment la irundha we get more clarity about the atom. Yeah, now you just imagine, you don't know, you didn't even see a person before, you didn't even talk to the person before. Ana vandu, I mean, someone is asking you to tell, okay, how that person looks or how the person talks. So we don't know anything about it. Correct ada? நமக்கு வந்து தெரியவே தெரியாது எப்படி இருக்கும் இல்லனா how the way the person used to talk ஒண்ணுமே தெரியாது. ஆனா suddenly somebody is asking you how this person is, or let's say how he looks or how she looks, இல்லனா how they were talking. So இதுக்கு வந்து definite clarity இல்ல. அந்த மாதிரி ஒரு மொமெண்ட்ல தான் atom, what is atom, now we know அதுக்குள்ள electrons இருக்கு, அதுக்குள்ள what is protons இருக்கு, எல்லாமே இருக்கு, ஆனாலும் கிளாரிட்டியே கிடையாது. கரெக்ட்டா? அதுக்கு வந்து ஒரு கிளாரிட்டி கிடையாது. So adilirundhu da nama Rutherford, Thomson's model, Bohr's model, everything came up. Okay, zero lirundhu da they made a structure for the atom, or they found the structure of the atom. So adula vanda first the turning point na adu vanda nothing but Rutherford oda gold foil experiment da. So adilirundhu he understood atomoda majority ana space vanda empty da, adukulla oru positive dense space irukke. So adha vanda we were calling it as nucleus, adukku vanda positive charge da, and electrons vanda it is just revolving around it. Ana he cannot discuss anything about the stability and spectrum. Okay va, stability and spectrum related he couldn't say anything about it. Adukapram we should learn another term that is nothing but distance of closest approach. Okay, distance of closest approach. Let us say inga oru nucleus irukke, inga oru nucleus irukke, idoda atomic number vandu z da, idoda atomic number vandu z2 da. So let us say idu vandu rest la da irukke. Now this is coming with a velocity v. Okay, so ipo vandu inga what I'm going to use is okay. I too know Malayalam da. Okay, so now the thing is like in the velocity irukella da. So in the velocity, I mean we are using energy conservation here. At the present state la, what is the total energy? Okay, tell me what is the total energy in the, I mean right now idu vandu rest la da irukke, and this is coming up with a velocity v na. What is the energy at this moment? Only in the kinetic energy mattum thana irukke. So adinala I can say that this will be nothing but half into m into v square. Half m v square da namma total energy in the moment la. Now what will happen? So ipo vandu it will reach us. Okay, in the nucleus vandu it will reach us at this point. Okay, in the nucleus vandu it will travel with a velocity v, and finally it will come to a distance r naught with the other nucleus. Okay, maybe it can be a nucleus, it can be an alpha particle, whatever it may be. So inga oru nucleus irukke, and the nucleus ku pakkathila ipo vandu another nucleus irukke. Okay va, ana konjam time ku appuram it will travel with the velocity v. Ana konjam time ku appuram what happened idu vandu rest la irukke, which means it started, I mean it came to rest. Idu vandu stop achu, which means the kinetic energy completely attained by this nucleus vandu sudden potential energy convert ஆருக்கு. Okay, so ஏனா இது வந்து ஒரு nucleus தான், இது கூட ஒரு nucleus தான். So அங்க ஒரு repulsion இருக்கும். அந்த repulsionனால what will happen in the nucleus க்கு it cannot come closer to it. So இதுக்கு வந்து ஒரு minimum distance இருக்குல்ல. Okay, so இத விட it cannot come, I mean it cannot cross this boundary. அதுதான் வந்து r naught. புரிஞ்சுதாடா? புரிஞ்சிருச்சுனா give me a quick heart quickly give me a heart. If you understood na, give me quickly a heart. What I said, so initially in the nucleus rest la irukke, and in the nucleus is coming with a velocity v, ana at some particular point, which means in the distance of separation vandu r naught agara point la this came to rest, which means kinetic energy converted as potential energy. Potential energy na k q1 q2 divided by r da. Now tell me in the case la what is q1, tell me quickly what is going to be q1 and q2. Tell me q1 na z1 into e da, correct? q2 na z2 into e da, so I'm just putting it as e square, and the distance of separation vanda it is nothing but r naught. In the equation la irundha you can find the distance of closest approach. Very good Arun, it is nothing but the distance of closest approach. R naught vanda it will be coming as distance of closest approach. Purinjudada? So this is, I mean from this equation you can go for distance of closest approach. Dadada vanda whatever I have written over here. Next one, another thing, Bohr's postulates da. Okay, Bohr is also find something about the atoms. So adila irundha first point enna, okay, first point enna, definitely ipo vandu we know that in the electrons is actually okay, so what is happening right now? When the electron is actually revolving around the nucleus, usually what should happen? If this is rotating, appadina it should radiate some energy and finally it will fall to the nucleus. correct? That is not happening. So according to Bohr, he is saying that இந்த electron வந்து எப்பவுமே ஒரு fixed energy level இருக்கும். It will always move in a fixed orbit. Okay, அந்த fixed orbitக்கு fixed energy இருக்கு. அந்த எனர்ஜில இல்லனா அந்த orbitல தான் எப்பவுமே இந்த electrons வந்து rotate பண்ணும். So அதனால தான் இந்த stability, இந்த electron is actually not coming and falling on the nucleus. புரிஞ்சுதாடா everybody? Are you guys getting what I'm saying? Yes or no? Quickly tell me da. So what I said, so இப்போ வந்து Bohr-ஓட first postulate தான் I'm telling. இந்த electrons will revolve around the nucleus, correct தான். ஆனா இது வந்து ஒரு fixed orbitல தான் it will rotate. Okay, ஒரு fixed orbitல தான் it will rotate, and definitely அந்த momentல it is not going to radiate any sort of energy. Now the second postulate, okay, second postulate வந்து let us say இப்போ வந்து இந்த nucleus is revolve பண்ணி இந்த electron is moving, right? அப்படினா அது வந்து ஒரு circular motion, circular motion இல்லடா. அப்படினா அந்த circular motionல definitely circular motionல which type of force should be the centripetal force இருக்கணும், கரெக்ட்டா? Centripetal force mv²/r இருக்கணும், கரெக்ட் இல்லடா? சோ இப்போ வந்து ஒரு சர்க்குலர் மோஷன் இருந்துச்சுனா அதுல வந்து ஒரு சென்ட்ரிபெட்டல் ஃபோர்ஸ் இருக்கணும். அந்த சென்ட்ரிபெட்டல் ஃபோர்ஸ் தான் mv²/r, which is nothing but given by electrostatic force. Okay, electrostatic force தான் ஆக்சுவலா வந்து இந்த mv²/r is giving. புரிஞ்சுதாடா? நாளைக்கு வந்து 5 o'clock செஷன் இருக்கு, PYQs தான், not just 11th 12th இருக்கும். இன்னைக்கு வந்து we skipped a lot of questions. அந்த questions எல்லாமே வந்து we will do it tomorrow along with 11th grade topics. Okay வா? Got it? So now mv²/r will be equal to the electrostatic force da it will be providing centripetal force வந்து. PM da 5 AM and all, it is not works well for me. I'm really sorry. என்னால முடியாதுடா. How many of you will wake up at 5? Here. Tell me. 5 AM waking, early birds, any early birds? இல்லடா 5 PM. Any 5 AM students here? Or 3 AM students were there? Can you please let me know எப்போ வந்து நீங்க you will wake up? அது வந்து can you just let me know? Don't say 10 o'clock and all. Okay. 4 AM Ajay. Okay. Oh my God. Others. And make sure every time you are sleeping at least 6 hours. Okay. Paravalla Samzi. It is, like if you are sleeping at 3 na, definitely 10, 9 o'clock ellame vandu okay da. 5 AM, very good Arun, very good. So, idu vandu make sure pannikoda ella dayslume you should sleep at least 6 hours. Yena adu vandu eventually it will affect our brain. Okay, so our brain will get tired. adukku vandu konjam rest irukanumda. Okay, it is not just about the thing that you are not what to say, you are not studying for the whole day. Aanalum the whole day your brain is working for studying or some other purpose. Okay, it's me 𝐂𝐴𝐾07. Sleep at 2 and 10, wake up at 10. You should wake up at 8. Okay, Ajay 11 to 4. Yeah, perfect. Arun 2 sleep and you will be wake up early. Oh my God, that doesn't work. Okay, so summa solrallada, it is actually the truth that it is not about your studying. The whole day you are just thinking something, you are doing something. So adanala anga vandu energy venumla, and the brain vandu it's working. So adukku vandu rest proper ah kodukanum, illana it is going to be a problem na. Yes Swati, very good. So now we got the second postulate. Third postulate வந்து, so இது வந்து it is moving in a circular path. அதுக்கு வந்து ஒரு angular momentum இருக்கும். Angular momentumத்தோட expression தான் mv. This will be, it is nothing but nh/2π இருக்கும். Okay, it will be nh/2π இருக்கும். Next one is nothing but, let us say இப்போ வந்து ஒரு electron இருக்கிறது வந்து அதோட ground stateல தான் இருக்கிறது. Okay, now this is what their excited state. இப்போ வந்து இந்த electron is in the ground state. If it needs to go to the higher energy level na, adukku vandu additional energy kadaikanumla. So definitely it will absorb a photon and it will go to the higher energy level. Are you guys getting it? Very good. I have written that only right here, nh/2π. Okay, so இப்போ வந்து what I said, so இப்போ வந்து ஒரு electron வந்து ஒரு stateல இருக்கு, energy stateல இருக்கு, அங்க இருந்து if it needs to, okay, if it needs to go to the higher energy level na, what will happen? So இது வந்து it should absorb a photon. So இப்போ வந்து the thing is like in the electron if it is going to the excited state na, and the moment it will try to come back, okay, and the moment it will try to come back, ஏனா அதுக்கு வந்து higher energy state la avlo time it cannot sit. Okay, so adanale it will reduce, or let's say it will just lose some energy and it will come back to the ground state. So now tell me da, losing energy means what we can say that ipo vanda higher energy level illa excited energy level la irukra or electrons ku vanda it needs to come back to the lower energy level na, it needs to lose some energy. Appadina how they are losing the energy? Tell me quickly how they are losing the energy. Everybody tell me. So ipo vanda if it needs to go to higher energy level na, absorbing the photon. Appadina if it needs to come back na, it should release a photon. Okay, it should release, yes Pooja, loss of energy da, and that is due to, and that is how it is happening, yes, emission of energy in the form of photon. அப்படினா I'm going to write the another relation. Photon ஓட energy ஓட equation என்னடா? h𝛎 இல்ல. So h𝛎 will be equal to E2 minus E1, or let's say hc by lambda will be equal to delta E. So if it needs to go from a ground to the higher energy state na, அதுக்கு வந்து extra energy கிடைக்கணும். அதுக்காக it will observe a, it will absorb a photon. If it is at the higher energy state needs to come back na, it will definitely release a photon, and the release ஆகிற photon da அதோட energy da hc by lambda. Okay, got it? Everybody understood? மறக்காம லைக் பண்ணிக்கோடா everybody. So இதுதான் வந்து ஆட்டத்துல we just need to study the Bohr's postulate da. So first one வந்து VZ இதுக்கு வந்து stability. Okay, stability சொல்லும்போது it will always go in a fixed energy, or let's say it will always go in a fixed orbit. அங்க அது வந்து energy radiate பண்ணாத. So next one வந்து இந்த what is in the centripetal forces provided by the electrostatic force da. And third one வந்து it is nothing but the angular momentum will be equal to nh by 2 pi da. And fourth point வந்து when it is really, when it is going from lower to higher or higher to lower na, it should absorb or release a photon. So h𝛎 will be coming as the change in energy levels. Understood na? Give me a heart quickly da. Everybody give me a heart quickly. Quickly give me a heart. Yes, done. So இதுதான் வந்து பேசிக்கா postulateல இருக்கு. Now the thing is like okay, now the thing is like we are just going for writing the radius of the orbit. இப்போ வந்து if I'm saying nth orbit இல்லனா second orbit, third orbit, and third orbit la what is the radius of the electrons? Okay, electrons will be revolving in a circular path. அதோட what to say okay reels vanda after May 3rd kapram we can watch da. Right now you can just watch the lectures please. Okay va? So now what I said, listen carefully. So in the radius of the orbit da we need to find it. So adukkaga we can just go for the relation. I did all the calculation and everything, ana vandu final result da we need to focus. Okay, so in the radius of the nth orbit, okay, radius at the nth orbit will be coming as 0.53 Armstrong into n square by z. So ipo vandu I'm saying fifth orbit na, you can go for 5 square divided by z. புரிஞ்சுதாடா? So அந்த மாதிரி velocityக்கு கூட ஒரு ரிலேஷன் இருக்கு. Velocity will be proportional to nth orbitல இருக்கிற எலக்ட்ரானோட what to say, the velocity வந்து it will be proportional to z by n. And next one the energy da, total energy will be minus 13.6 z square divided by n square da. So in the relations ellame vandu you should study. How we are getting it is very simple. We are just studying, getting it from the Bohr's postulates da. Ana in the relations just focus panikoda, the radius is actually proportional to n square by z, velocity is proportional to z by n, energy is proportional to z square by n square. Purinjidada everybody? Everybody got it? Yes or no? Please let me know. Please let me know. Yes, minus 13.6 divided by n square, it will come for the hydrogen. Yena z value will be coming as 1. No. Okay, yes, Pooja, very good, very good. 0.53 Armstrong into n square. Okay, I know that you, you are struggling a little bit to give the powers and everything. Okay, Sasmita, now onwards you cannot just get it. Okay, so now we got all the relations. Next in the energy, we have kinetic energy, we have potential energy, we have this total energy. So, this relation we should know. So, in the kinetic energy, இது வந்து எப்பவுமே ஒரு positive value இருக்கும். Potential energy and total energy will be negative இருக்கும். First point. Next வந்து இந்த kinetic energy and total energy ங்கிறது it is very simple. Minus of kinetic energy தான் இந்த total energy, and definitely total energy and potential energy will be having a relation that it will be U by 2, or let's say 2 times total energy தான் நம்ம potential energy, and minus 2k times the potential energy in terms of kinetic energy. In the relations வந்து புரிஞ்சுக்கோடா. What I said, kinetic energy will be equal to total energy. Ana the total energy will be a negative value of kinetic energy. Next வந்து potential energy da. Potential energy வந்து 2k. Okay, minus 2k. Illana you can say 2 times the total energy. Total energy yena in the potential energy and total energy வந்து negative இருக்கும். So அதனால you don't need to keep the negative sign. ஆனா வந்து when it comes to kinetic energy na, you should keep the negative sign. Got it everybody? Got it everybody? அவங்க வந்து பண்ணாத துரை. I don't know. They are becoming more and more selfish. I don't know in the likes வச்சு what they are doing. I don't know. இப்போ வந்து கேட்டுட்டேனா they won't give. Okay, let it be. I don't care. Okay, எனக்கு வந்து அவ்ளோ what to say, I don't feel bad. Okay, I'm happy only. Okay, so now we got all the relations. Now let us go for the next segment, which is related to the energy. Okay, so இப்போ வந்து kinetic energy ஓட expression, potential energy ஓட expression, total energy expression எல்லாமே வந்து I have written over here. And finally இந்த total energy ஓட equation வரப்போறது minus 13.6 z square divided by n square இருக்கும். Okay வாடா. So next வந்து time period தான். So இப்போ வந்து இந்த electron is revolving, right? So அப்படினா அதுக்கு வந்து to complete one circle it will take some time. So அந்த time period வந்து it will be coming as 2 pi divided by omega n, angular velocity. And finally we will be getting this relation in the time period will be proportional to n cube divided by z square. புரிஞ்சுதாடா everybody? n cube divided by z square. And the angular frequency and the angular velocity will be z square divided by n cube it will come. Got it? Next one you should know what is absorption spectra, what is emission spectra. Okay va? So now the thing is like let us say we are going to, okay, not we, electrons vanda. Okay, z na atomic number da. Okay, z na atomic number. Understood Aisha? Okay, so guys, like okay, so now I'm talking about absorption spectra, which means when an electron is jumping from a lower energy level to the higher energy level na, adula வந்து அந்த momentல it will release, okay, it will release some of the, or let's say I mean due to that there will be a spectrum. அதுதா வந்து we will be call it as absorption spectrum. Electrons absorb a photon and it goes to the higher orbit. அந்த momentல இருக்கிற spectrum the absorption spectrum. Now you guys can tell me what is the emission spectrum. When definitely higher energy state la irukra electrons வந்து it wants to jump and it wants to come back to the lower energy level, அந்த momentல it will release a photon. அந்த momentல இருக்கிற spectral lines வந்து we will be call it as emission spectra. Okay, photon emit பண்ணும்போது emission spectra, photon absorb பண்ணும்போது absorption spectra. Understood everybody? Are you guys getting it? Yes or no? Quickly tell me da. Give me a quick heart if you understood about this absorption. Yes, Arun. Electron E jump to lower state, so definitely photon release agum. Laws of energy, yes, very good, very good, very good. அது எனக்கு புரியல. Okay, so now we got all these things. Next one, we know that we have studied one thing. Okay, we have studied one thing. Just observe here what we have mentioned in the hc by lambda. Okay, hc by lambda na, it is nothing but delta E. Delta E na ennada minus 13.6 z square by n square da. So idhula vandu paakumbodhu for hydrogen z square vandu it is going to be 1. Appadina I'm just going to rewrite it for hydrogen minus 13.6 1 by nf square minus 1 by ni square. Now if I'm multiplying this negative sign inside, okay, I'm just multiplying the negative sign inside, I will be getting hc by lambda which is equal to 13.6 1 by ni square minus 1 by nf square. What is ni square? Initial, ni na initial energy level and nf na final energy level. Got it, everybody? Everybody understood? Now the thing is like I'm taking this hc over here. Okay, I'm taking this hc over here. Appadina I will be getting 1 by lambda. This 13.6 divided by hc, we will call it as the Rydberg constant, which will be, Rydberg constant R into 1 by ni square minus 1 by nf square. So, இப்போ வந்து இந்த emission spectral, if you need to know the wavelength which is emitted, na, அதுக்கு வந்து you can use this equation. Okay va? Simple இருக்கேண்டா, simple தான் இருக்கு. Energy equation என்ன? Minus 13.6 into z square by n square. அப்படினா I'm talking about hydrogen atom. Hydrogen atom na in the z square value என்னடா Isha, tell me. What is the z square value for a hydrogen? இது வந்து 1 ஆகும்ல. அப்படினா can I say that in the hc by lambda, which means in the time it will release a photon, right? And the photon energy na hc by lambda la. Previous chapter la we have studied, which will be equal to 13.6 into E2 minus E1 da. So while we are multiplying this negative sign, I will be getting 1 by ni square into 1 by nf square. So idu vandu use panni, yes, for our 1.009 or 1.1 you can choose into 10 to the power 7 da. Okay, so now in the equation use panni, you can just go for finding the lambda. In the hc vandu in the side la varumbodhu this will be coming as r. Ipo vandu apart from hydrogen, if we are going for any other atom na, there is only one change. You just need to put a z square over here. Okay va? Got it, everybody? You can just go for the z square along with this equation. 1 by lambda will be equal to rz square into 1 by ni square minus 1 by nf square it will come when it is not hydrogen atom. Hydrogen atom na in the z value will be coming as 1. Sorted, everybody? Everybody got it? So now we should know for a hydrogen atom, when this electron is coming from any energy state to the ground state. Okay, ground state na final energy level vanda, it will be coming as 1. Okay va? So ipa vandu in the hydrogen spectrathila I'm talking about, ipa vandu it is coming, electrode is jumping from a larger, okay, infinity lirundu kuda it can come to the ground state. அப்படினா nf will be coming as 1. Okay va? Ni ingiradhu it can be from the first excited state, which means n is equal to 1. Okay, which means just observe here da. So இப்படி தான் இந்த energy levels இருக்கும். So இதுதான் வந்து நம்ம ground state வந்து represent பண்றது n is equal to 1 தான். First excited state வந்து n is equal to 2 தான். Second excited state வந்து n is equal to 3 தான். Okay வா? So now the thing is like what I said, இப்போ வந்து இந்த electron, okay, it can come from infinity to this ground level. Okay, so இப்போ வந்து இங்க இருந்து கூட it can come and it can come from this to the ground level, it can come from this to this ground level, which means n is equal to 2. அங்க இருந்து ஏதாச்சும் ஸ்டேட்ல இருந்து it can come to the ground state na, definitely அந்த டைம்ல it will producing some spectral lines. Together we will call it as Lyman series. Okay va? So in the madri, if it is coming to the first excited level, which means n is equal to 2 it will be coming from infinity or some other, and it is coming to n is equal to 2. Final energy state வந்து 2 இருக்கும். அப்படினா அது வந்து we will call it as Balmer. Okay? And third one, nf is equal to 3 na, அது வந்து passion. And nf is equal to 4 na bracket, and n is equal to 5 na fun. Okay, which means in the 5th level, okay, illana 4th excited level like actually vanda in the electron is jumping. Okay va? And now the thing is like I made another column for it. Idu vanda you don't need to study and all. Yena idu vanda I have given I have substituted the values, which means I am assuming that இப்போ வந்து ஆக்சுவலா வந்து this electron is coming from infinity to the particular level. Lyman na I mean final state வந்து 1 இருக்கும், and Balmer na final state வந்து 2 இருக்கும். So அந்த மாதிரி infinity ல இருந்து அந்த particular level ல if it is coming na, அதோட lambda values தான் I have mentioned. Lambda வந்து இங்க பாக்கும்போது 1 by r தான், இங்க பாக்கும்போது 4 by r தான், here it is 9 by r, and the what is in the spectral lines ஓட range பார்க்கும்போது where it is coming under UV for Lyman, visible for the Balmer, and for passion it is infrared. For the rest it is coming as infrared only. Got it everybody? Got it everybody? Yes or no? So இதுதா வந்து another thing which you should study. Give me a hard die if you understood. Nobody is. Yes, I done. Number of spectral lines. இப்போ வந்து the ground state la varena. Okay, it is coming to the ground state na. You can just go for n into n minus 1 divided by 2. Okay, perfect. So அப்படினா one more thing that we should study. Okay, one more thing that you should study is, let us say இப்போ வந்து இங்க ஒரு atom இருக்கு. So அதுல வந்து I'm just mentioning இங்க வந்து ஒரு electron இருக்கு. Okay வா? இங்க வந்து ஒரு electron இருக்கு. So definitely we know that if this electron in the higher energy level இருந்து when it is going to the lower energy level na, it will release a photon. Correct? It will release a photon. After the class you can just check the comment box, they will update it. Okay, konjam like 5-10 minutes kapra you can just check the comment box, you will get the PDF. Everyone should take the PDF. And a few diagrams and everything ray optics la irundhu kuda I have kept it here. Okay, yes, after class check comment. Thank you Aisha. Description box la illada, only in comment box. Okay, so புரிஞ்சுக்க இது வந்து final topic in atom. Okay va? So now just understand. Okay, what we have said, இப்போ வந்து இந்த electron is jumping. Okay, it is actually going to any level, let it be. Okay, so இப்போ வந்து இந்த electron I mean if it is coming or it is going up or down, definitely இப்போ வந்து I'm just talking about emission of photon, which means இது வந்து high energy ல இருக்கு, it needs to come back. It needs to come to the lower energy level. Correct da? Thank you so much da. Thank you so much. Okay, so இப்போ வந்து it needs to come to the lower energy level. அப்படினா what is it? What is the process for it? இப்போ வந்து ஒரு electronக்கு higher energy ல இருந்து lower energy ல வரணும்னா what is the process? What we have mentioned? Tell me da. Everybody tell me. Tell me quickly. It should release a photon, right? So the photon will be released when the atom is actually coming to a de-excited or let's say lower energy la pogumbodhu, we can see that a photon will be emitted. So idu vandu actually vandu I'm going to compare with the recoil speed of gun. Do you remember that? Do you remember recoil of gun? What is recoil of gun? So definitely bullet will move forward and the time what will happen to the gun? what will happen to the gun? Tell me, quickly tell me da. What will happen to the gun? If one the bullet is moving forward, what will happen to the gun? According to the conservation of momentum, this gun will move back with the velocity v. Okay, now paravaillada, I just wanted to finish till semiconductors. Adudha vandu yen target. Okay, by 9 o'clock we should finish everything. So idhula vandu problems vandu naalaiki pannalamda. I mean the semiconductor kuda we can finish in this session. Content vandu we can finish, questions vandu naalaiki pannalam. Very good, very good. The gun will actually move backwards. Okay va? So now exactly the similar way. Think about this atom. Okay va? So in the atomilirundhu actually ஒரு photon வந்து it is moving like this. அப்படினா this atom, okay, இந்த photon na bullet மாதிரி, atom na இந்த what to say gun மாதிரி. அப்படினா photon is moving forward. அப்படினா what will happen to the atom? It will move back. Correct ஆடா? Are you guys getting it? So இப்போ வந்து ஒரு atom இருக்கு, அதில் இருக்கிற ஒரு electron வந்து actually it is emitting a photon na, I mean photon will move in this way and this atom will move backwards. Okay va? So according to law of conservation of momentum, tell me what is the initial stage la? We know that zero the momentum irukku, zero da, ஏனா இந்த atom and also in the photon வந்து rest la da irukku. Initially it was coming as zero. Finally what will happen? We said in the momentumukku, I mean in the what to say photonukku momentum irukku. What is the momentum value? Tell me what is the momentum of photon? You know it, previous chapter dual nature la we have studied. Quickly tell me da. Oh my god, I mean I have a problem while I'm talking. My speed is already 2x. That is the problem that everyone should highlight, and now you are just putting in 2x na. Okay, so now noda photon oda momentum adu vandu particle oda momentum, photon momentum, it is nothing but h by lambda. Momentum of the photon is nothing but h by lambda, illena e by c. Okay va? So now talking about the gun, illena talking about the atom in this case, idoda mass vandu m da, velocity vandu, the recoil velocity vandu I am considering v. அப்படினா I will be getting mv plus h by lambda, which means mv which is equal to h by lambda, which means v will be equal to h by lambda into m. Negative sign indicates photon oda direction as well as in the atom oda direction வந்து exactly opposite ஆ இருக்கு. So இதுதான் வந்து the recoil of atom. புரிஞ்சுதாடா? Everybody understood? Yes or no? Yes or no? Everybody tell me. Did you guys understood what I said? அப்படினா we can just what to say, நம்ம officially we can say atom முடிஞ்சது. Pakka, perfect. So now let us go for nuclei. Nuclei வந்து 5 minutes la I will finish. Okay, so nuclei. Okay va? So listen carefully. So idhula vandu first representations ellame vandu I have written over here. So just focus. So idudha vandu namma what is the representation. Idhula vandu A. What is A representing? What is A and Z? Tell me. What is A and Z? Tell me. A ina it is nothing but mass number da. Okay, it is nothing but mass number. Z na it is nothing but atomic number. Okay, now you should know one thing. In the atomic number is given na, what are the datas you are getting? Atomic number is given na, you should understand you are getting the number of electrons, you are getting the number of protons. Okay va? So Z is equal to number of electrons, number of protons, and mass number is representing what? Mass number is representing, tell me quickly. In the mass number represent பண்றது என்ன? Number of nucleons da. என்னடா இந்த nucleons? Nucleons na இந்த nucleusக்குள்ள இருக்கிற teams da. Okay, nucleusக்குள்ள யார் இருக்குடா? Nucleusக்குள்ள யார் யார் இருக்கு? Yes, we have protons as well as neutrons. அப்படினா இந்த A வந்து I can write it as it is nothing but the number of protons plus number of neutrons. Mass number is representing the number of protons plus number of neutrons. Also I can say number of protons na, which is equal to number of electrons. So number of electrons plus number of neutrons kuda we can mention. Let it be there. Now if you need to know the number of neutrons, what is the equation? Number of neutrons theriyanumna, what is the equation? Quickly tell me da. It is nothing but A minus number of protons or A minus number of electrons, or let's say we can go for a very convenient thing, A minus Z. So if they have given A and Z value na, you can find the electrons order number, protons order number, as well as you can find what? The number of neutrons also. Very good. Like panikoda, share paniko. So in a few hours we are going to finish the marathon session. Okay va? Ipo evlo time achuda 8 o'clock na, 9 hours ஆச்சு. Okay, perfect. Okay, so now இன்னும் hardly 1 hour தான் இருக்கும், அதுக்குள்ள we will finish. So இப்போ வந்து இந்த representation எல்லாமே வந்து you got it. Next வந்து இந்த nucleus ஓட size தான் முக்கியமா இருக்கு. So இந்த nucleus ஓட size வந்து usually we will say about the radius. Okay, so அந்த radius connect பண்ற ஒரு equation என்னன்னா R is equal to R naught into 8 to the power 1 by 3. A னா again the mass number தான். Okay வா? Mass number raised to 1 by 3 it will come. R naught na, I could say it is 1 femtometer, which means 1.1 irukku. Ana calculation la adum podada, because that is going to be a hectic task. So now you just go for 10 to the power minus 15 meter, which means 1 femtometer. Okay va? Calculation ku ellame vanda adu podum. Okay, don't study because ena board exam ella mudinjiruchilla. So just focus on the simplified form. So the 1.1 ella thevilla, just go for 10 to the power minus 15, which means the 1 femtometer. Next on the density of nucleus da, adula vandu major ah theriya vendiya oru vishayam I will tell you. In the density of the nucleus vandu it is a constant value. Idu da vandu approximate value varapore. 3 into 10 to the power 17 kg meter per second da in the density oda value varapore. And now the fact is another important point in the density illada, it is not depending upon the mass number. Note paniko, in the density of the nucleus is not actually depending upon the mass number. Got it everybody? Everybody understood? Yes or no? Please let me know. Quickly you can give me a heart. Yes. So இதுதா வந்து நம்ம left hand side வந்து finish ஆச்சு. Next வந்து you should know what is 1 AMU. Okay, 1 AMU na enna? We are actually giving a new set of mass. Okay, illana what is in the mass represent பண்றத வந்து we are just doing in terms of AMU. அப்படினா thank you guys, thank you so much. Okay, so 1 AMU na, okay, 1 AMU na, it is nothing but the mass of 1 by 12th of the mass of the carbon 12 atom. அது வந்து approximately equal to mass of electron, mass of proton. Okay va? So அதோட value வந்து 1.66 into 10 to the power minus 27 da. And definitely according to Einstein, okay va? According to Einstein, there was one important relation. What is that? Energy mass relation. Ennada in the energy mass relation? Quickly tell me everybody. In the Einstein is mentioned about the energy mass relation. What it is representing? இப்போ வந்து எங்கேயாவது மாஸ்க்கு ஷார்ட்டேஜ் இருந்துடுச்சுனா, ஓகேவா? So what I said, Einstein oda what is a mass energy relation da I'm going to tell. What it is indicating? Simple da irukke. Simple na, இப்போ வந்து எங்கேயாவது ஒரு மாஸ்க்கு ஷார்ட்டேஜ் இருந்துச்சுனா, what you should understand, அந்த மாஸ் வந்து எனர்ஜியா கன்வெர்ட் ஆயிருக்கு. So இப்போ வந்து m மாஸ் இருக்கு, அந்த மாஸ்க்கு ஈக்குவலன்ட் ஆன எனர்ஜி வந்து it is nothing but m into c square. What is c? Tell me what is c? What is c da? Tell me. c na enna? C na enna? Speed of light da. Correct? Very good. Soma answers me. Arun, very good. So, இப்போ வந்து is equal to mc square we got. அப்படினா yes, velocity of light in vacuum 3 into 10 to the power 8. Very good. So now this is the case. Next thing is like இப்போ வந்து there is a mass 1 AMU mass வந்து ஷார்ட்டா இருக்கு. What is that? 1 AMU. So shortage இருக்கிற mass வந்து இல்லனா 1 AMU massக்கு equivalent ஆன energy கிடைக்கணும்னா I can go for this expression energy equivalent to 1 AMU mass will be coming as 931.5 mega electron volt. Important ஆன value தான் you should study. You cannot skip it. புரிஞ்சுதாடா everybody? Yes, very good. 931 mega electron kuda will work. That is fine, Pooja. Okay, va? So the energy equivalent to 1 AMU mass was the 931.5 mega electron volt. Now I am just asking you, hey guys, so ipo enkita 5 AMU mass irukku. So adukku equivalent ana energy enada அப்படிங்கறத definitely you will do what? 5 into 931 you will do. Right, 5 into 931. So suddenly I am saying 10 AMU mass irukku adukku equivalent ana energy enna? What you will do? You will just multiply this 931 into 10. Purinjudada everybody? So now the thing is like, why we are studying this here? அதுக்கு வந்து ஒரு ரீசன் இருக்கணும்ல. Yes, very good. Okay, so அதுக்கு வந்து ஒரு ரீசன் இருக்கணும். Why we are studying, அதுக்கு வந்து ரீசன் இருக்கணும். So இங்க பாக்கும்போது இந்த ரீசன் என்னன்னா, definitely ஒரு நியூக்ளியஸ். Okay, if I am talking about nucleus, அதுக்குள்ள protons இருக்கும், neutrons இருக்கும். கரெக்ட் இல்ல? So அப்படினா அந்த mass of the nucleus ங்கிறது what is supposed to be the mass? In the total mass of the, okay, total mass of the proton plus the total mass of the neutron. இதுதா வந்து actually அந்த nucleus ஓட எனர்ஜியா இருக்கணும். ஆனா tell me what is the total mass of proton? What is the total mass of proton? Quickly tell me what is the total mass of proton and total mass of neutron. How we will be finding it? We know, if you know mass of one proton is, I am taking it as mp. அப்படினா number of protons into mass of proton will give the total mass. அப்படினா I can say that number of protons na அது வந்து equal to z da. And coming to total mass of neutron, now you can just tell me what is going to be the total mass of neutron. What is going to be that? Quickly tell me, what is going to be that? Tell me everybody. What is going to be that? It is nothing but A minus Z. Okay, A minus Z. ஏனா number of neutrons வந்து A minus Z da into mass of neutron. புரிஞ்சுதாடா? Of course da. No restriction for everyone. உனக்கு வந்து wherever you want to go and you can study, there is no problem. You go and study. So இதுதா வந்து actually total mass of the nucleus வரணும். Now what I said, what I'm doing, I found the mass of the nucleus. Okay, capital M na என்னடா? Mass of the nucleus da. Okay, mass of the nucleus da. ஆனா இங்க ஒரு shortage இருக்கு. These two values are not matching. Logically speaking, this value should be equal to mass of the nucleus, right? ஆனா அது இல்ல. So there is a shortage, which means இந்த mass வந்து high இருக்கு. இந்த நியூக்ளியஸோட total mass வந்து calculate பண்ணும்போது அது இன்னும் கம்மியா இருக்கு. So அதனால I am just getting to know there is a mass defect. Mass defect na mass of the nucleons. Okay, mass of the nucleons minus mass of the nucleus. இதுதா வந்து mass defect. So in the mass defect na I am substituting this and I will be getting this equation A minus Z into Mn plus ZMP minus mass of the nucleus. இதுதா வந்து the defect in mass. And in the defect in mass enga poda, I mean where is the delta M? Now you know, connect with Einstein's energy relation. So what is happening in the delta M vanda, it is actually converted as the energy. Purinjudada everybody? Yes or no? Quickly tell me, are you guys getting what I'm saying? Tell me da. Yes. So in the delta M is actually converted as energy. So இதுக்கு தான் இந்த எனர்ஜி தேவையா இருக்கு. நியூக்ளியஸுக்கு வந்து they need this much of energy. அது வந்து definitely இந்த நியூட்ரான் புரோட்டான் எல்லாத்தையுமே க்ளோஸா it needs to hold, right? Okay. So அதுக்கு வந்து கொஞ்சம் எனர்ஜி இருக்கணும். இந்த புரோட்டான்ஸ் இந்த நியூட்ரான்ஸ் எல்லாமே வந்து க்ளோஸா ஹோல்ட் பண்ணனும்னா அதுக்கு வந்து கொஞ்சம் எனர்ஜி இருக்கணும். அந்த எனர்ஜி தான் we are calling it as binding energy. What is binding energy? And the energy, if you are giving that much of energy na mattunda edachi I mean neutron illana proton na vandu you can just take it from there, which means to hold all these nucleons the nucleus has to apply, or let's say it should exert some energy, or it should have some energy. Adudha vandu binding energy. And the binding energy if you are giving na definitely and the nucleons vandu you can just separate it. Okay va? So ipo vandu if I am saying binding energy per nucleon and the madri or value if I am saying na and the value high na it is very difficult. Okay, avlo energy we need to give to take one neutron. Correcta appadina binding energy per nucleon is more, which means what is the meaning? Definitely adu vandu more stable ah irukku. Binding energy per nucleon is very high, which means what is that indicating? It is actually indicating stability. Okay va? So now the thing is like the most stable one is nothing but our iron tha. Okay va? Next one, when we are talking about the lower mass number elements, okay, illana lower mass number irukra nucleus patti, I mean if you are just talking about that na, what will happen? Adukku vandu less stable ah irukku. Okay va? So the thing is like in the lower mass number irukra nucleus vandu it needs to come to the higher energy level na, what they are supposed to do? Can you just give me an idea about it? What we can do? Ipo vandu in the lower mass number irukra nucleus vandu it wants to come to the stable energy level. Appadina adu vandu what it is supposed to do? It should actually combine, or let's say it should keep a friend, which means adu vandu fuse pananum. I mean it can just combine with any other element and it can come to the stable state. Adudha vandu fusion. Okay, that is what we are saying, fusion. Very good. So ipo vandu higher mass number irukra nucleus irukum. Adukku vandu stable state la varanumna it will split and it will come to the stable state. Adudha vandu we are calling it as the fission. Understood everybody? Adudha vandu we are calling it as fusion and fission. So all the details, everything important on informations vandu I have added here. Nuclear fission sollumbodhu splitting the fusion na fuse பண்ணிருக்கேன். Okay, so lighter nuclei will combine and it will come to the stable state. And idhula vandu paakumbodhu in the fusion la high energy will be released comparing with the fusion. Okay va? High energy da release ah irukku. Are you guys getting it? Yes or no? Please let me know. Replay, you can just better go. Right now we are going for semiconductor. If you need semiconductor na, you can just stay back right now. The rest of the chapters you should watch replay. No other way. Okay, Yadish? Got it? Yes, done. In the chapter முடிஞ்சதுடா. Questions வந்து நாளைக்கு பண்ணலாம். Now let us go for the semiconductors. I have added a lots of questions and we cannot do it today. Let us start semiconductor. Adukapram we can just say bye bye. Logic gates irukoda, logic gates I will teach, then only I will go. Okay. So tell me, semiconductor start பண்ணலாமா? 5 minutes break needed ah? 5 minutes break is needed? Yes or no? Tell me everybody. No, let us continue then. So now semiconductors the chapter name. So adila vandu first na we should know about intrinsic and extrinsic semiconductor. Oh my god, I was thought like you will say break venum ma'am. Then I was ready for a 5 minutes break, but paravailada. Let me just sit here and I will take. Okay. So now the thing is like we were just going for the intrinsic and extrinsic semiconductor. Intrinsic semiconductor na enna? It is nothing but the pure semiconductor. Okay, in the fire la polamda. Okay, illada volume 2 mattum da. Okay, volume 1 வந்து recent-ஆ we have done. You can just check the recent videos you can check. அதுல வந்து volume 1 ல இருக்கிற chapters வந்து majority we have done. But பரவாயில்ல, I will try to do one more marathon for the volume 1 chapters. Okay, let me just try to do it. Okay, ஏன்னா question practice அவ்வளோ important இன்னும் இந்த few days-ல. Okay வா? So அதனால தான் I'm just having a kind of reluctance to this marathon sessions for concept. Okay. So yes, let us continue. Okay. So now, Rohit, na illada question paper set பண்றது na illada, so அதனால என்னால சொல்ல முடியாது. Okay, so இப்போ வந்து why we are doing PYQs na அதோட motive we will be getting the pattern. Okay, so actually சொல்லும்போது இது வந்து another secret. Okay, so இந்த PYQs repeat பண்றது வந்து hardly வந்து இப்போ வந்து நீங்க வந்து you are doing 15 years of question paper. Okay, அதிலிருந்து 1 or 2 questions மட்டும் தான் repeat ஆக போறேன். That is what the one fact. Okay, but why ma'am in the 2 questions we are doing the இவ்ளோ number of questions, இவ்ளோ number of PYQs, we are doing it for 2, but அது இல்லடா pattern வந்து we can just get it. Okay, so similar patterns ல இருக்கிற questions வந்து we can expect. அதனால தான் we are doing PYQs. So அதனால 10-year question paper மட்டும் if you are doing na அதுக்கு வந்து I don't know how effective it is. Along with the concept, if you are doing na, definitely you can crack a good score, like even 90, 80, 90 and the range la you can just get it. Okay, done. So let us start semiconductor. Okay, so semiconductor la intrinsic semiconductor na adoda meaning vanda it is nothing but the pure semiconductor. Okay, இப்போ வந்து germanium na germanium மட்டும் தான் இருக்கு, silicon na silicon மட்டும் தான் இருக்கு. Got it? So இதுதான் வந்து நம்ம semiconductorsல pure semiconductor இல்லனா whatever we are saying the intrinsic semiconductor. Now I'm talking about extrinsic semiconductor. Extrinsic semiconductor na அதுல வந்து impurities இருக்கும். ஏனா conductivity increase பண்றதுக்காக we are actually adding impurities. Okay, and the process we will be call it as, can you just tell me what is the process name? So in the impurities add பண்ற அந்த process ஓட name என்னடா? You guys know it. It is nothing but doping. Very good, Arun. Okay, so doping is the process, and the impurities we will call it as dopants. Okay, but process one the doping, and the thing which we are, or let's say whatever we are adding as an impurity, that one the dopants are. Okay, so this is what the thing. Now we are just going for the intrinsic and extrinsic semiconductor. So idhula vandu paakumbodhu you can see that இதுல வந்து compare பண்ணும்போது conductivity comparing with the extrinsic semiconductor less ஆ இருக்கும். ஏன்னா அதுல வந்து impurities add பண்ணும்ல, so அதனால வந்து அதுல இருக்கிற what to say இந்த conductivity வந்து it is going to be little high. So now just listen carefully da. Now in the intrinsic semiconductor la what actually doing, we are giving temperature, which means heat energy we will give. அப்படினா இப்போ வந்து இந்த சிலிக்கன் ஆட்டம் இருக்கு, அதுல வந்து 4 எலக்ட்ரான்ஸ், ஓகே 4 வேலன்ஸ் எலக்ட்ரான்ஸ் தான் இருக்கு. இது எல்லாமே வந்து கோவேலன்ட் பாண்ட்ல இருக்கும், கரெக்ட்டா? சோ இந்த இந்த வேலன்ஸ் எலக்ட்ரான் எல்லாமே வந்து it will be in a covalent bond. அப்படினா what will happen basically? Okay, what will happen basically? So when we are giving heat na, in the covalent bond will break. Okay, so இந்த covalent bond break ஆகும்னா அங்க ஒரு free electron இருக்கும். அப்ப அந்த free electron இருந்துச்சுனா அந்த ஸ்பேஸ் வந்து வேக்கன்ட் இல்ல, அந்த வேக்கன்ட் ஸ்பேஸ்க்கு யூசுவலா we will say அது வந்து ஒரு பாசிட்டிவ் சார்ஜ் தான், and பாசிட்டிவ் சார்ஜ்னாலும் we will call a separate name as holes. That free electrons and holes. So அப்படினா இந்த intrinsic semiconductorல எப்பவுமே வந்து இந்த holes and இந்த what to say electrons ஓட free electrons ஓட ratio இல்லனா அந்த number வந்து it is going to be same. Got it da? And also in the conductivity, okay, conductivity is due to these carriers. Okay, in the free electrons, in the what to say nama free hole, not free holes, it's the vacant space. So இதெல்லாமே வந்து தான் conductivity ல contribute பண்றது. Number வந்து same ஆ இருக்கு. Number of free electrons, very good Pooja. Number of free electrons is equal to number of holes தான். மறக்காம like பண்ணிக்கோ guys. Okay, and definitely we know that இதுல வந்து ஒரு current இருக்கும். Okay, So இதுல வந்து ஒரு current இருக்கும் ஏனா இதுல வந்து holes will also move, electrons will also move, and the total current வந்து okay அதுல வர total current வந்து it will be actually the sum of the flow of electrons and flow of holes. So the total current in the intrinsic semiconductor will be IE plus IH. ஏன்னா இதெல்லாமே வந்து same directionல இருக்கு. Done. Now, extrinsic semiconductor. Extrinsic semiconductor la we are adding the impurities and conductivity வந்து இன்னும் high-ஆ இருக்கும். ஏன்னா இந்த doping process we have mentioned no, அந்த process கூட high temperature-ல தான் it is happening. High temperature na we already know in the what to say in the covalent bond will break. Correct? Covalent bond will break. That will be there. Now the thing is like so அந்த மாதிரி இந்த temperature நால இந்த covalent break bond break ஆகி definitely holes and இந்த electrons இருக்கும். அதை விட இந்த impurities add பண்ணும்போது it will replace the silicon or it will replace the germanium and it will create the corresponding free electrons and holes. Got it? Conductivity வந்து it is going to be very very high comparing with the intrinsic semiconductor, and practical application க்கு வந்து we are usually using the extrinsic. ஏனா productivity அதிகமா இருக்கணும்ல, so அதனால extrinsic semiconductor தான் usually we will do. ஓகேவா? And in the caseல number of holes and number of what to say in the free electrons வந்து equal ஆகாது. Okay, it is it is not depending, it is not at all equal as like in intrinsic semiconductor. Now the thing is like we have P type as well as N type. Extrinsic semiconductor la we have two types, P and the N type. So P type na adila vandu positive irukkanum, which means holes vandu adhigama irukkanum. So which means the impurities illana the dopant vandu it is nothing but the trivalent atoms are, which means valence shell 3 electrons irukum. Appadina there will be lots of free spaces irukum, vacant spaces irukum, which means holes vandu adhigama irukum. Now talking about N type, N negativity na more number of negative charges, more number of free electrons. So definitely N type is done by adding impurity, which is nothing but the pentavalent group. Okay, valence shell la 5 electrons irukum. So whenever it is replacing the silicon or germanium, what will happen? There will be 1 electron will be illana free electrons vanda additional ah irukum. So now the thing is like ipo vandu if you are adding 5 impurities na anda 5 free electrons irukum. Okay, 10 impurities na 10 free electrons irukum. Okay, அப்படினா impurities, the number of impurities add பண்ணிட்டேனா increase பண்ணிட்டேனா conductivity will also increase. ஏனா charge carriers ஓட number கூட increase ஆக போற. Are you guys getting it? Are you guys getting it? Yes or no? Please quickly tell me. Quickly tell me da. Everybody getting it? So now we understood in the N type illana P type la whenever we are adding the number of impurities more na adula vand conductivity increase agum, yena charge carriers vand increase agum. Now the point is when I'm talking about this adding impurities, எனக்கு வந்து அவ்வளோ number of impurities add பண்ண முடியுமா? இல்ல. Okay, the range வந்து around 10 to the power 1 is to 10 to the power 8. இப்போ வந்து 10 to the power 8 is எனக்கு 1 impurity அப்படிதான் add பண்ண முடியும். Got it everybody? Everybody understood? Yes or no? Please let me know. Okay, so yes, this is what the important thing which we need to understand in the extrinsic semiconductor. N type irukke, P type irukke. N type la what is the major charge carrier da? Idu vandu electrons da. P type la what is the major charge carriers? Adu vandu nothing but the what? It is nothing but the holes. Got it everybody? Are you guys getting it? Okay, now next one is again very important, PN junction. PN junction na in the P type semiconductor, N type semiconductor, we will just keep it together. Okay va? So at the time la what will happen? So in the holes வந்து பாக்கும்போது இங்க electrons வந்து பாக்கும்போது இங்க positive charges. அப்படினா they will start interfere, or let's say they will just go like this. ஏனா இவங்களுக்கு attraction இருக்கு. Holesக்கு வந்து electronsக்கு வந்து holes attraction இருக்கு. So definitely what will happen? This will go, and what will happen on the junction? Eventually there will be a barrier formed, or let's say there will be a depletion layer formed. Okay, of the immobile ions, which means when I'm talking about the PN junction na, This is how the PN junction will be. Okay, so now the thing is like in the N side la konjam positive ions irukum and in the side la konjam negative ions irukum. Ana in the layer la irukra ivangalukku vandu it cannot move. Idu vandu immobile ah irukum. Okay, it will be immobile. So in the beginning stage la, which means I just kept it together. Okay, I just kept it together. And the moment what exactly happening? When I'm just keeping it together now, and the exactly and the moment in the electrons will move from N side to P side, and P side la irukra holes when it will move towards the N side. So adinale and the flow inale there will be a current, and the current that we are calling it as diffusion current. Purinjudada? And the majority charge carriers nale there will be a flow of electrons, there will be a flow of charges, and due to that current I will call it as diffusion current. Now when time goes, this barrier will become little bit thicker. Okay va? Or let's say the depletion layer oda width vandu adhigama irukum. So eventually even one electron is trying to come this side nalum, what will happen? This negative side will repel it. இப்போ வந்து இங்க இருந்து ஒரு பாசிட்டிவ் சார்ஜ் வந்து trying to comeனாலும் இந்த பாசிட்டிவ்னால அங்க இருந்து ஒரு ரிப்பல்ஷன் இருக்கும். Getting it? So now we understood at some point in the diffusion current will become zero. Okay va? And இங்க வந்து பாக்கும்போது there is an electric field formed. Okay, in the potential barrier nala there is an electric field which is formed, and the electric field nala now what will happen? Inga irukra minority charge carriers illada, as I mentioned in the P type and N type, and the doping process vanda high temperature la da it is happening. When it is happening in the high temperature, okay, when it is happening at the high temperature, of course covalent bond will break. Adanala konjam minority charge carriers irukumla. In the P type la vandu electrons da minority charge carriers, in the N type la vandu holes da minority charge carriers. In the minority charge carriers will start moving because of this electric field. And due to the minority charge carriers irukra current oda flow da whatever we are calling it as the what drift current. Okay, drift current. And the electric field produced in this case will be around 10 to the power 5 voltmeter, and width of the depletion layer will be coming as 10 to the power minus 6 meter. Okay, and for a germanium inga form aarikra barrier potential vandu 0.3 da, silicon ku vandu 0.7 da. So you should study all these points. Got it da everybody understood? Yes or no? Oh my god, water is over. Okay, so now we got this right. Now the thing is like I just wanted to bias it, which means I wanted to give an external battery. Okay, external potential, and what is the potential one I'm going to apply. So now let us say in the P type la positive and N type la vandu negative. This is what I'm saying, forward bias. P la positive, N la negative da I'm going to apply. And the moment la what will happen? If let us say இது வந்து ஒரு silicon da, okay, silicon இல்லனா germanium பரவாயில்லை, whatever it may be. So germaniumக்கு what I said in the potential barrier na 0.3 இல்லடா, இது வந்து 0.3 potential barrier வந்து 0.3. அப்படினா இங்க இருக்கிற electric field ஓட direction இப்படிதா, and due to the biasing electric field வந்து இந்த directionல இருக்கு. அப்படினா if I am giving, okay, இப்போ வந்து இது ஜெர்மேனியத்தோட PN junction தான், அப்படினா I am giving more than 0.3 in the forward biasing ல I am giving more than 0.3, then what will happen? Tell me da, what will happen? Logically think. இப்போ இங்க வந்து பாக்கும்போது இது வந்து 0.3 தான், opposite directionல I am giving more potential na, what will happen? In the depletion layer oda width vandu reduce, and definitely what will happen? Eventually the majority charge carriers will start flow. Okay, again we will be getting the current, and on the current vandu milliampere la da irukum. So if you are giving more than forward biasing la, if you are giving more than the potential barrier, for silicon it will be more than 0.7, for germanium it will be more than 0.3, then definitely what will happen da, there will be a rapid current flow when it is crosses, when it is more than 0.3 illana 0.7 vida, if you are giving during the forward biasing na rapid current growth irukum adu vandu milliampere la da irukum. Understood everybody? Marakama like panikoda, also share with your friends. So next வந்து reverse biasing la. Reverse biasing na என்னடா? we will be இதுதான் வந்து நம்ம PN junction. இந்த P side la I will be giving negative potential, N side la I will be giving the positive potential. So what will happen basically, in the depletion layer oda width வந்து increase ஆகும். At some point la it will get break. Okay, at some point la it will get break. And the moment la oru rapid oru growth irukum, and the current vandu it will be in microampere. So adukkaga actually vandu you should give 25 volt for the germanium, 35 volt for the silicon. Got it? So idudha vandu you should understand in the forward bias and the reverse bias case. So important ana points vandu I have added here. Next one the Zener breakdown da. Okay va? So adukku munadi can I just take a little bit of water, just 30 seconds I will come. Okay? Is it okay for everybody? Just let me take a cup of water. Will it be okay guys? Yes. So let me just quickly go and take the water and I will come. Sorry Kanna, so actually more than 30 seconds I took. I'm really sorry. Okay, so now the thing is like, let us just continue. And inneki vandu in the session nala actually vandu enakku what to say, I drank almost 4 liters of water. Okay, so yes, so now okay, let us continue. Zener breakdown, Zener diode that we are going to explain. Zener diode, it is a device which is working under reverse bias condition. Okay, highly doped, which means doping will be very high. Okay, and this will always work under the reverse bias. Reverse bias, we said that when it is coming in the okay. Now I share with my sister also. What da? Yes. இன்னைக்கு வந்து throat வந்து கொஞ்சம் ட்ரையா இருக்கு, அதனால தான் I was just drinking water multiple times and finally it was almost 4 liters and I'm so very happy for it. One second. Okay, So அப்படினா now the thing is like we were talking about the Zener diode. Zener diode na reverse bias la da work பண்ற போறேன். And reverse bias la breakdown region la. What we said breakdown. So when we are increasing the potential and the barrier potential will get break and the flow of current will happen, right? Illana flow of charges will happen, right? So அந்த point la da actually வந்து இந்த Zener diode work பண்ண போறேன். Okay, I mean அந்த point la actually வந்து current flow எவ்வளவு ஆனாலும் voltage வந்து constant ஆ இருக்கும். Okay, voltage, thank you so much Sasmi, thank you so much. Okay, so in the breakdown region la tha highly doped ah irukum and definitely what is இது வந்து அந்த breakdown region la voltage la avlo variation கிடையாது. It will be almost constant ஆனா current flow will be very large. This we can use it as okay, in the principle வந்து we can use it as for the voltage regulator, which means ஏதாச்சும் device இருந்துச்சுனா you can use a Zener diode parallel to it. அப்படினா அந்த deviceக்கு எப்பவுமே கிடைக்க வேண்டிய voltageங்கிறது it is nothing but இந்த Zener diode ஓட voltage ஆ இருக்கும். So doping change, I mean if you are changing the doping different voltage la you can just create the Zener diode as well. Okay va? So Zener diode வந்து அவ்வளவுதான் இருக்கு. So next வந்து we should go for the LED. LED na அது வந்து forward bias la work பண்ற ஒரு device தான். LED light emitting diode. Light வந்து இந்த I mean light as photons it will be emitted. Okay va? So basically it is happening like electrons from N side and holes from P side will recombine and on the time energy will be released in the form of photons and in the energy oda amount illana and the frequency oda variation la different colors vandu it will be producing. Idha vandu you should study in the case of light emitting diode. Next one வந்து photodiode தான். Photodiode is actually works in the reverse bias condition la தான் work பண்றேன். And also இந்த caseல இந்த light வந்து fall பண்ணணும். Okay வா? இந்த light should fall on the photodiode. So definitely இந்த electron hole pair form ஆகும். அந்த momentல definitely what will happen? There will be a current flow will also be there and that is what photodiode is works under the reverse bias and also idu vanda light is actually needed, light will fall on it and the electron hole pair will be there, the current will be produced. Okay va? So next one vanda nothing but our solar cell. Okay, solar cell nu சொல்லும்போது அதுக்கு வந்து we are not giving any biasing. In the solar cell use பண்றது கூட it is to produce the voltage. Okay, voltage produce பண்றதுக்கு தான் we are using in the solar cell. Okay வா? So இதுல வந்து P or N type ல ஏதாச்சும் ஒரு I mean either P or this N will be very thin and definitely what will happen in the in between இல்லையாடா. So இந்த PN junction அந்த junction வந்து large area இருக்கும் because ஏனா அவ்வளோ light வந்து it will fall and definitely productivity வந்து increase பண்ணலாம். So definitely solar cell வந்து work பண்றது இப்படிதான். We are not giving any biasing. Okay, external biasing எதுவும் இல்லை, which means we are not giving any additional external voltage வந்து we are not giving. Okay, understood? புரிஞ்சுதா? Ma'am, it is 8. What 8? I'm not getting. Next வந்து rectifier. Simple. Half wave rectifier இருக்கு, full wave rectifier இருக்கு. Yes, it is 8:30. I know. பரவாயில்லடா. இன்னும் hardly 30 minutesல we can finish. Okay வா? Simple அதாடா இருக்கு. Solar cellல external biasing எதுவும் we are not giving. அதனால வந்து we cannot say forward biasing இல்ல reverse biasing it is working. It is nothing something like that. ஆனா லைட் வந்து ஃபால் பண்ணும்போது ஓகே P டைப் இருக்கும் N டைப் இருக்கும்ல, இதுல வந்து either P or N வந்து தின்னா இருக்கும், அந்த PN junction ஏரியா வந்து கொஞ்சம் லார்ஜா இருக்கும் because that much number of or let's say that much amount of light will fall and definitely அந்த electron hole pair will be formed and it will be producing the current. Okay வா? So அந்த effectiveness இல்லனா productivity increase பண்றதுக்கு தான் we are actually giving that larger area. So basically photodiode ஓட same principle தான், electron hole pair will be formed. So அந்த point இல்ல definitely that will be creating the current and that is what the purpose of solar cell. Okay, hey, just let me finish this rectifier da, adukapra I can go for it. No worries, logic gate finish பண்றதுக்கு அப்புறம் தான் I will go. No worries. Okay, so இப்போ வந்து half wave rectifier இருக்கு. Okay va? Half wave rectifier na adula vandu only one diode da irukke. So edukada we are using rectifier. What is the purpose of rectifier? Basically speaking, ipo vandu what is in the input vandu it is having multiple direction illana adukku vandu positive and negative half cycle irukumla. So adu vandu unidirectional ஆக்குறதுக்கு. Okay, illana இந்த AC ல இருந்து DC கடக்கிறதுக்கு தான் we are actually using the rectifier. புரிஞ்சுதாடா? Now the thing is like in the AC to DC convert பண்ணும்போது why we are using this diode there? ஏனா unidirectional property of the diode தான் இங்க வந்து we are using it. Okay வா? Okay. So now வந்து what I said we got to know that in the diode unidirectional property da inga vandu use airukku. So in the half wave rectifier la the output frequency and input frequency vandu equal a irukum. Efficiency vandu 40.6% da. Okay, so idila vandu we will be just using the one transformer and one diode da we are using. So idila irundhu you will be getting only the output for positive half cycles. Okay va, புரிஞ்சுதாடா? So next one வந்து full wave rectifier da. So adula vandu we are actually using the center tapped. Okay, we are actually using the center tapped nama center tapped transformer da we are using. ஏனா இந்த இந்த input வரும்ல அதோட input ஓட effect வந்து இந்த next இப்போ வந்து this is what the first positive half cycle. Correct? That is what reaching to A. So anga vandu paakumbodhu diode vandu forward bias la irukke, so it will be giving you the output. Okay, positive half cycle ku vandu you will be getting the output. Now the thing is like what about B? So definitely in the center tapped transformer nala this in the input which is getting for B will be like this. Okay, adu vandu negative cycle la irukum. Appadina in the D2 will be in reverse bias, no current will flow. Got it? So this is what is happening. Now what is happening? We are talking about the first negative half cycle. So idudha vandu input for A. Okay va? And the moment la D1 will be reverse bias and it is not going to give any what output. Now in the negative half cycle at B, negative half cycle at B la what will happen da? What will happen? Definitely it will come ulta. Appadina this will become positive. Positive na D2 will be in the forward bias condition, and definitely we can say that will be giving the output. So definitely the effectiveness vandu romba high ah irukum, 81.2 the efficiency vara, and output frequency vandu 2 times the input frequency ah irukum. Got it? Drift current na minority charge carriers nala varapora current da drift current. Okay, purinjada everybody? Marakama like pannikoda and also share with your friends. Now we got the rectifier. Okay, that is over. Now not going for the questions vandu we can do it on tomorrow. So இதுதான் வந்து நம்ம logic gates, and அதுக்கப்புறம் we should also okay, one more point இருக்குடா, அதுக்கப்புறம் I will start the logic gates. Just give me a second. So இப்போ வந்து VZ na, okay, VZ na what we have mentioned. So இதுல வந்து பாக்கும்போது இந்த outputல AC ripples இருக்கும். Okay, அந்த ரா shape இருக்கும்ல. So அதனால okay, I don't know தமிழ்ல ரா மலையாளத்துல வந்து actually ரா வந்து you will be writing like this. அதனால தான் I have mentioned. Okay, so let it be. So இப்போ வந்து அந்த AC ripples இருக்கும்ல, அந்த AC ripples வந்து if you need to remove na, you can just connect a capacitor parallel to the device. Okay, அப்படினா AC ripples வந்து reduce பண்ணலாம். இல்லனா inductor வந்து you can just connect in the series mode also, which will be used as filters. Okay, I'm not getting Durai. Before also you said the same thing, ma'am. I shared with my sister also. What is that? I'm not getting it. Now logic gates. Logic gates la first one I will be going for OR gate. OR gate na, okay. Thank you. Thank you so much. Okay. So, we were discussing about the OR gate. OR gate la what is exactly happening? If you are giving A as 1, okay, if you are giving, so this is how we will be representing. Okay, so இதுதான் வந்து நம்ம representation. Okay, so இதுல வந்து பார்க்கும்போது A, B, இதுதான் வந்து input and this is what our output. So A, B இருக்கு and this Y will be coming as A plus B. புரிஞ்சுதாடா? A plus B it will come. So A is 1, B is 0. So A plus B na usually வந்து how we will be adding the number. 1 plus 0 na என்னடா? Yes, Hari, I am in Trishur. Okay, so what is the Y value? It will be coming as 1. So 0, 0, what it will come? What it will come? Certain, I mean, quickly you can tell me. Quickly. Ma'am, you are truly the best physics teacher. Was hard, but because of you, not anymore. Okay, thank you so much, Angio, right? Yes. So, இது வந்து 0 ஆக போற 1 1 1 1 னா 2 தான் ஆனா வந்து we don't have 2 0 or 1 மட்டும் தான் இருக்கு high னா அது வந்து representing 1. So now 0 1, so that will also come as 1. So இதுதான் வந்து output ஆ இருக்கும். Only for 0 0 we will be getting 0. Okay வா? So next வந்து AND gate தான் கரெக்ட்டா? AND gate na it will be coming like this. Okay, இதுதான் வந்து representation A B. இது வந்து multiplication A B இருக்கு Y இருக்கு 0 1 னா 0 into 1 0 தான் 1 0 னா 0 தான் 1 into 1 மட்டும் தான் 0 and 0 into 0 again 0. Got it? Everyone is putting 0 1 0 1 0 1. I'm not getting the answer, which answer you are saying, but let it be. I just wanted to make sure you people are getting it. Next one the NOT gate da. NOT gate na it will be like this. Okay, so what is it representing? A na A bar da varapore, which means if you are giving 0 na you will be getting 1. If you are giving 1 na you should get 0. Okay, so idha vandu three logic gates we have. Now I am going to tell about the universal logic gates. Okay va? What is this universal logic gates? Adana definitely NOR and the NAND da. Okay va? NOR and NAND da namma universal, which means in the two gates use panni we can create all the other gates. Okay, adanala da we are calling it as universal gate. Okay va? So in the NAND gate na what is exactly happening? So இதுதான் வந்து நம்ம AND gate. அதுக்குள்ள we will be giving a NOT gate. Okay, இதுதான் வந்து NAND gate. Done. Simple. Okay va? So now the thing is like we know AND gate oda result enna? It is nothing but A into B. Correct? A and B da. Correct alla? So adinala now what happened in the AB adukapram again what we should do, we should take the note of it. So this is what the output it will come. So ipa vandu you are giving 0 as A, B as 0. What is A dot B, which means AND gate will be giving you 0. Ana vanda we don't need 0. Actually what we need bar of it, which means 0 na if you got it na the final result will be A dot B bar da. So this will be coming as 1. Okay, now the thing is like idu vanda logic gates da. So ipo vanda in the switches, okay, sometimes you know that ipo vanda some lights, okay, which is in the ground floor la irukum, first floor la kuda irukum. So you know that you will be switching on here. Okay, and you can just switch it off from the upside, right? So adukellame vandha in the logic gates actually use pandrathu. Okay, in the switch work pandrathu ellame vandha in the logic gate use pannida. Now the thing is like I'm giving 1 1. What is A dot B? Illana A and B ennada? It will be coming as 1. Okay, ana output enna? It will be coming as 0. Now let us say 0 1. 0 1 na AND gate da, adinala the result will be 0 da, ana you will be getting bar of it. புரிஞ்சுதாடா? So இந்த மாதிரி we will be having NOR as well. NOR na enna? A plus B bar. Okay, so we know that OR gate la irundhu you will be getting A plus B and now you will be adding a NOT of it, which means A plus B bar. So if you are getting in the OR gate la irundhu if you are getting 0 na, what is going to be the answer? It will be coming as 1. Understood everybody? Yes or no? Are you guys getting it? Please let me know. So இது வந்து இன்னும் important ஆன another concept. You guys should learn this. Okay va? Directa they will ask this. Okay va? You can create all the rest of the gates. So idhula வந்து first I'm asking you NOT gate தான் எனக்கு வேணும். NAND gate use பண்ணி you should create a NOT gate. அப்படினா அந்த input வந்து same if you are giving na NAND gate க்கு வந்து input same na you will be getting the NOT of it. Okay va? You will be getting the NOT of it. Second one வந்து AND gate you need to get it from the NAND gate. அதுக்காக first வந்து you will be using the NAND gate. அதுக்கப்புறம் அதிலிருந்து வர result இல்லையாடா, that is what nothing but A dot B bar. Okay, அது வந்து same input for the second one which will be giving you the AND gate. So இந்த மாதிரி OR gate ல இருந்து NAND gate use பண்ணி you can just go for the OR gate as well. Okay, so idhula vandu the number of gates which is used and how it is applied idellame vandu you should study, and naளைக்கு the same things we will be do it as questions as well. Okay vada everybody, so these are the things which we should study in the case of logic gates. Logic gates la vandu innum I have added few more, a lot of questions I have added. Okay, so in the questions allame vandu we should do tomorrow, so definitely that will help you by getting a good confidence in the logic gates. Logic gates vandu avlo difficult allada, easy da, ana and the logic puriyanum. Got it everybody? So idha vandu innekke நாளைக்கு வந்து we will be going for PYQs in the chapter la. I think last 2-3 chapters oda PYQs வந்து questions வந்து practice பண்ணல. So next day, okay, நாளைக்கு 5 o'clock sharp I am expecting you people there. So நீங்க வந்து you have to come, you should attend the session and I will be there, and I want you people to be from the beginning, evening the class. Okay va? So from the beginning I want you people, you will be there or what? Yes or no? Promise me. Promise me. Lunch break few students has given a promise, adukapra I didn't even saw them. Okay, so அந்த மாதிரி promise illada. I know இது வந்து long marathon session da. I can also understand exhaust ஆகும் definitely. இப்போ வந்து when I'm just touching on my head also I'm just feeling something. Okay, talking for a long time, no, so adinala definitely, and listening for a long time வந்து இன்னும் energy வேணும். Okay, so as a student, okay, I can just tell you that இப்போ வந்து teacher I'm telling I'm taking a lot of work and I'm just getting tired, listening க்கு அது விட energy வேணும். Okay, whenever your parents are saying na like what to say, ma'am, parents will say, okay, you are not doing anything na, you are just studying, right? So you can just tell, okay, ungala vida adhigama brain use பண்ணிட்டு இருக்கேன். Okay va? So you can just better tell them. So adinala I know you will be very what to say, tired arkenu enakku theriyum. Yes Arun Prasad, I know from the beginning onwards you were there. Very good, very good. Okay va? So நாளைக்கு வந்து sharpa 5 o'clock we will be continue with the session, and I want all the people who you should attend the session. PYQs da last few days la question solve பண்றது வந்து அவ்ளோ முக்கியம்டா. Okay? Okay, so sorry mom. Okay, so see you guys, so we'll so we'll meet tomorrow. So bye in the chapter la irukra questions ellame vandu we can just discuss tomorrow, and we will be getting the confidence by tomorrow in the chapters whatever we have discussed today. So adila irundha 100 illana 120% confidence vandu you will make sure by tomorrow. So marakama attend pannikoda. Thank you so much for being with the session from the beginning. Okay, few students were from the beginning, they were there, so I'm very much happy and I'm very proud. Thank you so much guys. And also in the other energy level vanda you should maintain for other subjects and also other days as well, and I will expect every day. Okay, so thank you guys, thank you so much, and I want to know the feedback through comment box. I am literally waiting for it. So thank you so much. Bye, good night. So session notes you will be getting after the session. Just hold on for some 10-15 minutes. You will be get the PDF. Please download it and go through all the notes. It is not just about listening the class. It's all about you should study. You should have a self-study time. Okay? Thank you. Bye. So feedback, don't forget. I want the comment. I want to see it.